AWS Fargate is a serverless pay-per-use container computing engine that simplifies container management. It allows you to run containers without having to manage the underlying infrastructure, such as servers or clusters or EC2 instances. With Fargate, you can focus on building and deploying your application, while AWS manages securing and scaling the infrastructure. So, as you all know, this is a fully managed AWS service that allows you to run containerized applications on AWS without having to manage underlying servers or clusters. Whether you're using AWS Elastic Container Service or AKS or Elastic Kubernetes Service, Fargate abstracts infrastructure management and allows you to focus on developing and deploying your application. With Fargate, you only pay for the resources your container uses. This is our CPU and memory, and AWS automatically provides the appropriate infrastructure for you. This makes AWS Fargate a cost-effective and efficient solution for developers and businesses looking to simplify container management. Serverless computing is a model of cloud computing that allows developers to run code or applications without securing or managing underlying servers. Serverless computing abstracts infrastructure so that developers can focus on writing code and building applications instead of worrying about managing servers. AWS Fargate introduced the concept of serverless access for containers. Unlike traditional container services, where you have to manage EC2 instances and clusters, Fargate automatically allocates the computing resources needed to run your containers. It allows you to define your application's resources, just like we mentioned, CPU and memory, and then deal with the rest. A revolutionary aspect of AWS Fargate is that it completely removes the need to manage infrastructures, so it is a serverless. AWS Fargate comes with several powerful features that make it a top choice for managing containerized applications. Serverless container managers, so there is no need to manage servers. AWS Fargate automatically takes care of securing and scaling the infrastructure. Then you only pay for the computing and storage resources used by your containers. This allows for more cost-effective operations. It has seamless integration with ECS and AX. Fargate works seamlessly with these services, allowing you to use familiar AWS container orchestration services. Auto-scaling adjusts your resources based on your application needs, scaling them up and down depending on the traffic or demand. Also, when we talk about security and compliance, Fargate integrates with AWS security services such as IAM and VPC to ensure the security of your application and the protection of your data. So, let's learn about components of AWS Fargate. We have clusters. So clusters are logical group where tasks and services are organized in Fargate. We have task definitions. Task definitions are configuration files where users define containers and their settings for an application. They act as a blueprint for the Fargate application, specifying different parameters for containers. We have task. Task is just an instance of the task definition that is running. So users can create multiple tasks for the same task definition in your cluster, whether they run a single task or multitask at the same time. And services at the Fargate manage and run tasks. They can run multiple tasks at the same time and replace tasks if they fail or stop according to task definition. And finally, when do you want to use AWS Fargate? If you have heavy download or workloads with minimal effort, Fargate is ideal for managing heavy workloads with minimal manual intervention, infrastructure handling, scaling, and automatic monitoring. If you have some microservice application, it is perfect for deploying microservices, APIs and web application, as well as containerized AI and ML model, enabling seamless scaling and development. If you have small workload or with occasional spike, Fargate saves cost by efficiently scaling resources for applications that have low workloads and occasional sudden overloads in memory or CPU. It is very good and often used in batch job, so it's best for workloads that require batch processing. Fargate automates starting and stopping containers for group tasks, eliminating the need for manual management. So, let's recap this one. So Fargate is a truly powerful and useful service provided by AWS for container services. It helps users to save a lot of time, effort, and costs while using container services if the user is new to AWS and the concept of containers in AWS, then it is the tool to choose, as it helps to focus on just building the application rather than managing it. If you remember, if you go back to a few lessons before this, I already showed you how can you run Nginx server or Nginx image in our Fargate service. Once again, if you go inside our Elastic Container Service, you can see that we have this service, and once again, let's repeat how can we create our cluster. We can simply get the name for our cluster. Here we can choose infrastructure, you can choose Amazon EC2 instances or AWS Fargate, as you can see. Then if you choose Amazon instances, you can also create your autoscale group if you want, and here this is our Fargate and it uses serverless application. Then when you create your Fargate service or cluster configuration based on AWS Fargate, then you will, just to remind you, create task definition, and after that we will use this task. Here if you go to info, you can see what is a Fargate and what infrastructure this Fargate use. Also, there is a difference between Fargate, which is a serverless, and Amazon 2 instance. You can click on create this Fargate service, this cluster based on target service. And finally, after our cluster is provisioned, we can then go to task definition, create our task definition, add more information, and then if you go, as you already know, inside our cluster, we can also add this task to this cluster. Let's now once again go inside our cluster. I won't create task definition, and I don't want to run any task. Just want to show you once again this what we have in our cluster, and you can also update your cluster if you want. You can add more capacity, you can set up monitoring, and so on. Then you can add a new namespace, task definition, and so on. So just to remind you, it is very easy to run with Elastic Container Service. It is very easy to provision this service, and then it's very easy to run this. As you already know, now I will delete this cluster, so we need to copy this phrase and paste it here, and finally we will be able to delete this cluster that we just created. So once again, if you go to CloudFormation, you can track your stack or event, and here it is the complete progress of our configuration of our Fargate cluster, or our cluster based on Fargate. So we successfully deleted our cluster. One of the most important service or most used service in AWS is AWS Lambda. My goal is to present you all the important services in AWS. The only reason why I left Lambda to the end of this course is simplicity, and I didn't know where to put this, to be honest. So in the next couple of chapters we will learn how to work with Lambda. AWS Lambda is a serverless computing service that allows you to run code without securing or managing servers. It automatically manages the underlying infrastructure, including server, maintenance, scaling, and security patches. You only pay for the computing time you consume, making it a cost-effective solution for a variety of applications and backend services. AWS Lambda is a powerful serverless computing service that automatically runs code in response to events, without the need to manage the underlying infrastructure. It supports event-driven applications triggered by events such as HTTP requests, DynamoDB table updates, or state changes. Simply upload your code as .zip as file or container image, and Lambda handles everything from provisioning to scaling and maintenance. So it is pass service. It automatically scales application based on traffic, manage the server, auto-scales security patches, and monitoring. AWS Lambda is ideal for developers who want to focus on writing code without having to worry about infrastructure management. AWS is a serverless computing function that is fully managed by AWS, where developers can run their code without worrying about servers. Also, AWS Lambda features will allow you to run code without securing or managing any kind of server. When you upload the source code file to AWS Lambda in the form of a zip file, AWS Lambda will automatically run the code without the need to provide a server and will automatically scale your functions based on demand. AWS Lambda is mainly used for event-driven applications to process Amazon S3 bucket or card data or respond to some kind of HTTP request. So, the main thing about Lambda service is something called file processing. So, when you're using a Lambda, you can run using simple storage service. Whenever files are added to the S3 service, Lambda data processing will start. Then you can combine web applications and AWS Lambda, which will automatically scale based on incoming traffic. You can work with Internet of Things or IoT applications. So you can run AWS Lambda based on certain conditions while processing data from devices that are connected to IoT applications. It will analyze the data received from the IoT application. Lambda functions can be integrated with Amazon Kinesis to process streaming data in real time for application monitoring, log filtering, and so on. AWS Lambda will help you focus more on your code than on the underlying infrastructure. Infrastructure maintenance in AWS has been taken over by AWS Lambda. Well, if you want to use this service, there is a price, of course. First, we have something called request. AWS Lambda fees consist on the number of requests made to your Lambda function. Each event or request will be calculated individually based on the time duration, and AWS Lambda will calculate all requests made monthly. The price will vary depending on the region and the total number of requests made to your function. AWS Lambda will also be charged based on the time from the start of execution of your code to the time it is completed. Also, during the execution of the AWS Lambda function, you should allocate some memory to your function, so this factor also counts when billing comes around, of course. You have 1 million free requests per month, which is free for all users, and when it comes down to duration, you have 400 gigabytes of compute time per month. The free tier allows you up to 1 million calls per month at no charge. This covers a wide range of activities for light to moderate loads, as each function trigger counts as one call. So let's hop to our console and see how can we set up our first Lambda service. And if you go to search and simply type Lambda, you can see that we have a Lambda that is run code without thinking about servers. So this is a serverless option in AWS offer. Something like functions in Azure. And here you can see that we can run Lambda from scratch. Here you can see how it looks like. And you simply run your code, and this is our pricing. All that we already learned in our theoretical part. Of course, you can see how can you build your AWS step functions, what is Amazon SNS, and so on. So you have the option to click on create function. You can create one function and you can choose from different options. You can create one from scratch. You can use a blueprint or container image. If you have container, the only thing you need to do is to select a container image to deploy it to your function. Also, if you're using a blueprint, you can use a Lambda application from sample, code, and configuration presets for common use cases. And if you want to build from scratch, you can start simply by typing your name and by choose one of this latest supported languages, your runtime. Then you will choose your infrastructure or architecture that will run your function code. Here you can change your execution mode if you want, permissions, and there is some additional configurations like function URL, or if you have VPC you can connect this to VPC and so on. But as I already told you, if you have container, simply add your function name, add your container URI, and this link, for example, from Amazon ECR. If you remember, we already talked about ECR, and finally you can set this roles permission, add networking if you want, security and governance, and simply click on create. Finally, here if you want to use a blueprint, you have option to start with sample code, and here I want to, for example, choose my hello world function. This is a starter AWS Lambda function based on Python or Node.js, sorry. And here you can find different samples, and of course you can run hello world from Python, as you can see, that run on Python. Here I will add my function name. So runtime is Python 3.10. Our architecture is x86, as you can see. So I will add my name for this function. So let's try this service. Then we will choose our execution role that defines the permission of our function. You have option to create your custom function, new role with basic Lambda permissions. You can use existing roles or create a new AWS from AWS policy templates. We already know how can we create our role, but let me leave this as our role with basic Lambda permissions, because we are just learning. And here you can see this is our Lambda function code. This is a pre-configured code chosen by our blueprint. So let's hit on create function, and after some time our function will be created. So as you can see, this is our function, and we successfully create our function. Now if you want to invoke your function, simply choose test. As you can see, this is our function lambda underscore function dot py, which means Pythons. And here you can see that we have some definition. This is our received event for our key 1 and 3, and I want to this return of this event for key 1 echo back with the first key value. So if this function is successful, then it will return as some different value. So let me go to my test option, and I can also see that you can add your event name. So let me add function event, for example. Event sharing, you can choose between private and shareable. This is my template, and here I want to change this event, these values. So for the key 1, for example, I will add some different value. You can also, this is also a JSON file, as you can see, and then I will add something like my value is 11, my value is 22, and my value is 33 for my value. And we can save this. It is successfully saved, as you can see. And finally, let's hit on test. So we are executing our function, and here you can see how it looks like in functions preview. This is our Lambda function as you can see, and we are now testing our function. Let me go back to code. If I type test here, you can see that I need to scroll down to see my output, but if you click on deploy, you will deploy this function. And if I scroll down, you can see that our output status was succeeded. Test event name was F event, if you remember, and response is my value 11. So this is our function log where this started, and that's it. So our return event from our key 1 was value 11, if you remember. So echo back the first key value, and you can see all other duration. Build duration is 2 seconds, memory size, max memory is used is 31 megabyte, of course. And that's it. This is just a simple demonstration of how can you use your Lambda function and how can you set up and deploy this and test this. Now let me, for example, change this a little bit, and I will now try to deploy different, and we will see that when we test this again. So we are updating our function, and now as you can see we have error message, something went wrong, and that is exception. So now we made the change in our Python code, and we're getting an error, and we're getting that echo back that something went wrong. So you have this Lambda warning, unhandled exception, the most likely the return of our memory of our function is not right. So I will now unmark this and mark this raise, and once again if you run first deploy and then test your function, then it will once again return my value 11 for our key 1, if you remember. And that's it. This is the whole point of how can you mark or unmark some options, how can you deploy this script, this function, and that's it. This is just a simple demonstration and simple execution of this code. You can try it yourself. There is a lot of blueprint option, and you can choose a runtime, for example Python, Node.js, and so on. So if you go to test, here you can add some different events, change events. In the monitor option, source section, you can see this CloudWatch metrics, and this is our invocation, duration of how many seconds our execution lasted, and throttles, total concurrent exceptions, and so on. Many different logs. And here you can see our CloudWatch logs. So you get these columns, and you can see different values. For example, what is our log stream, most expensive invocation, recent invocation, duration in seconds. You can also use AWS X-Ray service. We already know what is X-Ray, and of course many different monitoring option in your Lambda. You can see Lambda Insight, Code Guru profiles, X-Ray traces, CloudWatch alerts, logs, and so on. And here you can edit some general information. You can choose your trigger or create a new trigger. You can add permission. If you want to add a new trigger, simply choose. Here is a whole list of this trigger configuration, and some trigger are AWS services and some are from different vendors. And finally, you can see a lot of options like permissions, destination, and our general configuration. Then we have something called aliases. You can create your alias, and here are our version of our Lambda function. So you can even public a new code if you want. But in general, this is how can you work with your function. I will now go to actions and delete this function because I don't want to work with this function anymore. Our demonstration is successful and now we are deleting our function. Thank you for watching, and I hope that this was helpful. So you can see what is our location, what is code storage, full account concurrency, and so on. And if we go to functions, you can see that we don't have any functions here. Also, there is some additional options here, but for now this is enough. So we are just getting we are only learn about this service. Thank you for watching. Amazon API Gateway is a fully managed AWS service that allows developers to create, publish, maintain, monitor, and secure APIs at any scale. It acts as a gateway for application handling tasks such as traffic management, authorization, access control, throttling, monitoring, and API versioning. Essentially, it acts as a reverse proxy that sits in front of backend services, such as AWS Lambda functions or other HTTP requests or endpoint, and manages client API requests. An API gateway allows you to define the APIs, including their methods like get, post, put, or delete, resources, and integration with backend services. It performs routing of incoming API requests to the appropriate backend service based on the rules you defined. API Gateway provides features such as authentication, authorization, and access control to secure your APIs. It integrates with AWS CloudWatch to provide metrics and logging for your APIs, helping you track performance and troubleshoot any kind of issues. You can manage different versions of your APIs, allowing for control deployment and updates. API Gateway support REST API, HTTP APIs, and WebSocket APIs. It can seamlessly integrate with services such as AWS Lambda, Amazon S3, DynamoDB, and others. So there is some advantages of using this service, like reduced complexity. It simplifies the process of building and managing APIs, handling many backend complexities. API Gateway is a scalable and reliable service designed to handle a large number of API calls. It helps optimize costs through efficient traffic and resource management, and you can use it for faster development by abstracting the complexity of the backend. It allows for faster development cycles. Essentially, an API Gateway acts as a central point for managing and securing your APIs, making it easy to build, deploy, and scale your application on AWS. Amazon Lightsail is a cloud service provided by AWS that simplifies the deployment and management of virtual private servers or VPS, databases, and other resources for individuals and businesses, especially those who are new to the world of cloud computing. It offers a cost-effective, predictable monthly pricing structure and consolidates resources such as memory, vCPU, storage, and data transfer into easy-to-use plans. Amazon Lightsail is the easiest way to get started with Amazon Web Services for anyone who needs to build a website or web application. It includes everything you need to get your projects up and run quickly, like instances or virtual private servers, container services, managed databases, content delivery network distributions or CDN distributions, load balancer, SSD-based block storage, static IP addresses, DNS management of registered domains, and resource snapshot or backups. It is at a low predictable monthly price. Lightsail also offers Amazon Lightsail for Research. With Lightsail for Research, academics and researchers can create powerful virtual machines in the AWS cloud. These virtual machines come with pre-installed research applications such as RStudio or Scilab. So, if you want to use instances in Light Service, you can, because Lightsail offers easy to configure virtual private service or instances that are backed by power and reliability of AWS. You can get your website, web application, or project up and running in minutes and manage your instance from the intuitive Lightsail console or API. As you create your instance, clicking on it, it will launch a simple operating system or OS, a pre-configured application, or a development stack such as WordPress, Windows, Plesk, LAMP, Nginx, and others. Each Lightsail instance comes with a pre-built or built-in firewall that you can use to allow or restrict traffic to your instances based on the source of IP address, port, and protocol. If you need to set up containers, you can do it in the Lightsail. You can run and securely access container as application in the cloud. A container is a standard unit of software that packages code and its dependencies together so that an application runs quickly and reliably from one computing environment to another. Also, you can route web traffic through your instances so that your website and application can accommodate variations in traffic, protect it from interruptions, and provide seamless experience for visitors. So there is an option to use load balancer also. You can use managed database. Lightsail offers a fully configured plan for MySQL or PostgreSQL database that includes memory, processing, storage, and allowable transfer. With Lightsail managed databases, you can easily scale your databases independently of your virtual servers, improve application availability, or run standalone databases in the cloud. You can also use both block and object storage. You can quickly and easily scale your storage with quickly available SSD supported storage for your Linux or Windows server virtual servers. With Lightsail object storage, you can store and retrieve objects at any time from anywhere on the internet. You can also host static content in the cloud. Then you can enable content delivery network or CDN distribution, which are built on the same infrastructure as Amazon CloudFront. You can easily distribute your content to a global audience by setting up proxy servers around the world, so users can access your website geographically closer to them, thereby reducing latency, of course. And Lightsail uses a focused set of features such as instances, managed databases, and load balancers to make it easy to get started. But that doesn't mean you are limited to these options. You can integrate your Lightsail project with one of over 90 other services in AWS via Amazon VPC peering. Lightsail is for everyone. If it's for everyone, you can choose an image for your Lightsail instance to run your project, so you don't have to spend as much time installing software or framework. If you're an individual developer or hobbyist working on a personal project, Lightsail can help you deploy and manage core cloud resources. You may also be interested in learning or experimenting with cloud services such as virtual machines, domains, or networking. Lightsail provides a quick way to get started. And Lightsail also has images with core operating system, development stack such as LAMP or Nginx, and SQL Server Express, and applications such as WordPress, Drupal, and Magento. For more detailed information about the software installed in each image, you must check official pages, AWS pages, of course. As your project grows, you can add block storage disk and attach them to your Lightsail instance. You can take snapshots of these instances and disk and easily create new instances from those snapshots. You can also connect to your VPC so that your Lightsail instances can use other AWS resources outside of Lightsail service. You can also create a Lightsail load balancer and attach target instances to create a highly available application. You can also configure the load balancer to handle encrypted HTTPS traffic, session persistence, validation, and more. And here it is. Here's just another quick example of how can you use your Lightsail service, for example. So if I want to create some server and I want to provision this very fast, I can go on the Lightsail WordPress in the Lightsail service, provision this machine very fast in a private subnet. This is our VPC, as you can see, in Amazon Lightsail VPC, and then I can use VPC peering to connect other application load balancer, for example, that is available in my AWS account. And then with the help of AWS WAF, as you can see, I can add this or connect this to our public internet, of course. And this is a different VPC because if you remember, we are using VPC peering to connect two different virtual private cloud. And finally, this is our US East 2 region. So let's hop to our console and see how can we set up or take a tour about and see what is Lightsail service. Just like any other service, you can find your Lightsail service if you go to all services in your console, and in the compute option you can click on Amazon or Lightsail. Here you can see that this is our Amazon Lightsail, and you can see this is lightsail.aws.amazon.com. This is our portal, and here you can choose these categories: instances, containers, databases, networking, storage, domain, DNS, and snapshot. If I choose my instances and click on create instance, you can see that after some time, so Lightsail is now loading all these options. You can choose your instance or region. So for example, I can create this instance in my location in Frankfurt Zone A. This is US Central 1A, and now I can pick my instance. You can pick a platform, so you can choose between Windows and Linux. You can see we have 27 options or different distribution for this platform, and there is, for example, WordPress multi-site LAMP based on PHP 8, Node.js, Joomla, Magento, Min, Drupal, Ghost, Nginx, Django, PrestaShop, and so on. Or you can choose operating system OS only. So we have Amazon Linux 2, Ubuntu 24.04, 22.04, Debian, FreeBSD, OpenSUSE, Alma Linux, CentOS. So you can choose between apps or OS or simply operating system. Here we have, for the Windows, we have SQL Server 22 Express, 19 Express, and 16 Express. Or simply you can choose operating system only, Server 22, 19, and 16. And you can see it really depends of image and operating system. What do you need to achieve with this? Then you can choose your script if you want. This is optional. Add your SSH key, and finally you can upload your key if you want. If you have, simply go to choose files and upload this. You can enable automatic snapshot if you want. You can choose your instance plan. This is the most important type. So you can choose dual stack network type for IPv4 and IPv6, or simply IPv6. This is recommended. And here you will select your size. You can select by memory, processing, storage, or transfer. Here, as you can see, this is a lot of offering, and it really depends of the type of your needs. So you will choose between these options, and there is the price per month from $5 to $386. And finally, when you're satisfied, simply choose your size of your machine and throughput, and finally you will be able to create your instance just like that. And as you can see, you will add the name for your instance and click on create instance. So this is how can you create your instance in different location using Lightsail. Then if you go to containers, you can create your container. Just like that, you can choose your container service capacity, nano, micro. This is the power. So you're choosing basically the family type of your virtual machine. Then you can choose to scale container, as you can see. And finally, you can set up your first deployment, identify a service, add a name for a service, and create your container service. You are choosing micro with 1 GB of RAM and 0.25 vCPU. Of course, you can change your AWS region, you can scale this machine, and it really depends of your need. If you go to database, you can create a network if you want. You can create static IP address, you can create CDN distribution, content delivery network, or you can create load balancer. So when you want to connect your project, these networking settings will help you to set up more things on the run. So just like that, you can create a different network resources. And finally, there is an option for light sale for research, if you can see, and you can use also that option. Finally, you can create your storage, you can create your domain and DNS, you can even create a snapshot. If you can see here, you can create a bucket or a disk volume that you can mount on your hard drive. You can create a DNS zone or even register a domain. So here is a snapshot. We don't have any snapshot, and you can also export this snapshot if you want to, and create EC2 instances from this snapshot from Lightsail. So you can go to your regular console, and in EC2 service you can create your new instance based on this exported snapshot from Lightsail. Also, you can add your alarm notifications and so on. And there is, of course, a detailed information of what is Lightsail and so on. So, as you can see, Lightsail is very, very good and friendly service that are available to us, and you can use this for everything that you need. Thank you for watching, and I hope this was helpful. In the next few hours, we will talk about one of the most important service in AWS, and that is S3 service or simple storage service. But before that, let's learn what are the types of AWS storage services. First, these services include, but not limited to, Amazon S3, Amazon EBS, Amazon EFS, and Amazon FSx. There are three types of cloud storage. First is an object storage, the second one is file or file storage, and the third one is block storage or block storage. Let's talk about the first one. So, when you talk about object storage, what you think of that the vast of scalability and metadata capabilities of object storage are often used by cloud-based applications. Amazon S3 or simple storage service and Amazon Glacier are excellent object storage options for building modern applications from the ground up that require scalability and adaptability. These solutions can also be used to bring in existing data warehouses for analytics, backup, and archiving purposes. Then we have file storage. An archiving system is required because many applications need to access shared files. A network-connected storage service, or NAS, is commonly used to support this type of storage. In situations such as large content repositories, development environments, media, storage, or users' home directories, file storage systems such as Elastic File System or Amazon EFS are ideal. And if you have some other business applications, such as ERP or database systems, it is often require exclusive low latency storage for each host. This is often compared to a cargo area network or SAN, or a directly connected warehouse's DES. Block-based cloud storage options such as Amazon EBS, Elastic Block Store, and EC2 Instant Storage. What are the types of storages? So we have storage facilities. First, this is Amazon S3. This is a highly scalable, durable, and cost-effective object storage service suitable for storing vast amount of unstructured data such as backups, archives, and website contents. Also, we have Amazon S3 Glacier. This is designed for long-term, low-cost archival storage with download times ranging from a few minutes to several hours. Then we already mentioned Elastic Block Store or Amazon EBS. It provides permanent block-level block storage volume for use with Amazon EC2 instances. EBS volumes are highly available, durable, and offer a variety of performance characteristics to suit different workloads. And finally, with Elastic File System or Amazon EFS, you can use a scalable, fully managed NFS file system that can be accessed by multiple EC2 instances at the same time. EFS is ideal for shared storage file and applications that require shared access to data. Of course, we have Amazon FS6. It offers a range of managed file systems, including FSX for Lustre, this is high performance computing, and FS6 for Windows File Server. Finally, in the other storage services, we have something called AWS Storage Gateway. It connects on-premises application to AWS Cloud Storage, enabling seamless data transfer and access. Then we have AWS Snowball. This is a data migration service that allows large data sets to be physically transferred to and from AWS. We have AWS Backup. This is a centralized backup service for managing and automating backups across various AWS services. And if you use all of these services, you can have, or you can see that there is a lot of benefits if you're using AWS storage. So the first one, there is no upfront cost. You can use pay-per-use model. You can access all your data around the world using only an internet connection. So it is a worldwide, it has worldwide access. Storage can be increased or decreased depending on the size of the data. Low-cost data storage with high endurance and high availability. Lots of choices to backup or archive data in case of disaster recovery. Over the years, Amazon Web Services or AWS has diversified significantly to meet a variety of needs. With the significant increase in data, new data storage technologies have transformed and continue to evolve day by day. Millions of customers use AWS storage cloud services to transform their businesses, increase agility, reduce cost, and accelerate innovation. You can choose from a broad portfolio of storage solutions with deep functionality for storing, accessing, protecting, and analyzing your data. As you can see, this is some type of storage services. We have block, file, block, and object. In the file, we have Amazon EFS service. Block is Amazon EBS or Amazon EC2 Instant Store, and Amazon S3 and Amazon Glacier are for object. In the next few hours, we will see, and I will introduce you to most of its services, and we will see how can you work with these services. So let's move on to another lesson. Now it's time to talk about Elastic Block Service. Well, Amazon Elastic Block Service Storage, or EBS, is a service that provides block-level storage volumes for use with Amazon EC2 instances. It allows you to create storage volumes that can be connected to EC2 instances similar to how you would use a hard drive on your computer. So, EBS volumes are permanent, which means that the data remains available even if the EC2 instance is stopped or terminated. Block-level storage. It is a block-level storage, of course, so EBS provides storage in the form of blocks which are the smallest units of data that can be individually processed and managed. This allows for efficient storage and retrieval of data. Also, it is a persistent storage. Unlike instance storage volumes, which are temporary and tied of the life cycle of an EC2 instance, EBS volumes survive even when the instance is stopped or terminated. Also, it is a very friendly option for scalability and performance. So EBS volumes are designed to be scalable, allowing you to adjust storage capacity for your need. They also offer high performance and low latency, making them suitable for a variety of workloads. Also, they have very good integration with Elastic Cloud service or our instances, so EBS volumes are designed to work seamlessly with Amazon EC2 instances, allowing you to plug in and separate volumes as needed. Also, EBS provides a snapshot feature that allows you to create a backup of your volumes in an instant fashion. This snapshot can be used to restore volumes or create a new volume with backup data. As its core, EBS is a reliable and scalable storage solution for your EC2 instances, offering durability, performance, and the ability to easily manage your storage needs. AWS introduced EBS in August 2008 as part of its effort to provide a more comprehensive cloud computing solution. EBS was developed to meet the need for persistent and high-efficiency storage that could be easily managed and scaled together with EC2 instances. Over the years, EBS has evolved significantly, introducing different types of volume optimized for different workloads and performance requirements, along with advanced features such as data snapshots, encryption, and elastic resizing. Also, there is a few type of EBS volumes. There is general purpose SSD. So we have GP2 and GP3. This option have balanced price and performance for a wide range of workloads. Then there is SSD with provide IOPS or provide provisioned IOPS SSD designed for mission critical applications that require consistently high IOPS performance. Then we have throughput optimized HDD or ST1. This is a low cost HDD or hard disk drive designed for frequent access and high throughput workloads. And we have SSD without load or cold HDD. This is SC1. This HDD has the cheapest price designed for infrequent access. And if you must use this EBS, you can use it for following services. EBS is used for database storage. This is ideal for relational or NoSQL databases that require high IOPS and output per second and low latency. It is very useful for big data analytics, suitable for big data applications that require high throughput and fast access to large data sets. It is used for backup and recovery. You can store backups and ensure data durability using EBS snapshots. Business applications. It supports a variety of business applications that need permanent storage with scalable performance. You can use for boot volume. This is often used as root volumes for EC2 instances, storing operating systems and application data. Also, Amazon EBS has become a cornerstone of cloud storage solutions in various sectors. Its widespread adoption is fueled by its seamless integration with AWS broad suite of services, making it an essential component for companies migrating to the cloud or scaling their existing cloud infrastructure. Also, Elastic Block Storage or EBS is widely used in organizations of all sizes, from startups to large enterprises in industries such as finance, healthcare, e-commerce, and technology. Its versatility in handling a variety of workloads, from high-performance database to large-scale data analytics, has cemented its place in the cloud storage market. Also, here you can see that I made a mistake. It is EBS, not ELB in our headline. So let's hop to portal and see Elastic Block service. But before that, we will first log in or sign in as a root user to my AWS account. I will provide my email address, my password, and then I will add MFA code from my phone, of course. You already know how to do this, and this is just another example how can we sign in with our verification or multi-factor authentication. Of course, in this chapter we will talk about Elastic Block Service. As you can see, I'm logged in as my root user, and I will use this root user account mainly for this course, of course. But as you already know, it is recommended to create another user, and then you can give that user admin privileges, and then you will go and see how to work. Of course, if I go to billing and cost management, you can see that I have some cost, and you can see that I have EC2 cost breakdown, and this is just an example that I wanted to show you now that some time has passed, and now we can see this option. Of course, let's go to EC2 service, and as you can see, if I go to instances, I don't have any instances here. Let me click on launch instance, and here, as you already know, I must provide the name for my VM. This will be, for example, VM1 Linux. I will choose Amazon Linux 2023 image, and then for the instance type we will use t2.micro. I will use my key pair that I already have on my local machine, and for the networking settings we will allow SSH traffic from anywhere and other two options. And here you can see that we have options to configure this storage. So if I click on this drop down menu, you can select from this general purpose SSD GP3, GP2, or provisioned IOPS SSD IO1 and IO2, as you can see. And finally, we can use something called magnetic standard. Also, there is an option, we have this called HDD and throughput optimized, but let me by default choose this GP3 storage. If I go down I can add my file, custom file if you want, just to make it more interesting. You can also choose your file. You already saw how can we add this, and finally there is a bin bash script. It will update, install HTTPD server, then it will start system and enable this message that this message is coming from our IP, and that's it. It will be at var www.html folder. So if you go up, just check our machine, let's click on launch instance, and our instance is launched and created, successfully created. Let me go to view all instances, and if I refresh this page, you can see that we have our VM1 Linux that is available and currently in pending state. So it is running, but we need to see, as you can see, we still initializing, or AWS still initializing this machine. If I check this box of this machine, you can see this is our public IP address, and if you copy this public IP address, of course, we will get the message from our machine, as you can see, because we added this script during deployment. And finally, if you go to storage, you can see our root device details. So our root device details is dev/xvda, EBS optimization is disabled, and our root device is EBS or elastic block system. And if we scroll down, you can see the volume ID of our volume ID. This is the volume of our ID, device name, what is the size of our volume state is in use, attachment status is attached, and you can see the date of attachment time. It is now encrypted, and it will be deleted when you delete or terminate your instance. If I go and click on terminate delete instance, this will be, of course, this EBS will be deleted with this virtual machine or instance. If you go scroll down and go to Elastic Block Store and go to volumes, you already know that we have our volume here. This is a separate resource, as you already know. You can see what is the type, size, IOPS, throughput, snapshot ID, when it's created, what is the availability zone, and all other information, and where it is attached. This is the ID of our VM or instance. Of course, we don't have any snapshot, but if I go and click on create volume, you can see that you can choose what volume types can you add to this machine. Then you have to choose your size for this. For example, 2 gigabytes. You can choose your IOPS or throughput in megabytes per second. You can choose your availability zone. If I open a new tab and go to instance, let me check where it is. North Virginia, US East 1D. This is our availability zone. So if you're creating a new disk or volume, it must be the same availability zone. And then you can automatically specify that if you want to create a snapshot, or simply choose don't create a snapshot. I will choose don't create a snapshot. And finally, you can encrypt this volume if you check this option. Also, you can add a tag and simply go and click on create volume, and after some time, if you refresh this page, you will see that we have our GP3 volume. This is our volume ID. You can see the size and availability zone is in East US 1D. Also, this disk is not attached to our instance, so if I, for example, go to instance settings, just let me find my attach network interface. Of course, you can attach this disk to this virtual machine, but for that we must go back to our volumes, and it is very easy to attach. Just click on this volume and click on attach volume, and here you can choose your instance, but as I already told you, this disk and virtual machine must be in the same availability zone. Then you can choose select device name. You can choose, for example, dev/sdb and click on attach volume, and after some time this volume will be successfully attached to our virtual machine. If I now go and refresh this page in our instances tab, you can see that we have two disks, and this is our OS volume, and the second one is, for example, data volume. But if you see, when you delete or terminate this instance, OS disk will be terminated, but the second one that we just created will not be terminated. So this is very important to know. If you plan to work in AWS. So as you can see, this is very important. And as you can see, this is very easy to work with EBS. How can you create a volume? You can easily create any type of volume, any size of your volume, and just like that you can also attach this volume to your instance. Simply go to storage and you will see. And one important thing, that once again your new volume and your VM must be in the same availability zone if you want to, of course, attach this disk to that VM. You can see what is the device name and volume ID, of course. So this is how can you work with Elastic Block storage with your volumes. And in the next set of chapters we will see more about this. And now if I go to, for example, volume ID, you can see the details and go to modify, and you can simply change the type of your volume, size, IOPS, throughput, and click on modified, and the old disk with new details will be provisioned very soon, and you will be able to continue to work, of course, without deattaching or attaching this drive again, drive or volume. So as you can see, AWS is working in AWS with volumes is very easy. And now if I go and type again create new volume, I can add again, for example, 5 gigabytes, exactly the same. I will choose some different availability zone. Let me find 1B, and let's create this volume. I will now refresh this page. So this is a volume of 5 gigabytes, for example. And if I go and right click on attach volume, if I want to choose the instance, you can see that no matching, running, or stopped instances in US East 1B availability zone. So if I want to use this volume, I must create an instance in this availability zone. So once again, that's it. So I can't attach this volume to my current instance. And now you can simply check this box and click on delete volume. Here you will type delete to confirm this deletion, and simply click on delete, and this volume is deleted. Of course, you can also delete in this second volume that is attached on our VM, but this is just a little practice. So if you want, you can continue to exercise with volumes, and that's it. Now that we know how can we work with Elastic Block Service and volumes, let's learn the difference between SSD and HDD drives. Well, Elastic Block Storage, or EBS, offers storage options on both SSD and HDD for EC2 instances. SSD are generally faster and better for performance-sensitive workloads, while HDD are more cost-effective for heavy storage needs. The best choice depends on the specific requirements of the workload, cost balancing, and performance. SSD stands for solid-state drives, and hard disk drives stands for HDD. And these are data storage devices. SSD store data in flash memory, while HDD store data on magnetic disk. SSDs are newer technology that uses the physical and chemical properties of silicon to offer greater storage capacity, speed, and efficiency. However, HDDs are a cost-effective options if you need infrequent access to data in blocks of 1 megabyte or more at a time. SSDs contain non-volatile flash memory, which consists of an array of integrated circuits for storing and retrieving data. Inside the SSD, there are floating gate transistors in network patterns. Each row within these grids is called a page, with many sides forming a block. An SSD stores information within these blocks. The different charges on floating gate transistor are converted into binary ones and zeros. This binary code is how an SSD communicates data. The SSD controller will keep track of where certain data is stored inside the drive, allowing you to access the data on your computer or laptop. Unlike solid-state drive, hard disk drive have several mechanical parts that move together to store and retrieve data. Inside the HDD device, there are rotating plates with a magnetic coating. Each plate has strips or concentric circles on it called segments. Each strip and sector number creates a unique address that HDD technology used to organize and locate data. The motor rotates an internal actuator lever with a read-write head. By reading the charge information on a specific segment, the read-write head records and retrieves the information. The I/O input-output controller and the operating system of the HDD tell the mechanical parts what to do and when. Let's talk more about SSD. So, if you want to learn more about price, performance, durability, and types, stick with us or with me. So SSD provides faster read-write speeds, lower latency, and higher IOPS or I/O operations per second, making them ideal for applications that require high performance and responsiveness, such as databases, media processing, and data analysis. SSD are generally more expensive per gigabyte than HDD. SSD are more durable due to the absence of moving parts, making them less susceptible to physical damage. EBS offers different types of SSD, including general purpose SSD GP3 and GP2, and SSD with provisional IOPS like IO2 and IO1. On the other hand, HDD offer slower speed and higher latency compared to SSD, but are suitable for less demanding workloads and high storage needs where cost is a primary concern. HDD are more cost-effective for storage large amounts of data. HDD have moving parts, making them more susceptible to manage from physical impacts. ABS offer different options for HDD, as Flow Optimized HDD, this is ST1, and Cool HDD, this is SC1. So, what are the key considerations? If you choose workload requirement, you must determine if your application requires high performance SSD or if price is a primary factor, then you will choose HDD. If you talk about IOPS and bandwidth, you can consider the required IOPS and bandwidth for your workload, and SSD generally offer higher IOPS and bandwidth than HDD. For the cost optimization, you can choose between these two, but balance storage cost with the performance requirements of your application. If data durability is critical, SSD are generally more robust due to the lack of moving parts. In short, SSD are the preferred choice for high-performance applications, while HDD are better suited for cost-sensitive scenarios, while less demanding performance needs. Carefully evaluate your workload requirements to determine the optimal type of EBS storage for your need. Also, in this table, you can see the main difference between SSD and HDD. So, as I already told you, let's recap. SSD stands for solid state drive. HDD stands for hard disk drive. How it works? SSD store data on electronic circuits, and HDD store data on mechanical moving magnetic patterns. SSD controller finds the correct address and reads its charges, and HDD I/O controller sends a signal that moves the actuator arm. The read-write head then reads charges. An SSD copies data to a new block, if you want to write process, to know more about write process, then erase the old block. It then writes to new old block by changing its charges. And HDD move the read-write head to the nearest available location. It then writes data by changing the charges of bits in that area. Performance, SSD are faster, they are silent and run cooler. HDD on the other hand are slower as their platters have to move around and they release more heat and are noisy. Cost, SSD are costlier, but HDD are less costly and larger storage volume are commercially popular. SSD are more durable and are electrical, which makes them less prone to damage. On the other hand, HDD have moving mechanical parts that makes them comparatively less durable. This lesson is very important because when you choose to create your EC2 instance, you must know the difference between SSD and HDD offer in AWS. In this lecture, we will get acquainted with snapshots in the Elastic Block service. Well, EBS snapshots or just snapshots are copies of data stored on Amazon Elastic Block Storage or EBS disk at a time, which are used for backups, disaster recovery, and data migration. They are incremental, which means that only charged blocks of data from the last snapshots are stored, saving storage space and time. These recordings or snapshots are stored in Amazon S3 and can be used to create new EBS drives or restore data to existing ones. The snapshot is a backup of the root repository that is connected to the EC2 instance. To learn how to create an AWS ES instance, you can see Amazon EC2 and how can we create an Elastic Cloud service. The snapshots that you will take first contains all the data that is present in EBS. Eventually, the snapshots you will take will only contain the data that was newly added, and these snapshots are also called incremental snapshots. AWS will change your price based on the amount of data that will be backed up for a single snapshot. The original disk image will not be determined the price, but the amount of data to be backup for. For example, if the size of EBS volume is 100 gigabytes and data that you back up is 60 gigabytes using the snapshot, then Amazon will only charge you with that 60 gigabytes. Data backup using AWS snapshot or recordings will be stored in the same region as the EBS volume. The images contain the region. If you want to share snapshot between regions, you need to make some adjustments such as enabling multi-region options and so on. And now there is a new option, so you can copy volumes or snapshot between regions. Sharing snapshots between multiple AWS accounts also can be achieved by managing permissions. So, snapshots support for encrypting snapshots. These snapshots and volumes created using each of them will be encrypted in encrypted state. Recordings or snapshots that are copied from undecrypted snapshots can be decrypted during the copying process. This is recordings, but it must say snapshots. If the snapshots have already been encrypted before copying, you can re-encrypt them with different keys based on your requirements. In EBS volume created using encrypted recordings or snapshots, then the volume will also be an encrypted format. So, what is the benefits of snapshots in EBS? You can use it for automation. The data stored in AWS EBS will be dynamic, that is, the data will be continuously added to the volume. So, instead of executing it manually, you can automate the whole process. For example, you can set a timer in the configuration of the snapshot while creating AWS snapshots, and the snapshots will be automatically created at a certain time interval. Also, it is a cost-effective option. The design of AWS snapshots will make them efficient from a cost standpoint, because AWS snapshots will follow an incremental type. The data added to the existing storage space will only be created as a snapshot, not as a whole data. The price will only depend on the amount of data that has been backed up. Also, this is a secure way, so your data that has been backed up with AWS snapshot or recordings will be encrypted, and you can also re-encrypt recordings or data, or snapshots depending on your need. Also, the snapshots will be stored directly on the Amazon S3 for long-term purposes. The S3 is designed for endurance of 99.11 nines, ensuring great availability of your EBS snapshot. So, example how to use these EBS recordings or snapshots. You can use it for backup and restore. The main purpose of Amazon Snapshot is to backup the EBS volumes in the form of encryption, which can help you to avoid data loss. And also, if accidental deletion occur, you will be on the safe side. You can use it for disaster recovery. This is a rare scenario in AWS, but if any disaster has occurred in the region where you have configured the data, then you can recover it by using AWS snapshots. And you can use it for test and development. Tested development environments can be built using Amazon EBS snapshots. This is a useful method for testing new settings or software without disrupting your live environment. Well, now it's time to see what are Amazon machine images. If you remember, when we learned about EC2 instances, we already talked about how can you choose and what image or Amazon machine image can you choose from. So let's see what are these Amazon machine images. This is just, or AMI, Amazon Machine Images, is just a template used to create virtual servers called instances within Amazon Web Services or AWS. It acts as a plan which contains all the necessary information, including the operating system, application server, and other software configurations to start a new instance. AMIs allow users to quickly and consistently deploy virtual machines with predefined settings. An Amazon Machine Snapshot is a special type of virtual machine that is used to create a virtual machine within EC2. It serves as the basic unit of implementation for the services delivered using EC2. Whenever you want to start an instance, you need to specify the AMI. You can also use different AMIs to start instances. If you want to run multiple instances for a single AMI, then you need multiple instances of the same configuration. You can also create your own custom AMI for an existing EC2 instance with the help of snapshots. After creating a snapshot, you create a new EC2 instance using the existing one, knowing that the new instance is a copy of the existing instance with all the necessary data in it. You can also search for an AMI that meets the criteria for your new instance, and you can use that instance to create a new instance. So, Amazon Machine Images are just templates used to create virtual machines in AWS. There are 4 main types of AMI. The first one is AMI provided by Amazon. These are default images from AWS, which offer basic operating systems such as Amazon Linux, Windows, and others. They come prefigured and pre-configured and are regularly updated by AWS. It is best for quick setup with standard configurations. Then we have AMIs from the marketplace. This is available for purchase on the AWS marketplace, and these AMIs include third-party software and services, often with licensing fees. It's best for deploying specific software or business applications that require licensing. Then we have community AMIs. These are publicly shared AMIs created by other AWS users. They are free to use, but they may not have the same level of support or reliability. Best for experimenting, collaborating, or using custom settings. And finally, we have custom AMIs. These are AMIs created by users from their own custom EC2 instances. Once you configure an instance with your specific settings, you can save it as a custom AMI and you can use it again. It is best to use for example, replicating custom configurations across multiple instances. Each type of AMI is designed for different needs, whether you're looking for a quick basic setup or a fully customized environment. If you have created a custom AMI according to the needs on your organization or of your organization, it is highly confidential. You can keep it private, or if it can be shared with the public, you can keep it in community so that others can use it. Instead of creating custom AMIs for your organization, You can save your effort and time by using AMIs created by independent organizations, such as, for example, Red Hat and Ubuntu. You can also create your own custom AMI and sell it to another Amazon EC2 users, depending on your needs. Also, there is a table, and public AMIs, these are free to use. Private AMIs, if you create a private AMI or AMI, you will pay depending on your storage region and other factors. The price is generally higher for private AMIs compared to public one. Region-based pricing may vary depending on where your AMI is stored. For example, the price will fluctuate between regions such as United States and, for example, Asia Pacific region. Data transfer cost, you may have also be charged for transferring data to and from AWS. Also, private AMI cost if you use a private AMI created by someone else. You may also have to pay the price set by the creator of this or that AMI. And once again, we are in our portal. As you can see, we have our virtual machine that is in the stop state, and in this virtual machine, as you can see, we have two volumes that is attached. And if I now go to AMIs, you can see that we don't have any AMIs for this region all by me. Then if we go to AMI catalog, you can see that we have a different catalog. This is quick start AMIs. This is a commonly used AMIs, and you can also filter your result by category or architecture. Here you can find official AWS images or AMIs, and you can, for example, filter only free tier if you want. Then you can find also all Linux or all Windows based by category and architecture. You have 64-bit ARM and x86. If you go to my AMIs, if you have one of your AMIs, it will be stored here. And AWS Marketplace, you can see there is a lot of AMIs that you can have from here, and this is a community AMIs, and you'll have to pay if you want to use one of these. And this is a community. These AMIs are created by AWS users, of course. And when you create or click on select, for example, AWS Amazon Linux, you can create a template with AMI. If I click here, you can add the name for this template, add a template version, for example. Let me add a name. Then, add a template here. You can use auto-scaling guidance, and you can also create a template. For here, I already have one template, if you remember when we created our ASG. And here, I can search for other catalogs, but I already choose my template. And here you can choose your instance type. What is your instance type? Choose your key pair login. Choose your network settings. If you want to create a new security group, your storage volumes, and in the advanced details, also you can set up your own file or your script, and then simply click on create line data, and this is how can you create your template. And we have only one template. If you remember, when we work with our HG or auto scaling group, we need to create this template. So if I go to actions, you can delete this template just to avoid any necessary confusion. And here, if you go to instances, if I go to launch instance, I can also add a name, for example, to my VM. Let me just find the proper name. This will be VM2. And here you can use, for example, application and OS images. I can use a different image if I want. I can use Debian, for example. This is Debian 12 bookworm. This is just another distribution by Linux, and here you can see that I can use Amazon machine image. This is based on Debian, and I will choose my T2 micro instance type. We will choose our key pair. We will leave everything as it is. We will allow all traffic, and if you want, you can add your script by file, or simply paste it from here. This is our script. I will now just delete this other information, and that's it. And finally we will hit on launch instance, and that's it. We are creating a different VM or VM2 based on Debian AMI. And let me refresh this page. As you can see, our Debian machine is running, and then you can, for example, copy this public IP address and you will get the message from our server, from our VM. But this machine is still in phase of creation, and after some time, it needs some time to be provisioned. But this is how can you create a VM based on different AMI, and I hope that now you have more knowledge about Amazon machine images. Thank you for watching, and I will see you in the next lesson. And if you go to volumes, you can see that I can now delete this volume, but first it must be detached. If you now go to instances and go to volumes, you can see that this volume can be attached to our Debian VM, and it can be attached because our Debian VM is not in the same availability zone as our Linux, simple Ubuntu Linux VM. Welcome back, and in this chapter we will look at how can we create a snapshot and then use this snapshot to create our new instance. I will now open a new tab and go to EC2 service in instances. As you can see, I don't have any instance for now. Let's hit on launch instance. I will now add a name for my VM. This will be VM Linux. This is a simple name based on Amazon Linux. Image, or you can even choose Ubuntu image. I will now choose my Ubuntu image, for example, and then I will choose this is based on 2404 LTS image. This is our AMI image. Now that you know what is an image, we can continue and choose our instance type. This will be based on T2 micro family with one vCPU and 1 GB of memory. I will now choose my existing key pair. You can create a new one if you don't have. And finally, in the networking settings, we will leave everything as it is, but here you can see this is our volume. And finally, I will hit on launch instance. This is a simple VM based on Ubuntu image. Let's check our logs. Everything is successfully created, and if I refresh this page, you can see that, of course, now you know that we need to wait a few minutes to get this machine in the running state. This machine is located in North Virginia and US East 1A. If we go inside our inside our virtual machine, you can check all other informations. And if I go to volumes, you can see that we have one volume. This is our default volume, and this volume is created when we provisioned our VM or instance. And then this is a root volume with 8 gigabytes of size. And if you go to status check, you can also see other information. And let me just wait for this machine to be initialized. I will now add a name for this volume. This will be VM Linux root volume. Let's confirm this new name for our root volume. As you can see, let me expand this a little bit more, and you can see we have our name. We are still waiting for initialization, and finally if you go to storage, you can see the root name device, what is the name of our root name device based on EBS, and of course this volume will be deleted when we terminate our machine. Of course, it is not encrypted. And let me now go to my volumes, and let me right click on this volume. And if you go and right click here, you can also create a new volume, create a snapshot, and I will now click on create snapshot. Of course, you can detach this volume, add a tag, you can force detach volume, you can manage auto enabled input output. There is something called create snapshot lifecycle policy. If you go inside this policy, you can choose what resource target type do you want, volume or instance, and here you can simply choose and configure this option. But there is also a lifecycle manager. This is a different topic, but we are still waiting for our machine to be initialized. Let me now go to actions and create a snapshot. I will now add a name for this snapshot. As you can see, this is our availability zone, and this volume is not encrypted. So here you will add a description, and I will type VM Linux snapshot, simple name. Let's hit on create snapshot, and as you can see, we successfully created our snapshot. And if you go to our snapshot blade in Elastic Block Store, you can see that we have our snapshot, and snapshot status is pending for now. Storage tier is standard, and we can add a name and see what is the volume size of this snapshot. So we created a snapshot from our VM Linux root volume, just to remind you, and after some time our snapshot status is still in pending state, and of course we need to wait for a few minutes. Let me, in the meantime, add a name for this snapshot. This will be VMLSP as a snapshot. And snapshot status is completed, as you can see. Progress is 100, and this drive is not encrypted. Or sorry, snapshot is not encrypted. If you go inside our snapshot, you can see the details of the snapshot. And in another tab, you can see snapshot settings, what our storage tier are we using, and all other information that is useful for our action. And if you want, you can use tags. And now we have our snapshot. I will go to actions, and we can create a volume from this snapshot. You can create an image from this snapshot. I will hit on create a volume. You can see that you can choose different volume type. General purpose SSD GP3 is what I want to use. Let me choose my size, IOPS throughput, and then I have an option to choose a different availability zone. Let me choose a different availability zone. East, US East 1B. If you open a new tab and go to our instances, you can see that our instance is located in US East 1A. This is different availability zone. Of course, our region is North Virginia. You can choose whatever region you want when you create your VM. And here we selected a different availability zone. Then you can even add volume initialization, and you can encrypt this volume if you want. I want to encrypt this volume. Simply I will hit on create, and our new volume is created based on snapshots that we take from our VM Linux root. And you can see here that we have a new volume based on exactly the same volume from our VM Linux. And now, but in different AZ. I will now add a name for this volume. This is VM Linux and root number 1, for example. And for this, with this volume, you can actually go to our instances and click on create or launch a new instance. I will add a name for my VM. This will be VM Linux 1. I will choose my Ubuntu AMI. Let me choose my instance type. This will be based on t2.micro. I will use exactly the same key pair. And then in the networking settings, we will leave everything as it is. And here we can choose to add a new volume, or simply create this machine. Click on launch instance. So we are creating a new virtual machine, and this virtual machine is also located in East US 1A. So I made a mistake and didn't add a proper information, proper availability zone, but here you can see all information about this AZ, or sorry, VM. I will now terminate this instance because I didn't specify the correct availability zone. So let me go back to instances. I will now launch a new instance, but this time we will do whatever we need to do. We need to first add our name for this VM. I will choose my Ubuntu image, choose my instance T2 micro. Here we can choose our key pair, and then I will edit network settings, go to availability zone and choose our US East 1B. If you remember, if you go back to volumes, our new volume is located exactly in this availability zone. As you can see, US East 1B. So we are choosing US East 1B. And of course, I can choose a subnet if you want. Let's find our subnet. Again, exactly the same. We are using exactly the same AZ or availability zone. And now I will hit on launch. And this time we created the machine that we wanted in different availability zone. Let me just refresh this page, and finally you can see that our VM1L is located in the right availability zone. And now we can join this image to this volume to this VM. But first let's wait until this machine initialized. And once again we are using US East 1B. Just to remind you, what are we doing? First we created our VM Linux, then with the help of snapshots we created a snapshot from VM Linux root, and then from that snapshot we created a new volume located in different availability zone in US 1B, and then we created a new VM located in the same availability zone. So if I go to volumes, to instances, you can see that our machine is still initializing, and finally we can go to volume, and right on here we can attach this volume to our new virtual machine that is running in US East 1B. I will now add a name for this volume and click on attach volume, and this is how can you, we need to choose a different C, for example, or D, and this is how can you use volume from one VM in one AZ, create a snapshot. From that snapshot you can create a new volume, and then you can attach this volume to a new VM in the different AZ. If you go to storage, you can see that we have now two block devices. One is that is original that we created when we create this instance, and the second one is our volume based on volume from VM Linux. This is our first instance that we created in the start of this demonstration, as you can see. Now if you go back to snapshot, you can see that we still have our snapshot, and as you can see we have three volumes. We have two volumes from our instances that we created and one from this snapshot. And finally, if I refresh this page, you can see that our VM is now up and running, and it's very easy to work with snapshots and volumes in EC2 service. And now this is our VM that we create but terminated. And now if you go back to snapshots, as you can see we still have our snapshots. I will go to actions and choose create image from snapshot. So you can create an image and snapshot, a volume and image from snapshot. I will now create an image. I will need to add a name. This will be our description. For example, Linux VM. Architecture will be x86 This is our root device name. Virtualization type. You can choose your virtualization type from paravirtual or hardware assist virtualization. And here we can add block device mappings if you want, and simply click on create image. And our image is still in the provisioning state, so we need to wait a few minutes to complete this job. If I now go to AMI, you can see that we have our image that we just created from that volume, from that snapshot that we take from our first instance, if you remember. Now, after some time, our AMI is completed. Let's go to launch instance, and now we can create an instance right from this image that we created, from my image. I will now simply add a name to this image, to this, VM. This will be, for example, VM image, Linux, and you can see what is our instance type. I will choose my key pair. You can select your network settings or change it or leave it as it is by default. And this is our storage. Let's click on launch instance. And just like that, we created another VM based on our AMI that we created from our snapshot. And if we refresh this page, you can see that we have pending VM image Linux, and you can locate it in US East 1A availability zone, and now you can do whatever you want with this machine. And this is exactly the same machine, just like our VM Linux and VM1L. But if you go to MI, you can see that we have our image, and based on this volume, and this volume is this snapshot. I can now go and, for example, copy this snapshot, choose our snapshot settings. You can modify permission, manage snapshot lock, manage fast snapshot lock, restore. This will cost you money if you want to restore this snapshot. This is a paid option. You can also delete this manage. You can archive this snapshot. You can archive in S3 storage, for example. You can copy this snapshot if you need. If you click on copy, this is US East 1 region, so you can see the destination region. For example, you can choose whatever region you want. If you choose, for example, UAE North region, then this snapshot will be copied to the new region. And that's it. This is how can you create snapshot. Then from that snapshot you can create a new volume. Then when you create this volume in different AZ, you can create a new VM, and then for that VM you can also attach this volume to that VM. Also from this snapshot you can create a new image and create a new VM just from that image. I will now delete my instances because we are done with this demonstration. Let me delete this AMI. First we need to deregister AMI, and then we can delete our snapshot. And of course, AMI, sorry. And of course, you can delete your snapshot, and just like anything else. And if you go to my AMI, you can see that we don't have any AMI now. And in the volume, we have our one root volume. You can now delete this volume because this volume is created from our snapshot and it isn't deleted when you terminate your VM. And now we can simply delete our snapshot. And this is how can you work with snapshots, volumes, and AMIs. Thank you for watching, and I will see you in the next lesson. First, you need to deregister your AMI and then delete your snapshot. So if you want to delete your snapshot or AMI, you can go to AMI, find it here, check this box of your AMI, click on deregister AMI, also check this box to delete associated snapshot and click on deregister AMI, and you can see that we successfully deregister AMI. If you go back to snapshot, you can see that we don't have any snapshot in this region. So if you refresh this page, we don't have any snapshot or any AMI in place. So simply go to search and you will find your snapshot if you have one snapshot, if you have one AMI, of course, and that's it. Just simply go to deregister AMI and both AMI and your snapshot will be deleted. Of course, we don't have any snapshot, any volumes, and our instances is terminated. Thank you for watching, and I hope this was helpful. When you create a new volume or VM, your volume is not encrypted by default. But if you want to encrypt your volume, you can go to volumes, choose one of your existing volume, and if I scroll down, you can see that this volume is not encrypted. Of course, you can create a separate volume, and when you create a new volume, you have the option to check one box and to allow encryption on that volume. As you can see, this volume is not encrypted, but as I already told you, you can create a new volume, and if you scroll down, you can choose your volume type, choose your size of this volume, IOPS, throughput, availability zone. You can also choose your snapshot ID if you want, and here, as you can see, we have an option to encrypt this volume, and it will use this encryption option. This is encrypted solution, but you must add KMS key. This is a simple service, and this is default, as you can see. And let's hit on create. So we are using encryption of key management service, and here it is, we have one volume, and if we scroll down, you can see that our volume is encrypted by KMS. If you go to a new tab, if I go to our search bar and type KMS or key management service, let's go inside that service, and if we go to AWS managed keys, you can see that we have our AWS EBS, and this is our key AID. This is a free option, and this is how can you encrypt your volume. Of course, you can now go to actions and delete this volume. Let me type delete and hit on delete, and this volume is deleted. If I now go to instances and choose to launch instance, and if I add some random name, choose my image, choose my instance type, key pair, networking settings, and go to my configure storage. I can click on advanced, click on this little arrow and choose encrypted or not encrypted, and choose my KMS key. I will use exactly the same KMS key, and finally we will hit on launch instance, and you will create your instance with encrypted volume. If you now go back to our instances, go inside our VM, go to storage, scroll down, or go inside our, you can see that we have our encryption, and this is our KMS key ID, and we are using exactly the same ID, and this is our key. So that's it. This is how can you create and create a new instance and create your encrypted volume. I will now terminate this VM. Thank you for watching. And of course I will delete my volume, and let me hit delete and confirm this. Welcome back. We are again in our console, in our EC2 service, and let's see how can we increase our volume size. Yes, it is possible, but as you can see, I don't have any virtual machine because I terminated my virtual machine from some of the previous chapter. So if you create a VM, for example, or instance, you can choose a different size or different type of volumes. We already saw how can we create a volume, how can we create a snapshot. But now let's go and create a new instance. I will now provide the name for this instance and choose our Amazon Linux image. We will use t2.micro instance type. In the key pair name, I will choose to proceed without key pair. This is not recommended, but this is a simple demo, so we can do whatever we want. Here in the networking part, I will select an existing resource group, choose my resource group, and then here in the storage option, you can add more volumes, but I will leave this as it is, and we are creating a new instance. And after some time, as you can see, our VM1 will be ready to go. And as you can see, it is running, but status is initializing. If you go inside our VM, and if you go to storage tab, you can see that we have one volume of 8 GB. This is the size of our volume. It is in use, and of course it is attached, and it will delete on termination. Then if you want to have a bigger volume size of your in GBs, of course, first we need to wait for our machine to be initialized, and then I will show you how can you do this action. Let me first connect to my VM using EC2 Instance Connect, and we are logged in, and now we will use lsblk command. This command in Linux provides your information about all block storage on your system. As you can see, these devices are for read and write data in blocks, just like HDD, SSD, USB devices and their partitions. I'm recording this course in Serbian in the same time, so I apologize if you don't understand what is said, but just follow this command, type lsblk, you will list all your information about block storages on your device. I will now paste this command, and here it is. You can see that we have a few disks and partition. We have one main partition for 8 gigabytes, and the second one is for booting up. Then we have dfh command. This will show you the result of or information of your capacity in your file system in human readable format. That 8 mean human readable. So I will copy df-h command. I will provide this notepad document in English so you can track. Here, as you can see, we have more human readable, and you can see that we have one disk. Then we will use the next command. You can see what is mounted on and what percent is every part of this drive is in use. So this is our main drive, as you can see, and it is use 20% of the capacity. Then if I go back to our instances, let's go to volumes, and let me just refresh this page, and you can see that our machine is finally initialized. Let me go to volumes. I will go inside our volume, click on action, choose to modify volume, and let me try again. Now we are inside our volume, and I want to modify this volume. So this is volume from our existing VM or instance, and you can see we are using our volume type, and the part that we are interested is this 8 gigabyte. Just to remind you, if you go to our storage, we are using our DevX VDA, and this is our volume. As you can see, this is our volume LD, exactly the same. So just to remind you, let's go to modify volume. We can use exactly the same volume type, and I will now add 12 gigabytes or 16, for example, for this existing volume. Let me click on modified, and again I want to modify it. If you want to increase the volume of the size volume, you must extend the file system to the new size of the volume. So you can do only this when the volume enters the optimizing state. So we will use some Linux command to increase the size of this volume, and of course we must extend the file system to the new size of the volume. So our new volume size is 16 gigabytes. Let's click on modified, and after some time our volume will be, if you go to storage tab, will be 16 gigabytes. And then if we as you can see, if you go back to our instances in our, so we are, do not forget that we are still connected to our instances. You can see all other information about this VM, and finally our storage volume is 16 gigabytes. And here, let me just try to connect again to our existing instance, and we will again run ls-blk. We are listing our part. As you can see, our main target, our main disk is 16 gigabytes, but it said 8 gigabytes. So we must run our sudo grow part name of our disk. This is command to, let's first run df-h, and you can see we still have this 8 gigabyte. So we must run, as I already told you, sudo grow part, the name of our disk 1, and this command sudo grow part is used to extend partition on your drive. It is very useful if you add more space storage on your EBS volume in AWS, but the partition is still using the old size. So grow part comes from this packet cloud-guest utils on Ubuntu, and you must install this option if it's not installed. So we will run sudo grow part and the name of our disk. Let me manually type the name of our volume or disk. Sometimes it's really hard even for me to... I used to work in so I'll copy from here, work in Azure, and disk or volume, it is exactly the same stuff. So we must again type this. As you can see, we are using, this is our partition, and it's changed our old size and end size. This is our new size, and if we run again our lsblk or df-h, you will see that both of our parts are now 16 gigabytes, and we are extending our file system, or our file system is extended with this sudo grow part, the name of our hard drive, and that's it. This is how can you use this option to have bigger volume, to increase the size of your volume if you want. And that's it. If I now click on reboot this device, let me reboot our device. After some time, and if you refresh our page, let's go to our connection. You can see that the system will power off now. And once again, if we connect again to our VM1, and if I run lsblk, everything will be fine. So the size of our volume is 16 gigabytes. So this is how can you resize your volume. And as you can see, if you want to install this grow part option command, you need to run sudo apt install cloud-guest utils, and this grow part option is coming from this packet on cloud guest utils from Ubuntu. If you're using CentOS, then it is cloud-utils. So just run this command if this program is not installed, and then you will be able to run sudo grow part, the name of your hard drive, and number 1 after that. And that's it. I will now go to instance and terminate this instance. Let's click on terminate, and that's it. I will see you in another lesson. Let's see what is EC2 Image Builder. EC2 Image Builder is a fully managed AWS service that automates the creation, management, and deployment of customized, secure, and up-to-date Amazon Machine Image or EMI, and also containerized image. or images. It simplifies the process of building, testing, and distributing images, reducing the effort and time required compared to manual processes. EC2 and EC2 Image Builder are two different services provided by AWS with different purposes. EC2 is used to run applications, host websites, process data, and other computing operations in AWS, while EC2 Image Builder is used to create custom Amazon machine images with specific configurations and settings for EC2 instances. So, this service, EC2 Image Builder, provides the following features. Image Builder reduces the amount of work required to create and manage images at scale by automating your construction pipelines. You can automate your construction by specifying your preferred construction execution schedules. Automation reduces the operating cost of maintaining your software with the least and latest operating system patches. Image Builder provides access to test components that you can use to test your images before deploying. You can also create custom test components using the AWS Task Orchestrator and Executor, AWS TOE or TOE, and use them. Image Builder distributes your image only if all configured tests are successful. The image creation tools allows you to create images that remove unnecessary exposure to component security vulnerabilities. You can apply AWS security settings to create secure, off-the-shelf images that meet industry and internal security criteria. The image creation tool also provides a collection of settings for companies in regulated industries. You can use these settings to quickly and easily create images that comply with STIG standards using built-in integrations and AWS organizations. The image creation tool allows you to enforce policies that restricts accounts from running instances only from approved AMIs. The EC2 image creation tool integrates with AWS Resource Manager or AWS RAM to allow you to share specific resources with any AWS account or through AWS organizations. The resources of the EC2 image creation tool that can be shared are components, snapshots, image receptions, and containers. Essentially, EC2 Image Builder simplifies the entire image lifecycle from creation to deployment, making it easy to maintain a consistent and secure infrastructure. The Amazon EC2 Instance Store provides block-level temporary storage directly connected to the physical host of the EC2 instance. It's like a local hard drive for your virtual machine, offering high performance for frequently accessed data like cache and buffering. However, this storage is not permanent. Data is lost if an instance is stopped, terminated, or failed. Because the storage of an EC2 instance is temporary, it is not ideal for storing critical or important data. In the event that the EC2 instances associated with the storage is stopped or terminated, all data in the storage is lost without the possibility of data recovery. If the host machine providing the EC2 instance experiences a system failure or crash due to internal problems, all data stored in the EC2 instance storage is lost. In addition, not every type of EC2 instance supports storage volume instance. This volume must be specified at the time of the instance is started, as the new storage volume cannot be added in the same instance later. However, the data remains intact if the instance is simply restarted. The storage volumes of an EC2 instance are particularly useful in scenario where data changes rapidly and where high input-output performance is crucial. They are ideal for the use as cache or buffer storage in application. The storage volumes of the EC2 instance are highly recommended for situations where data changes frequently and where high input-output performance is required. Then, temporary storage volume instances are designed for temporary data that can be easily recreated or recovered. Also, there is a good option for physical connectivity. Unlike EBS volumes, instance storage volumes are physically connected to the host computer, which provide lower latency and higher I/O performance. Also, this ephemeral nature or data stored in instances storage is lost when an instance is stopped, terminated, or experiences a hardware failure. Instance stores are ideal for caching, buffering, deleting data, or any data that can be easily rebuilt or reloaded. So you must know that EC2 instance store is not for permanent storage. Due to ephemeral nature, instance stores are not suitable for storing critical data that needs to be preserved beyond the lifetime of the instance. And also, you have these performance benefits. If you're connecting directly to the host computer, it results in faster read and write speed compared to EBS volumes or TOMs, making it suitable for performance-sensitive applications. So let's go to our console and see how can you use our instance store. I will now go to launch instances, and we will create a new instance, or try to create new instance. So let's add the name for our server. Let's add some random name. For example, A. I will choose my image. And let me just choose my image. This will be simple Amazon Linux image. And we will use this. As you can see, root type is EBS for now, Elastic Block Store. And I will choose my, for example, instance type. Let me choose my key pair that we already have. And here I will scroll all down to the configuration storage. And as you can see, if I click on advanced, there is an option to choose file systems. I will now choose my file system, and you can choose between EFS and FSX. Also, if I click on, just to find appropriate instance type, so we are not using right now, we will not use our T2 micro. We can go to let me find a new volume, and here you can see that our storage type is EBS right now. So this is our storage name, and here you have options to add different file systems, as you can see, and you can create a new file system. We will learn about this more in the next chapter, but for now, if we let me find this, we must choose appropriate instance or image. So let me find this image, and I will run instance family or instance store. That's it. So we are searching instance type that using instance store, that can be used instance store. And now we can run instance store, and this will be the list of instance type that can use this local instance store. So let me hit on true, and here, as you can see, this is the list of machines that can be, or images, or instance type, that can use this. Let me choose C3.4x large. We will choose this image, and now here, if we choose, for example, our subnet and scroll down, you can see that now we have option for instance store volumes, and now we can modify these options. So we have volume 1, for example. This will be 160 gigabytes of storage, and instance store volumes are not included in this template unless unless you can modify them. So here you can, for example, choose your group rules, and as you can see, this generation of or family, C3 family, can use our instance store. And if I, for example, choose a different one, the different instance cannot use instance store. So in the storage volumes, you can also add this EBS volume and also add this instance storing volume if you want. And as we already know, this is very fast, but if you're using this instance store volume, then your volume, if you, for example, restart your machine, all data on that volume will disappear or will be deleted. Also, if you stop your machine, this data will be lost. So this is how can you add this instance store. And I must warn you that these instance store volumes are available only for certain instance types. So that's it. Thank you for watching, and I will see you in the next lesson. Well, another great option if you want to use AWS is Elastic File System, or EFS. We already mentioned EFS when we talked about in the first lesson of the AWS storage options, and now we will dive in this feature. Amazon Elastic File System, or EFS, is a fully elastic, scalable, and serverless cloud file storage service offered by AWS. It allows users to share file data between multiple AWS compute instances and on-premises server without the need to provision or manage storage capacity and performance. EFS is designed to automatically scale to 5 times per demand, increasing and decreasing as files are added or removed without interrupting applications. EFS can be created using an EC2 instance, where it will be created in a specific region and distributed across multiple availability zones for high availability and durability. You can choose EFS based on input-output operations that you will perform. Once EFS is created, you need to set mount targets that will ensure connectivity to your EFS file system. Listed below are the sum of the resources that you can mount on EFS. This is Amazon EC2, Amazon ECS, Amazon EKS, AWS Fargate, AWS Lambda, and some other servers. So, with Elastic File Share, you have secure file sharing. So you can share your files in any secure way, faster and easier, and also you can ensure consistency throughout the system. This file system is suitable for web servers, where multiple web servers can access the file system and store data. EFS also scales whenever there is an increase in data flow. You can share data from AWS resources such as ECS, EKS, and any serverless web application in an efficient manner and without the need for additional management. Also, EFS is suitable for large-scale artificial data applications where multiple instances and containers access the same data, improving collaboration and reducing data duplication. Also, this is a shared file storage, so if multiple EC2 instances need to access the same data, EFS manages shared data and ensure consistency across instances. You can increase and decrease its storage capacity depending on the incoming data. If you have no idea how much data will arrive at the warehouse, you can use Amazon EFS. There is also simplifying data sharing, so if different apps want to use the same data in a collaborative way, you can choose Amazon EFS. EFS can share large data sets between a group of instances. You can use with serverless application. Amazon EFS is very suitable for services such as serverless computing services, such as some of the examples of AWS Lambda, EFS, etc. If your app has unpredictable storage growth, then there is no need to pay upfront or make any prior commitments. You only pay for the storage you will use. So, advantages of the AWS file system or EFS is that this service is scalable and resilient, so you can customize it depending on the data that will be saved. Scaling is done automatically. Multiple instances in AWS can access EFS at the same time. This makes it easier to share data between instances. Within the same region, EFS replicates data in multiple availability zones. EFS also allows you to periodically back up your data, so that in case of data loss, you can always have a backup. EFS also supports a wide range of POSIX file system features, making it compatible with many Linux-based applications. Also, there is a limitations of this service. So with AWS Elastic File System or EFS, you have to consider this when you start using this service. EFS only supports the network file system or NFS protocol, so only NFS-enabled devices can mount and access to it. EFS has a maximum of size of 47.9 terabytes, and the maximum throughput is 1000 megabytes per second per file system and a maximum of 16,000 IOPS per file system. EFS also has a maximum number of files and directories that can be created with a single file system, which is determined by the size of the file system. For example, a 1 terabyte file system can support up to 20 million files and directories. EFS is only available in certain regions and is not possible to migrate data between regions. If we see this map on EFS, let me just grab my pen so I will explain a little better. So, if you remember when we talked about Azure file share, this is exactly the same system that you can use here. So you will create a file share, EFS file share here, and then you will create two EC2 instances. First, you will create one VPC, as you can see, virtual private cloud. Then in one of the availability zone in one region, for example, you will create two EC2 instances, and then you will mount these instances to this file share. And if you, for example, add some X file to this machine, that file will be copied thanks to FS file share here to our second VM, and from here it will be copied here if you choose to use this machine. So it's very easy and very pleasant to work with Elastic File System. One of the most important services in AWS, and one of the services that was first created by Amazon, is S3 service or Simple Storage Service. Amazon S3 or Simple Storage Service is an object storage service offered by Amazon Web Services or AWS. It provides industry-leading scalability, data availability, security, and performance to store and retrieve any amount of data from anywhere on the web. Essentially, it allows you to store your data as objects within buckets, and these objects can be accessed over the internet. Amazon S3 is used for a variety of cloud purposes due to its robust scaling and data security features. It helps people with all kinds of use cases in areas such as mobile web apps, big data, machine learning, and many, many more. So, the following are some of the broad uses of Amazon S3. For example, data storage. Amazon S3 acts as the best option for scaling both small and large storage applications. It helps to store and download data intensive applications as needed as the ideal time. You can backup and recovery with S3 service. So many organizations use this service to back up their critical data and maintain data durability and availability for recovery purposes. Also, you can use to host static websites, so Amazon S3 makes it easy to store HTML, CSS, and other web content from user developers, allowing them to host static website with low access latency and cost effectiveness. For more detail, you can check article on how to host static website using Amazon S3, for example. Then, on official AWS website, of course, you can use this service for data archiving. The integration of the Amazon S3 Glacier service helps as a cost-effective solution for long-term data storage that is less frequently accessed by application. And also, you can use big data analytics to use with Amazon S3, it is often considered a data lake due to its ability to store large amounts of structured and unstructured data, offering seamless integration with other AWS analytics and AWS machine learning services. So, what is an Amazon S3 bucket, or simply bucket? The Amazon S3 bucket is the basic storage container function in the AWS 3 service. It provides secure and scalable storage for storing objects such as data, text or text data, images, audio, and video files over the AWS cloud. Each S3 bucket should be globally uniquely named and should be configured using an ACL or access control list. How does this service works? Amazon S3 works to organize data into unique S3 buckets, adapting the buckets to access control. It allows users to store objects within S3 buckets. There is a mistake, it's not bins, not buckets, with facilitating features such as versioning and lifecycle management of data storage with scaling. Amazon S3 manages data using an object storage architecture that aims to provide scalability, high availability, and low latency with high endurance. The basic storage units of the Amazon S3 are objects that are organized into buckets. Each object is identified by unique user-assigned keys. Buckets can be managed using the console provided by Amazon S3, programmatically using the AWS SDK or the REST application programming interface. Objects can be up to 5 terabytes in size. Requests are authorized using the access control list associated with each object bucket and support versioning that is disabled by default. Since the recycle bins are usually the size of the entire mounted file system on other systems, this access control scheme is very rough. In other words, unique access control can't be linked to individual files. Amazon S3 can be used to replace static web hosting infrastructure with client-accessible facilities. It support for index documents and support for error documents. The Amazon AWS authentication mechanism allows the creation of authenticated URL valid for a certain period of time. Each item in the cart can also be served as a BitTorrent feed, for example. The Amazon S3 store can act as a starter host for torrenting and any BitTorrent client that can download the file. This can drastically reduce bandwidth cost for downloading popular objects. The bucket can be configured to store HTTP log information in the bucket of a related bucket. This can be used in data mining operations. There are various file systems based on user file mode or fuse for Unix-like operating system, for example Linux, that can be used to mount the S3 bucket as a file system. The semantics of the Amazon S3 file system are not semantic of the POSIX file system, so the file system may not behave fully as expected. An object in S3 can be between 0 bytes and 5 terabytes in size. If the object is larger than 5 terabytes, it must be divided into parts before uploading. When uploading, Amazon S3 allows the maximum of 5 gigabytes in a single upload operation. Therefore, objects larger than 5 gigabytes must be uploaded via the S3 multi-part upload API. The widespread adoption of Amazon S3 and related tools has led to competing services based on S3 API. These services use a standard programming interface but differ in their core technologies and business models. The standard interface allows for better competition from rival vendors and allows for economies in scale in the implementation, among other advantages. So in the next chapter, I will show you how can you create your first S3 server. Now it's time to see how can we create our first S3 bucket. If I go to search and type S3, you can see that we are getting the old result for our S3. This is a scalable storage in the cloud, and we have S3 Glacier, which you can use for archiving your files in the cloud. And here it is. We don't have any bucket created, and as you can see, every object in S3 is stored in something called bucket. Bucket is just a simple container, and here you can find more about what are benefits and features of this service, and as you can see, use cases, and you can read if you want and get more knowledge about S3 service in AWS. As I already told you, this S3 service is one of the most popular service in and most used service in AWS, and also you can see what is the related services. And let me now scroll back to the top, and we will, for example, see that you can only pay for what you use, and price is based on location of your S3 bucket. We are now in North Virginia region, and if you click on create bucket, there is also buckets are just, as I already told you, containers for data stored in S3. You can choose your region. As you can see, this is our US East, North Virginia, US East 1 region, and you can choose between two bucket types. The first one is general purpose, and this is the most used. This is recommended for most use cases and access patterns, and also we have directory. This is recommended for low latency use cases. These buckets use only S3 Express one zone storage class, which provides faster and processing data with a single availability zone. So you can choose availability zone. If you go back to general purpose, we already have our AWS region, and the first thing we need to do is to add a unique name for your bucket. Buckets names must be from 3 to 63 characters, and it must be unique within global namespace. If you, for example, use some random name, and if you delete that name, and after 6 months, for example, you again use that name, and if someone else use that name in the meantime, then that name won't be accessible. I will add some random name, and as you can see, this is a unique name. If you want, you can use copy settings from existing bucket to copy settings, if you want, and following configurations to this new bucket. So you can choose this bucket, and you can see what is the format prefix. This is a very good information, but it is an optional. And here, if you go and see object ownership, you can choose and control ownership of object that is written to this bucket from other AWS account. So from here you can choose your bucket if you want to copy the settings into the new one. Simply choose one from the list and click on apply. So as I already told you, you can choose ownership, and this action control list is disabled by default, and this is recommended. So all object in this bucket is owned by this account, and access to this bucket and its object is specified using only policies. If you, for example, choose ACL enabled, then object in this bucket can be owned by other members from other AWS account, and access to this bucket and its objects can be specified using action control list. So it is recommended that you disable this option, and as you can see, bucket ownership is just for this. Then another very important option is block public access settings for this bucket. So public access is granted to bucket and objects through action control list, bucket policies, access point policies, or all together. So this is default, and we will use we will not now disable, we will disable our versioning. Also tags is optional, and you can see that this is our default encryption. All objects are encrypted by service-side encryption with Amazon S3 managed key or SSS S3. Also, you can choose between SSS KMS and dual layer server DSS KMS. Also, there is something called bucket key, so you can use, which is enabled, you can use S3 bucket key for SSS KMS server-side encryption with AWS Key Management Service that reduce cost by lowering calls to AWS KMS. So S3 bucket keys are not supported with this third option. And finally, there is an advanced settings. So here you can enable or disable this object locked, and if you enable this object locked, then it will permanently allow object in this bucket to be locked, so nobody from outside world can delete your object in this bucket. I will leave this as a disable. This is but if you want to use and enable this, you must enable versioning. And finally, let's create our bucket. This username is already this, so I must add some random numbers, and let's try now. So just to tell you once again, the name for your bucket must be unique. And finally, let's hit on create bucket, and we successfully created our first bucket located in East US region. So this is our bucket, and as you can see, account snapshot is updated any 24 hours for all AWS region. So this storage lines provides visibility into storage usage and activity trend. This is a general purpose bucket, and then in another tab you have directory buckets, but we don't have any bucket any directory bucket for now. Just to remind you, directory bucket is strictly used in one AZ. And as you can see, our bucket is created, and it is located in North Virginia in our East US 1. And for example, you can create another bucket and the list will be shown here. Also, you can change table bucket for analytics workload. You can grant access for this bucket. You can use access point for general purposes. And with this S3 access grant, you can control access to datasets within S3 by using identities from your corporate directory or AWS identity or access management IAM. Also, there is a lot of options, but for now we will go to our bucket. Also, you have this access analyzer, and you can see who and how can reach this bucket. Let's go inside our bucket. If you go inside our bucket, you can see that we have option to upload objects, and here you can add the files and folders. And if you want to click to add simple files, you can add the files, or simply you can add a whole folder. Let me go to some photography from my local VM, and I will upload these objects and finally hit on upload. So as you can see, we are successfully uploaded our objects, and you can see the total, how much objects we added and what is the size of grouped by objects. And you can see the status is succeeded. Finally, if I click on one object, you can see that we have option to see all objects individually. So here in the properties for AWS Cert 2, for example, this is a PNG file. You can see who is the owner, what is the AWS region, when is last modified, the size, the type, and the key for our object. Also, there is a S3 URI. This is Amazon resource name. You can have this entity tag and object URL. As you can see, in object URL, there is first the name of our bucket, then .s3.useast1.amazonavs.com, this is the address of our bucket, and finally /AWS plus cert2, this is the name of our object. So this is how is this link structured. So as you can see, this is our S3, the name of our bucket, as I told you, and this is Amazon resource name, or ARN. We already know what is ARN, and this is our object URL. If you click on this object, you can see that by default access is denied. So this is very good for security point of view, so nobody outside your AWS account can access this object. If I scroll down, you can see there is a storage clause, server-side encryption, metadata, and object locker, just for this object individually. You can also, if you go to object, you can download this share with a pre-signed URL. You can calculate total size, copy, move, query, deselect bucket, and also if you choose share AWS with a pre-signed URL, you can specify how many minutes an hour. In the minutes, for example, this URL will be grant access to this object for a limited time. For example, if you choose 10 minutes or 1 hour for this, or 5 minutes, you can click on copy pre-signed URL, and here if you copy this pre-signed URL, everybody who has this link can access this file. As you can see, if you check our link, you will see that we have something called access signature that is created, or security token that is now linked or part of this link. So this is very useful option. Also, if you click on open, you can see how your object looks like, and this is our object. This is only for internal use, and also you can download file, copy this URL, and that's it. This is for object. If you go to permissions, you can grant basic read-write permissions in your AWS account, and you can see, if you see, only owner can read this object, and owner of this file can practically create account access control list to our account. So in the group, everybody have public access. Sorry, nobody can reach this from outside of this account, and user groups must be authenticated before they can see this file. Also, there is something called versions. You can have more than one versions of this object, but you must enable versioning if you want to use this option. So this is the basics of how to upload and work with your objects in S3 service. If I hit on close, you will see that we have now 4 objects, and if you choose these tabs, you can see your metadata, properties for this. Here there is a versioning for this bucket on bucket level. It means that it's keeping multiple variants of your files. You can enable decryption if you want, or change your encryption, and that's it. There is a lot of options that you can choose from. Of course, you can use static website, and most of these options we will learn in separate lectures. Also, in the permission tab, there is also an option to block public access, or you can enable public access for all. Also, you can see the metrics for all bucket objects, but for now we don't have any graphics available. And in the management option, you can set up lifecycle rules, replication rules, and this is very important options that you can use, for example. But more about this in the later part of this service. But for now, let's just go to our lifecycle management or configuration. So for example, you can add your lifecycle rule action, and for example, if your object is not accessed, for example, 30 days, then with this option you can automatically create a script after 30 days after your object is not accessed. It will automatically, for example, be in another storage class thanks to lifecycle configurations. But with the later part, as I already told you in this course, we will learn how to set up lifecycle configurations. So as you can see, S3 is a very useful and very interesting service that can be used for variety of options. And then the last tab is access points. So access points are name network endpoints that are attached to buckets, which simplify managing data access at scale in S3, for example. So you can create your access point to this bucket or cross account access, but you must go to IAM Access Analyzer for S3 for that. So you can see there is a special wizard for this option, and you can add your policy based on JSON file. All in all, as I already told you, this is a very useful option. So you can also create a folder if you want. Let's create one folder. This will be folder 1. You can choose your encryption or do not. Simply create a folder, and here it is. Folder 1 is here, and now we can also upload some objects to this folder, or you can add a complete folder from your machine. Let me add a few objects and hit on upload. So now these objects will be in this folder, and if you choose one of these objects, as you can see, now we have a different S3 link. We have the name of our bucket, the name of our folder, and the name of our object. And that's it. Exactly the same, just like in our storage services in Azure. As you can see, folder 1 is now included in our S3 URI. And finally, if you go back and select all objects and folders together, you can delete your objects. Simply you can type permanently delete in this empty field, or you can copy permanently delete, and then sometimes it's better to copy this and paste it here. And now we can delete our objects from this bucket. And if you go back to buckets, you can see that we have only one bucket, and you have options here to automatically empty and click on delete. I must warn you that you must copy the name of your bucket here to this empty field to be able to delete this bucket. You must empty your bucket if you want to delete this bucket. Let's hit on delete bucket, and we don't have any bucket, and this is how can you work with or create a new bucket. Thank you for watching. Now it's time to see what is the security for this service, for our simple storage service. Well, all newly created S3 buckets are private by default. This means that they are blocked for public access by default. They only identify that has initial access to the newly created S3 buckets is in the AWS account, through which is the S3 bucket was created. The owner of the S3 resources or resource is always the AWS account to which they belong. Even if S3 resources were created by any other IAM user, the owner of that resource still remains with the AWS account. If the permissions are to be granted to the S3 bucket, then they must be explicitly defined. There are several ways to do this: by card policy, identity policy, and access control list or ACL. So, what are the politics of the bucket and politics of identity? The politics of the bucket is a form of resource policy or politics which is tied to the resource rather than the identity found in identity politics. It basically controls who can access a particular resource, while in identity policy or politics it controls what that identity can access. In theory, there are two main differences between the policy of the bucket and policy of identity. You can grant access to multiple AWS accounts. With identity policy, you can only assign permissions to identities within your AWS account, as opposed to a resource that can invoke multiple identities from different AWS accounts. This is a great advantage for resource policies. Then, anonymous access to the Buckets resource policies can grant anonymous access to the outside world, as opposed to an identity policy that is always tied to identity. Then the principal part of the bucket resource policy is S3 basically determines which identity is associated with the bucket. Perhaps you will find the principal part in a typical identity policy simply because the identity policy is written for a given identity and there is no need to mention it. Also, I already told you about access control list or ACL. So this list allows you to manage access to buckets and objects. For each bucket, an object has an ACL associated with its sub-resource. It defines which AWS accounts or group are granted access and the type of access. When a resource request is received, Amazon S3 checks the appropriate ACL to verify that the requester has the necessary access permissions. However, ACLs are considered obsolete and are primarily being replaced by S3 bucket policies. Their use is limited today mainly due to their inflexibility compared to the bucket policies, which may work better. For example, ACLs cannot have conditional statements as found in the policy. And there is also blocking public access policy, and to ensure maximum security for S3 buckets, AWS recently added a block public access feature. By default, this is enabled to ensure that implementer does not make mistakes during the configuration of buckets. There is no hard and fast rule to follow for either identity politics or resource politics. We can use both in different situations. For example, if your S3 permission depends on multiple AWS accounts, then you should always use segment policies. If you are within a single AWS account, then it's always better to use IAM policies, mainly because it's easy to manage multiple resources for a single identity policy. Otherwise, we will probably have to write more policies for resources for a given situation. In addition, not all resources may have the ability to define resource policy, which would encourage you to use identity policy. Sometimes you may need to define both identity and resource policies in combination to achieve specific use cases. Well, if you go to our S3 service and if you click on create new bucket, as you already know, we must use unique name for this bucket, and I will add some random number, and then as you can see our ACL is disabled and this is recommended, and finally this is a block public access setting for this bucket. Here you can enable versioning, and let me create this bucket. So we created our new bucket, and if you go inside that bucket and as you can see we don't have any object uploaded for now, and if we go to properties to permissions, you can see that we can edit our permissions. By default, all public access is blocked. If I click on edit, I can uncheck this option and save our changes. So it will unblock public access, and this bucket will be vulnerable. Also, you can choose one by one. For example, this block public access to buckets and objects granted to new access control list. S3 will block public access permissions applied to newly added buckets or object, or you can use only any access to control list or access point policies, or this will block and cross-account access to bucket and objects and any public objects. So you need to confirm that you are aware that you are unblock this public access, and after some time we successfully edited this, as you can see. So now you can enable this individual block public access for these block settings if you want, and there is also a bucket policy, and you can add your bucket policy written in JSON, and this will provide access to the object stored in the bucket. As you can see, bucket policies do not apply to objects owned by other accounts, so it is only applicable to this AWS account. So here you can add your simple JSON file, for example, and here you can define to add an action or choose a service. If you have some JSON file already written, you can add it here. If I, for example, find this EC2, you can check all actions for EC2. If you remember, when we work with our EC2 policies, I explain in great detail how can you choose your access list and how can you add or allow or deny this effect. And of course, all these JSON files must be written accordingly. And as you can see, you must define your statement ID, principal, effects, action, and resource, of course. So you can add your resource, you can select your type, for example, you can choose one of these that is offered, or you can, if you have already written JSON files, you can simply paste it here to add this bucket policy. Let me choose one of these resources, and if you add it here, then it will remain as a star. Of course, there is an error because this JSON file is not written or properly. So you can use something called policy generators, for example. If you click on this link, it will open this policy generator, and here you can choose the type of your policy. For example, IAM policy or S3 bucket policy. Then you can choose your effect, choose your service. Let me find my EC2, for example, and it will use allowed effect. And here you can choose what action do you want to add to this role or to this generator, policy generator, and you can add any of these. And I will scroll down just to show you how many actions there is. And finally, for Amazon resource name, you should add your resource name. And finally, you need to click on generate policy, but we must again choose our actions. For the simplicity, I will choose all actions or let me choose something else. So if you have more than one policy, it will act as a container for one or more statement, and you must add a condition if you want, or remove everything. And finally, this is our JSON policy, our document. I will now copy this. As you can see, this is allowed statement for EC2, for example, and I will copy here in our bucket policy just to show you how can we use this bucket policy. There is a lot of errors, as you can see, but you can save your changes, and after you add this policy, you will be able to add your bucket policy. So this was just a simple example of how can you add and use this permission. If you go back to our block public access, we can now enable this, and for example, if I go to add some file or object, let me upload a few or one. I will now click on upload, and for example, if you go to our object and copy this URL, you can see that we do not we still do not have this granted. But if you go to share with a pre-signed URL, then you can add appropriate number of minutes, and finally you can copy this pre-signed URL, and this document will be enabled. But it is a good example to go to your permissions and enable block public access. Thank you for watching. If you carefully listen and follow this course in sequence, this section, I already told you that you can run static website in S3 service. So as you can see, we have our bucket, and if you go inside this bucket, we can run our static website or host our static website. Let's go inside our bucket, and for this we must go to properties and enable bucket versioning. But if I scroll all the way down, you can see that static S3 website hosting is disabled. I will now click on edit and enable static website hosting. But first, as I already told you, I will go to upload and add a file. I have already some files with index and wallpaper that I want to use, and I will hit on upload. So we are uploading our index and wallpaper, and I will just show you. If I open this index file in my notepad, this is just a simple file, as you can see, with title My Demo Web Page and really beautiful scenery. And I want to host this wallpaper, and you can see below index that we have our JPG file. So let me now go back to my browser, and as I already told you, I uploaded files and folders, and here I can go to properties and enable static website. Let me choose enable, and I want to host a static website. And here I must add index.html and For error document, this is optional, you can add error.html. I must copy my H letter or HTML, sorry, and here we can add this document, and finally I will add error.html. This is just an optional, and also you can add JSON file if you want, but let's save our changes, and here it is. This is our link for our static website. If I open this link, you can see that this is forbidden for now, but if I go back to our bucket, we have to go up, go to permissions, and let me edit my block all public access. I will now save my changes. Let me confirm this. So we are adding our default settings back from previous chapters. And finally, if I go back to properties, scroll down and copy this link, it's still forbidden, but we must wait a few seconds before this rule, and finally, after some time, if I again open my link, as you can see, we are getting the message from our really beautiful scenery, but thanks to my antivirus software, our picture is not shown here, but you can see that we are getting exactly the same message. If I go and change this really and delete this D letter from my index file, we can successfully edit this page. So let me go back to my bucket. I will now delete my files. We need to type permanently delete, paste it in this empty field, and hit on delete objects. Now, if I go back to my console, to my S3 bucket, I will go inside my bucket, go to properties, edit my files. I will now disable this website, click on save changes, and that's it. We are now not hosting anything. Well, another option in S3 service is something called versioning. S3 versioning is a feature in Amazon S3 that allows you to save, download, and restore every version of every object in your S3 bucket. When enabled, S3 automatically creates new version of objects whenever they are modified or deleted, effectively creating a history of changes to your data. This helps with accidental deletion or modification of objects, compliance requirements, and general data management. Some of the key aspects of S3 versioning are: it keeps multiple versions each time you modify or delete an object. In the version enable recycle bin, S3 creates a new version of that object, preserving the previous one. It has unique version IDs, so each version of an object is assigned a unique version ID, which allows you to identify and download specific versions. You can enable or suspend versioning, so versioning can be enabled or suspended for the bucket, but once enabled, it can be completely disabled. Also, versioning allows you to easily recover deleted or overwritten objects by downloading the desired version. Also, versioning can be critical to meeting compliance requirements that require tracking data changes over time. Also, there is a price for versioning, and it increases storage costs because multiple versions of the objects are stored. As you can see, versioning, you can enable versioning for your S3 bucket through the AWS Management Console, AWS CLI, or SDK, object replication, or operations. So when you upload, modify, or delete an object in version-enabled bucket, S3 automatically creates new versions. You can also download specific versions of an object by specifying its key and version ID. And also, deleting the latest version of an object does not remove it permanently. Only the previous version is the current one. To permanently delete a version, you need to delete it by specifying its version ID. If you go inside our existing bucket, as you can see, we are in Amazon S3, of course, and if for example, we don't have any object, as you can see, if I go to properties, there is something called bucket versioning. So you can edit this versioning, and for now our bucket versioning is suspended. Let me click on edit, and I will enable this versioning, and let's hit on save changes. So our versioning is enabled, and we successfully edit these options. Let me go to files, and I will add some random files. Let me add these objects for our static site. I will hit on upload, and finally let's go to our properties, and if I now edit my static website hosting and enable this, let me add my index HTML. This is our document, index document. I will save changes, and once again, if you go to objects, if I, for example, click on index and go to versions, you can see that I have only one version, and this is our current version. If I, for example, open this file, you can see that we have our exactly the same from the previous chapter. This is our website, and here you can go to object action, or simply go to our bucket, and I will now change this notepad, and let me just delete this D from readly that is written. I will now save this and upload a new version of this index file. Let me upload this, just index.html, and let me upload this. As you can see, I will now close this, and as you can see, we have our index. And if I go inside that object, if you go to versioning, you can see that we have two versions, the first one and the second one when we deleted our letter D, and this is our current version. So this is how versioning works in AWS S3 service. And now if you open this, you can see that we have really beautiful scenery. We don't have D. That was added intentionally. So here we can now delete our objects. Let me type delete, just to finish this demonstration and having all cleaned. I will now go to properties and edit this service website. I will disable this hosting, save changes, and also we can enable our bucket versioning and suspend our bucket versioning, and we must acknowledge the outcomes of suspending bucket version, and let me hit on save changes. So this is how can you use versioning in AWS S3 service. In this lesson we will learn what is access logging in S3 service. Well, Amazon S3 periodically collects access log records, consolidates the records in log files, and then uploads the log files to your destination bucket as log objects. If you enable logging on multiple sources, buckets, then identity the same destination bucket, the destination bucket will have access logging for all these source buckets. However, each log objects report access logs records for a specific source, not bin buckets. Amazon S3 uses a special log delivery account to write server access logs. These writes are subject to the usual access control restriction. So, AWS recommends that you update the bucket policy on the destination bucket to grant access to the sign-on service principle. For example, logging.s3.amazonaws.com to deliver the access logs. So you can also grant access for log delivery to the S3 log delivery group through your bin or bucket access control list. However, it is not recommended to grant access to the S3 log delivery group using your ACL bucket. Also, the completeness and timeliness of logging on the server is not guaranteed. A log record for a particular request may be delivered long after the request has actually been processed, or it may not be delivered at all. It is possible that you even see duplicate log records. The purpose of a server log is to give you an idea of the nature of traffic in your bucket. Although log records are rarely lost or duplicated, keep in mind that logging on the server is not intended to be a complete representation of all requests. Due to the best effort nature of logging on the server, your usage reports may contain one or more access requests that do not appear in the supplied server log. These usage reports can be found in the Expense and Usage Reports section of the AWS Billing and Expense Management console. Changes to the status of the bin log take time to actually affect the delivery of log files. For example, if you enable logging for a bucket, some requests made in the next hour may be logged and others may not. Suppose you change the destination logging bin or bucket from bin A to bucket B. Over the next hour, some logs may continue to be delivered to bucket A, while others may be delivered to the new destination on bucket B. In all cases, the new settings eventually take effect without any further action on your part. Let's hop to our console and see how can we use access logging. Well, as you can see, we are still having our old bucket, and if I go to this bucket, you can first we will create our destination bucket. This is our new bucket, and I will add some random name, and we will leave everything as it is. So this is our destination bucket for our logs. Then we will hit on create bucket. So we have two buckets for now. Then we will go inside our amazing, this name is taken. So I will choose some random name, and finally let's click on create bucket, and I will now go to our first bucket, and from here this is our source bucket, and the new one is our destination bucket. Let's go to properties and edit this server access logging. So we will enable this option, and our destination will be our new log bucket. Let's choose this destination, and as you can see, you can choose this log object key format, so all your logs will have this format of unique string, as you can see. So, for example, this is a unique string, as you can see, and it has the year, month, date, and so on and so forth. Also, this is for destination prefix. Let's hit on save changes, and after some time, from our bucket, our first bucket, all logs will be stored in that destination bucket. And if you want to see your logs, you must be active on this bucket. So let's, for example, upload some files and just to have some activity on this bucket, source bucket. And if you go inside that bucket, you can see that we have our static website here. And if I go to my destination bucket, you can see that we don't have any logs for now, but after some time we will see our log bucket. And if I go to, for example, other tabs, you can see that this is exactly the same bucket as our source bucket. So I just want to know that if you don't see your logs after some times, you must wait for 5 to 6 hours to see the first log from our source to our destination bucket. Also, as you can see, our server is access logging, so all logs from our server will be stored in that destination bucket. Also, you have option to go to CloudWatch, for example. This is a separate service to see all your log buckets from your server, of course. But this is a very good option to store your logs in other bucket. S3 replication is a fully managed feature available to Amazon Simple Storage Service or S3 customers. It can automatically replicate S3 objects to help you reduce cost, protect your data, and achieve regulatory compliance. Here are two options for replicating S3 storage. The first one is cross-region replication or CRR. It copies S3 objects to multiple Amazon regions or AR, which represent geographically separated Amazon data centers. And we have same region replication or SRR. It copies S3 objects between buckets in different availability zones or AZ, which are separated data centers in the same Amazon regions. AWS also offers a replication time control or RTC, service level agreement or SLA, that guarantees object replication in less than 15 minutes. AWS 3S cross-region replication or CRR. CRR can help you to reduce latency, maintain compliance, enforce security, and implement disaster recovery. This feature allows you to replicate objects to the other Amazon regions or AR, including your objects metadata and object tags. You can configure that S3 CRR to copy objects to one or more buckets in another AR for improved resiliency. This feature allows you to set up replication between buckets, shared prefixes, and individual objects. You can manage replication for individual objects by using object tags. Some of the use cases and are key use cases for S3 CRR are compliance. The default configuration in S3 to set to store data in multiple geographically distant availability zones. However, compliance often requires storing data in specific geographic location. So, with cross-region replication, you can achieve this. And also, customers and end users are sometimes located in several geographic locations, so CRR can help you improve their user experience by minimizing latency for data access. And then we have same region replication, or SRR. It provides fully automated replication of S3 objects to another AZ within the same region. It is available in all commercial AWS regions as well in AWS Government Cloud in the US only. So, same region replication uses asynchronous replication, which means that objects are not copied to another AZ immediately after they have been created or modified. You can also configure SRR using the S3 Management Console API or SDK. SSR identifies the objects for which you have requested replication at the prefix, bucket, or tag level and initiates replication. You can set up an AWS account that owns the original copy to own the replicated objects. Alternatively, you can use a different copy account to protect them from accidental deletion. Some of the use cases for same region replication: you can aggregate logs for several S3 processing buckets in the same Amazon region. You can also use it to configure live replication between the development and test environments, for example. You can make a copy of your S3 objects and keep it in the same Amazon region to meet the data compliance and sovereignty requirement. Once again, we are in our console, and as you can see, we have our first bucket. And if I go to permission, if I go to properties and scroll down, you can see that we have option to enable this bucket versioning. So bucket versioning must be enabled if you want to use your replication. If you now go to management and go to replication rules, you can use these rules to define the options if you want to Amazon S3, and these options will be applied during the replication such as encryption, replica ownership, transition replica to other storage class, and more. So you need to create this application rule if you want to use this option, of course. Then if we scroll down, there is another option, but let's click on create an option. First, what we need to do is to go in our bucket, and I will now create a new bucket. This will be a general purpose bucket located in East US, so this is the same region. I will now add this dest, that means destination bucket. Once again, the name must be unique. We will leave everything as it is, and as you can see, let's go to Ohio, for example, to Ohio region, and I will now here create this bucket. So we are using cross-region replication to make it more interesting. Let me add a name for my bucket. This is destination for D. We must enable versioning, and we will leave everything as it is. Let's finally hit on create bucket, and our bucket is created. So as you can see, we have one bucket located in North Virginia, and the second one, this is our destination, located in Ohio. If I go to our first bucket and go to management, I can now create replication rule. First, we must specify our rule name, and let me add, for example, some random name. The status is enabled. Our source bucket, as you can see, is our first bucket, and you can see what region is, in what region is that bucket. So you can choose a rule scope to limit the scope of this rule using one or more filters, or you can apply to all objects in that bucket. So you can now copy all. This rule will be for all objects in that source bucket. In the destination, we must choose a specified bucket in another account or in this account. So we will use the first option in this account, and finally we will choose our bucket located in Ohio region, and this is our destination bucket, as you can see. Then the permission access to specific resources, you have option to choose a different resources. You can create a new role, choose from existing roles, or the first option is good. And finally, let's click on save. And then you can choose yes, replicated existing bucket. So I want to replicate all bucket from our source to our destination bucket, and that's it. And finally, let's click on save. But first we must again choose our destination bucket, and that's it. If you go inside this rule, you can see that status is enabled, and now action, you can also disable this, or you can edit this rule, replication rule, if you want, but I'm happy and I won't change anything, and that's it. Replication configuration is successfully added. And finally, if I go to our buckets, if I go to our destination bucket, after some time there will be objects from our source bucket. Just to remind you, if you go to our source bucket, we have our static website, but let me upload some more files. I will go to one of my folders, and I will add some random objects or pictures, and we successfully upload these objects, and you can see we now have 4 objects. I will now go to our destination bucket, and here you can see that we don't have any objects for now, but after some time there will be objects, as you can see, and this object is uploaded a few seconds ago, and all objects that we uploaded from our source bucket from US East is now in our Ohio region, as you can see. But in the meantime, let me go to my log bucket. As you can see, we don't have any logs for now, and sometimes it takes a few hours to get a first log, but as you can see, we successfully used our cross-region replication, and we successfully created our rule. And it's a very useful option if you need to copy more than one object. If you can see, our server logs are on, but we don't get any logs. This is from previous chapter, but if you go to management, you can see that we have our replication rules, and our replication rules are working perfectly. And I will now delete my replication rules because I don't want to replicate anymore. And as you can see, if I go to my first bucket, I can now delete this bucket. But first, if you want to delete this bucket, you must empty this bucket. Let's click on empty bucket, and then I will copy this permanently delete. So we are deleting our destination bucket because I don't need it anymore. And you must click on empty, and now you can delete this destination bucket. Also, I will now delete my log bucket because we are not getting any logs. But if you leave this bucket, for example, 24 hours, there will be logs, of course. Now I will enter the name of this bucket to delete it permanently. This is our log bucket from previous chapter, if you remember. And I want to delete every bucket and object just to have a clean slate for my next lab. And then let's delete our destination bucket. We must enter the name of our destination bucket and finally click on delete bucket. And if we go inside our first bucket, you can see that we have 4 objects. I will now click on empty bucket and finally copy this permanently delete into empty field and click on empty. Let's now go back and finally we can delete the last bucket. This is our source bucket for this demo. So this was a long demonstration and I hope this was helpful. And now we don't have any bucket in our AWS service, S3 service. Thank you for watching. If you ask yourself what is the difference between availability and durability, we will find out in the next few minutes or in this lesson. So availability and durability are key aspects of data storage, but they pose different challenges. Availability refers to the availability of data when it is needed, ensuring that systems are working, while durability focuses on preserving data in the long term, protecting it from loss or damage. Availability can simply be understood as the time of continuous operation of the system, the percentage of time that the storage system is available and operational, allowing access to data. Highly available systems are designed to minimize downtime and avoid loss of service. All organizations expect to achieve high availability of their applications and business services. This is not achieved with just one IT component. High availability depends on many IT infrastructure components, including hardware and storage software, to work as expected in concert, minimizing downtime by quickly restoring essential services in the event of a failure. Availability is usually calculated by the numbers of 9. So 1 9 is 90% availability, 2 9s are 99 availability, 3 9s are 99.9 availability, 4 9s is 99.99% of availability, and so on. The opposite of availability is downtime. So, if the storage system has an annual SLA of 7 9s, 99.79%, it would only have 3.15 seconds of downtime per year. You need to fully understand your business requirements and cost so that you can determine and set your availability goals. Service providers also offer availability SLA as part of their contracts. To improve accessibility, organizations generally use a replication technique that creates redundant copies of data to allow continuous access to data. Avoiding individual points of failure is key to improving data availability. Permanence refers to the continuous persistence of data. Businesses will have long-term data retention goals. This is achieved by improving the durability of data and the storage infrastructure that stores it, especially in the context of storage facilities where data is archived and stored for a long time. It is important to achieve greater durability. A high level of durability ensures that the data will not suffer from big rot, degradation, or any form of data corruption or loss. RAID alone will not be enough. By regularly backing up replication and deleting data objects and enable warm write once, read many, immutability, data durability can be increased. So, for durability, focus is uptime and system accessibility. The answer is the system operational and can I access my data? It is achieved through redundancy, failover mechanism, and robust infrastructure to minimize downtime. Example is a website that remains online and accessible to users. Metric typically measures a percentage. 99.99% uptime means minimal downtime. and one of the key concerns is ensuring the data is easily accessible when it is needed for work. Also, durability is a long-term protection and preservation of data. Answer the question, is my data safe from loss or damage? It is achieved by data weekends, keeping multiple copies, backups, and robust storage solutions. One of the examples is ensuring the data is not lost due to hardware failure or other problems. Metric, it is measured by the probability of data loss over a period of time. For example, this is a persistent of 11 nines, means a very low probability of data loss. One of the key concerns is protection of data from various threats such as hardware failures, natural disasters, or accidental deletions. So availability is about keeping your data running and ensuring that your data is accessible, while durability is about ensuring that the data itself remains intact and secure over time. One of the most important options in S3 are storage classes. So, if you want to know more about storage classes and know how to use them and take all benefits and look at economic options, then these storage classes are very important. So let's start. AWS S3 storage classes are different categories of storage within Amazon S3, each designed for specific data access patterns, durability, and cost requirements. They allow users to optimize storage costs by choosing the right classes to use their data. So let's learn more about storage classes. Amazon S3 offers different storage classes based on your cost and performance. Based on your business needs, you can choose exact storage class you need. The default storage class is a standard class where data can be accessed frequently whenever needed. The intelligence layer is one of the layers that is mainly used for data unknown patterns that will be stored as an intelligent layer where the data will change from access level, frequent, and rare access patterns. So S3 storage classes play a major role in cost-effective management. Different storage classes will have different access patterns. You can choose storage classes based on requirements depending on latency and bandwidth. Key features of S3 storage classes. So, storage classes are very beneficial and you can use it for durability and availability. You can access latency and performance, profitability, data download options, and for security and encryption. What are the types of classes? And here it is. We have Amazon S3 Standard. We have Amazon S3 Intelligent Tiering, Amazon S3 Standard Infrequent Access, Amazon S3 1ZO Infrequent Access, Amazon S3 Glacier Instant Retrieval, Amazon S3 Glacier Flexible Retrieval, Amazon S3 Glacier Deep Archive, and that's it. Now let's talk about first one, the right choice for frequently accessed data. It is used for general purpose and offers high endurance, availability, and object storage performance for frequently accessed data. The S3 standard is suitable for a wide range of use cases, including cloud applications, dynamic website, content distribution, mobile and gaming, and big data analytics. It is mainly used for general purpose to maintain durability, availability, and performance to a greater extent. Its applications are cloud applications, dynamic websites, content distribution, mobile and gaming, as well as big data analytics or data mining. Ideal use case for S3 standards. Amazon S3 standard storage class is a versatile and widely used storage class in Amazon S3, and here we can use some of the use cases. For example, you can host your static website, serving content distribution like network CDN or content delivery network, storage of frequently accessed data. You can build data lakes and data warehouses. You can back up your data, serving mobile and video game apps. Features of these S3 standards: the availability criteria are quite good, about 99.9%. It improves the recovery of the object file. It is resistant to events that are a little stronger and can affect the entire availability zone. The durability of S3 standard is 99.999999%. Then we have S3 Intelligent Tiering. This is automated cost optimization for data with unknown access patterns. First, Cloud storage automatically requires storage cost for the user. It proves it's a very cost-effective approach based on frequency, without affecting other performance. It also manages complex operation, so Amazon S3 Intelligent Tiering automatically reduces the cost of granular facilities. There are no download costs in Amazon S3 Intelligent Tiering. Features of S3 tiering are less tracking and automatic layer bidding is required, no minimum storage duration or recovery costs are required to access the service. The availability criteria are very good, such as 99.9%, and the durability of the S3 Intelligent Tiering is 99. As you can see, there is 10 nines, if I can see correctly. The third one is infrequent access, S3 standard infrequent access. This is a cost-effective storage for less frequently accessed data. To access this less frequently used data, users use standard S3 IA or instant access. Quick access is needed when you need to access your files, and by using this standard IA, we can achieve high power, high performance and low bandwidth. It is best for storing backups and recovering data over a long period of time. It acts as a data store for disaster recovery files. So it is very good for identifying the appropriate data for S3 standard rare access. And if you want to select which data type is suitable for S3 standard infrequent access, you can use this tier. It is good for access frequency, data size, access latency requirement, data durability requirements, features of S3 standard, high performance and same rate of action, and very durable in all AZs or availability zones. The availability is 99.9 in S3 IA, and you can see durability is 99.99 if I see correctly. The fourth option is S3 Glacier Instant Retrieval. This is good for high performance archiving with fast downloads. It is a class of archival storage that provides the cheapest storage for archiving data and is organized to give the highest performance and greater flexibility. S3 Glacier Instant Retrieval provides the fastest access to our archival store. Same as with S3 Standard, data download in milliseconds. Features of this option, of this storage class, is it only takes milliseconds to recover your data. The minimum size of the object should be 128 kilobytes. Availability is 99.9% in S3 Glacier Retrieval, Instant Retrieval, and durability is 99.999999. The fifth option for storage class is again S3 Single Zone Rare Access, storage optimized at price for one availability zone. So unlike other S3 storage classes that store data in at least 3 availability zones, this S3 Single Zone, as name suggests, store data in one availability zone and costs 20% less than S3 standard IA. It is a very good choice for storing secondary backups of local data or data that can be easily recreated. S3 Single Zone IA gives you the same high endurance, high throughput and low latency as the S3 standard. So features of this storage class that this class support SSL or secure socket layer for data in transit and encryption. Destroying an availability zone can damage your data because it is only available for one AZ, and availability is 99.5% in single S3 zone rare access, but durability is very good, 99.9999 and so on. The sixth option is S3 Glacier Flexible Retrieval. Here you can use this class for balancing cost and flexibility of archival downloads. It provides inexpensive storage compared to the S3 Glacier Instant Retrieval. It is a convenient solution for backing up data so that it can be easily recovered several times a year. It only takes a few minutes to access the data. Features of this storage class or S3 Glacier Flexible Retrieval: it has free recovery in large quantities. The destruction of one not Asian or AZ can lead to difficulties in accessing data. Availability zone can lead to difficulties in accessing data. So when you need to download large data sets, then the S3 Glacier Flexible Retrieval is best for backup and disaster recovery use cases. Availability is 99.99 with S3 Glacier Flexible Retrieval, and durability is 99.999999%. Then we have Amazon S3 Glacier Deep Archive. This storage class is designed to provide long-term and secure storage of large amounts of data at a price that is competitive with off-premises tape archiving services, which is very low cost. You will no longer have to deal with expensive services. Accessibility is very efficient, so it can restore data within 12 hours. This class of storage is designed in such a way that users can easily get long-term and more secure storage for huge amounts of data at a very lower cost. Efficient accessibility and the ability to restore data in a very short time, therefore its time complexity is also effective. The S3 Glacier Deep Archive also has an object replication function. Features of this storage class are that it offers a very safe storage, safer than other one. The recovery time is shorter, which requires less time. Availability is 99.99 in S3 Glacier Deep Archive, and durability is 99.99999%. So, depending on your needs, the S3 service offers a wide range selection of storage classes, and it's up to you to choose the one you need at that moment. As you can see, we are again in our console. In the search bar, I will type S3. Let's go to our S3. And I don't have any bucket, so we will create a new bucket right now. I will choose my USN North Virginia, US East 1. I will add my name for this bucket. It must be unique. As you can see, we are creating general purpose bucket. And here we can leave everything as it is. We will not enable our versioning. We will use server-side encryption with Amazon SS3 key. And let me just change my name because this name is already taken. And after that, we will be able to see and get to know more about storage classes. So I hope that this name is now unique. And finally, we will create this bucket. And let's go inside our bucket. And here we can upload some object. Click on Add Files. You can also add a folder if you want. And from here, let me go to my AI course. I will now let me just find some appropriate object. Here, it really doesn't matter what images we are using, simple 2 PNG files, and as you can see, we successfully uploaded our object. Let's click on Close, and as you can see, we have 2 objects. And now, if I check one of these objects, for example, IA certification, and go to Actions, you can see that we have something called Edit Storage Class. And right from here you can see a lot of options that you can use, for example, to rename objects and so on. Let me edit my storage class. By default, every object that you upload is uploaded in standard storage class. As you can see, this is designed for access data more than once a month with millisecond access, and it uses 3 availability zones. So you can also edit your storage class that creates a copy of object with updated settings and new, less modified date. Then in this table, you can see all options that we learned in previous chapter. There is something called intelligent tiering. When you change this, it is designed for data with changing or unknown access patterns, as you can see, and it uses 3 AZ. It also using this tiering and auto tiering fees So you will add your pay more per object and this fees applies for object more than or equal than 108 kilobytes. Then I already told you about standard IA. This is infrequently accessed data. IA stands for infrequently access, once a month with millisecond access. Then you can see what is availability zone, what is the minimum storage duration, and minimum billable object size. Retrieval fees, so you can pay per gigabytes if you want to retrieve your file. If you choose one of these archive file, first you must retrieve your files and then you can use this file. Then, as you can see, we can change easily between storage classes, and we have this for one zone. As you can see, this is the only class that is available for one zone. Then we have this Glacier instant retrieval, and minimum storage duration is 90 days, exactly just like Glacier flexible retrieval. This is a long-lived archive data that accessed once a quarter with instance retrieval in milliseconds. Then we have this Glacier deep archive. Minimum storage duration is 180 days. So that means that if you don't access your file in 6 months, that is 180 days, then this file or object will stay in this Glacier deep archive. As you can see, you will pay here for retrieval, and we have this reduced redundancy. This is a non-critical frequent access data with millisecond access, and this is not recommended as S3 standard, and it is more cost effective. Here you can choose additional copy. You can copy source settings and so on. So by default our objects are in storage class. I will now change my, as you can see, storage class. So we have intelligent tiering, and our AI certifications are now using intelligent tiering storage class. So here is standard, and choosing this storage class, it will really help you with your objects. And now imagine that you have millions of objects, and you can also use this lifecycle management to edit the storage class. For example, if you choose this initiate restore, then you can be able to use this option if you're using one of this archive class. So for example, let me choose my second object, and if you go, for example, to edit storage class, we can now choose a different storage class. Let me choose this Glacier instant retrieval. We will choose one of this Glacier retrieval and click on edit or save, and you can see we are now using Glacier flexible retrieval, formerly known as Glacier. And now if you want to use this option, you must first retrieve your file. So you must initiate restore, and after some time, as you can see, restore object from Glacier retrieval, you must add the number of days that to restore the copy is available. So when the restore request initiated, it temporary copies all of the file object that will be available for number of days that you specify in this request. So you need to add the number of days that restored copy is automatically deleted after a specified number of days. So for example, if you add 5 days, your copy will be available for 5 days, and you must choose your retrieval tier. Bulk retrieval, typically this file will be available between 5 and 12 hours. There is a standard retrieval, it needs 3 to 5 hours, or if you choose expedited retrieval, between 1 and 5 minutes you can retrieve this file if it's less than 250 megabytes. So I can now go to actions, and check initiate restore if I want to restore this file. As you can see, we can now change our storage class because first you must retrieve your file. And of course, I will now delete these files. And first we must empty our bucket. And that's it. This is how can you change your storage classes and choose the appropriate one. Just to remind you, if you retrieve your file, it really depends on the speed of retrieval, and then that will also affect the price of your retrieval. Now I will delete and copy the name of my bucket, but the best way is to use this standard, and this is the default option. Thank you for watching. In AWS S3, objects are basic storage units, which represent individual pieces of data such as files. Each object consists of the data itself, metadata or descriptive information, and a unique key identifier. They are stored in S3 buckets, which act as containers. Data, that is actual content of an object such as document, image or video. Metadata provides additional information about an object such as its name, content type and the date it was last modified. They are stored as a set of name-value pairs. Key, well, a key is a unique identifier that allows you to retrieve an object from S3 bucket. Essentially, it is the address of the object inside the bucket. S3 objects are not organized in the traditional file system hierarchy. Instead, they are stored in a flat structure inside the bucket, and they can be used to simulate the structure of the folder. For example, a key like documents/report.pdf would be interpreted by S3 as an object with the key documents/report.pdf rather than as a file name report.pdf within a name folder documents. Object in S3 can be range in size from 0 to 5 terabytes. If the object is larger than 5 terabytes, it must be broken into chunks and uploaded by using the multi-chunk upload API. Also, bucket is a container for, this is a mistake. It is a bucket is a container for objects and tables stored in Amazon S3, and you can store any number of objects in the bucket. General purpose buckets are the original type of S3 bucket, and one of general purpose bucket can contain objects stored in all storage classes except S3 Express One Zone. They are recommended for most use cases and access patterns. S3 directory bins only allow objects stored in the S3 Express One Zone storage class, which allows for faster processing of data within a single availability zone. They are recommended for use cases with low latency. Each S3 directory bucket can support up to 2 million transactions per second, or TPS, regardless of the number of directories. With the bucket, S3 spreadsheet bucket are purpose-built to store tabular data in S3, such as daily purchase transaction, streaming sensor or sensitive data, or add impressions. When you use a bucket of tables, your data is stored as an Eisenberg table in S3, and you can then interact with the data using analytics, capabilities such as row-level transactions, queryable table snapshots, and more, all managed by S3. In addition, table segments perform continuous table maintenance to automatically optimize query efficiency over time, even as data lake scales and evolves. In AWS 3, Glacier Word Lock is a feature that allows you to create written once, read multiple times, or worm policy for your Amazon S3 Glacier bucket, making the policy mutable once it's locked. This means that policy cannot be changed or deleted even by the root user in your AWS account, thus ensuring data integrity and compliance with the retention policy. What is the purpose of Glacier Lock? Well, Glacier Word Lock is designed to help organizations meet regulatory and compliance requirements regarding data retention by preventing accidental or malicious deletion or modification of archive data. How this works? First, you will create a Word Lock policy that defines how your archive should be handled, including retention period and access control. When a policy is locked, it becomes immutable, enforcing these rules. Key feature of worm. This ensures that data is written to the vault, it cannot be altered or deleted, which is crucial for compliance. Also, the vault lock policy itself cannot be changed once it has been locked, providing a strong guarantee of data protection. Vault lock or this Glacier lock help organizations meet compliance requirements data related to data retention and immutability, such as those in the financial services and healthcare industries. And Vault Lock is integrated with the S3 Glacier and can be used in other AWS services, such as AWS Backup for comprehensive data protection. Well, in this section, we will get to know the Snow family. What is Snow and what are their offerings? Well, the AWS Snow family is a set of physical devices designed to move large amounts of data in and out of the AWS cloud, especially in situations with limited or no internet connectivity. It also enables edge computing and on-premises data processing in remote or disconnected environments. The family includes Snowcone, Snowball, and Snowmobile, each offering different storage options and capacities. To move massive amounts of data in and out of the cloud without relying on networks, Amazon has created the Snow family of physical devices. This allows you to use your data with a wide range of Amazon Analytics, file systems, and archiving services. Large-scale data transit and on-premises storage are well suited for this, for use cases such as sophisticated machine learning and video analysis entirely disconnected environment. Snowball Edge Compute Optimized device offer 52 of vCPUs and 42 terabytes of usable block or object storage, and an optional GPU. The tractor-trailer is used to transport AWS Snow mobile containers for shipping. These services can assist with initiatives involving data migration, disaster recovery, data center shutdowns, and remote data collection. The AWS Snow family is just a collection of physical devices that help organizations transfer large amounts of data to and from AWS cloud. It is designed for environments while traditional network connectivity is insufficient or unavailable. AWS Snow family is often used for large-scale data migrations, processing at the edge of the network, or in remote locations where network bandwidth is limited or unreliable. AWS Snow family devices are rugged, portable, and secure, designed to handle challenging environments while ensuring secure and efficient transmission. So, some of the features of the Snow family are convenient management and monitoring, easier device tracking, automatic 256-bit encryption is used to protect all transmitted data. Snow devices act as NFS or network file system endpoints for applications, and this is a very reliable platform modulated to help maintain data confidentiality. What is the advantages of this Snow family? It is easy to manage and track, embedded computing, encryption, tamper protection, follow-up from start to finish, and secure deletion. The AWS Snow family is ideal for large-scale data transmission and edge computing in a variety of scenarios. These devices are designed to address specific challenges, especially in environments where reliable network connectivity is limited or non-existent. Here is some of the relevant use cases for the Snow family. So, for example, if you have an organization that needs to move massive amount of data from on-premises environments to AWS clouds, then the Snow family provides a very convenient solution. You can use it for disaster recovery and backup, for example. So the AWS Snow family is very effective for disaster recovery efforts. Enterprises can back up critical data using these devices in low bandwidth or disconnected environments. Edge computing in remote locations, in remote access, such as oil platforms, military bases, and research stations, Snowcone and Snowball can be used for edge computing tasks. Internet of Things, of IoT data collection and analytics, organization can use the AWS Snow family of devices to collect as well as store and process Internet of Things data in areas with limited connectivity. AWS Snow family offers flexible and cost-effective pricing based on the type of device being used and the type needs of your data and computing task. The pricing structure is designed to ensure that customers only pay for the services they use, making it an effective solution for various data migration and edge computing needs. So, what is AWS Snowcone? This is the smallest device in the Amazon Snow family of edge computing and data transmission equipment is the AWS Snowcone. Snowcone is versatile, reliable, and safe. Snowcone can be used to collect, process, and transport data online via Amazon Data Sync or offline by shipping devices. Snowcone is a compact, reliable solution for edge computing and data storage, as we already said, and it can be used to send data online or offline by sending devices to AWS. Because these locations often lack the capacity, power, and cooling needed for the data centers, IT equipment running applications in sterile or non-data centers, environments at the edge of the network, where reliable network access is lacking or when bandwidth is limited, can be difficult. The AWS Snowcone is a small, portable device designed to transfer data between on-premises location and the AWS cloud, making it ideal for use in areas which limited or do not have any internet connectivity. So, you can see the diagram below for a visual explanation or how Snowcone works, demonstrating its data transfer and edge computing capabilities. Also, you can also use AWS Snowball. So what is a Snowball? This is an option for large amounts of data that are sent to Amazon Web Services using AWS Snow Mobile, an exabyte scale data transfer service up to 100 petabytes of data that can be sent with each Snow Mobile. It is a truck with a semi-trailer that pulls a robust 14-meter-long shipping container. Internet faster data transfer between Amazon Simple Storage Service S3 and your on-site storage location is possible with AWS Snowball using physical storage devices. The physically rugged devices called Snowball are provided by AWS Key Management Service or AWS KMS. Your data is safe and secure during transit. Snowballs are shipped from Amazon S3 to your on-site storage facility through local delivery companies. You can also see AWS Snowball in AWS official site for list of AWS regions where Snowball is available. Using AWS Snowball would help you save both time and money. You can use Snowball robust interface to create trades, track data, and monitor the progress of your trades all the way to completion. You order the device to load your data onto it and return it to AWS, where they upload your data to the cloud. This process helps you to avoid slow internet transmission, making it ideal for migrating large data sets of operating in areas with limited internet access. And finally, the most funny one is AWS Snowball. This is a physical, as I already told you, data transfer service designed for a large-scale data migration to the AWS cloud. Essentially, it is used to provide a 14-meter-long shipping container that can transmit up to 100 petabytes of data in a single shipment. AWS Snowball is ideal for industries that needs to move massive amount of data, such as media, entertainment, or the government sector. It offers a high level of security, including encryption, GPS tracking, and security to ensure that your data is securely transported to AWS data center. AWS Snowball works by physically transferring large amounts of data from your location to AWS data centers. Also, you can see the diagram and see visual explanation of how AWS Snowmobile works. The AWS Snow family offers a suite of physically robust and portable devices designed to help organizations to move a massive amounts of data to and from the AWS cloud securely and efficiently. From the compact Snowcone for edge computing and small data transfers to the versatile Snowball for medium-scale migrations and the massive Snowball for a petabyte-scale migrations, that Snow family provides scalable solutions tailored to different business needs. Whether you need to migrate data, enable edge computing in remote locations, or provide secure storage and transportation, the AWS Snow family simplifies this process, improving flexibility, security, and cost effectiveness for your cloud journey. AWS Storage Gateway is a hybrid cloud storage service that connects on-premises IT environments to AWS Cloud Storage, providing a bridge between your data centers and the cloud. It allows you to use cloud storage as if it is on-premises storage using well-known storage protocols such as SMB, NFS, and awscloud, while also benefiting from the scalability and cost-effectiveness of AWS. So key features and benefits of Storage Gateway is that you can use hybrid cloud storage, and it allows you to use cloud storage for on-premises workloads, expanding storage capacity and simplifying data management. Then you will use familiar storage protocols. As I already told you, it supports standard protocols such as SMB, NFS, and awscloud, allowing you to integrate with existing application without major changes. Also, it reduces local storage cost by moving data to the cloud and using AWS storage services such as Amazon S3. Data durability and availability of AWS storage services for data backup and data recovery, and you can use different types of passes. It offers different types of gateways like volume, file, and tape to meet different storage needs. It is very good for low storage latency caching, allows you to cache frequently accessed data locally, ensuring low latency access for your application. There is 3 types of gateways. I already told you. File gateway, it allows file-based access to your data stored in Amazon S3 using NFS or SMB protocols. Volume gateway offers block storage volume supported by Amazon EBS or Amazon S3 that can be accessed via awscloud. And Tape Gateway, this is a virtual tape library or VTL interface to your backup applications, allowing you to migrate tape backups to the cloud. You can use Storage Gateway, for example, for backup and archive. You can move backups to the cloud, reducing local storage requirement and simplifying data protection. You can use it for data recovery, use cloud storage for disaster recovery, ensuring businesses continuity in the event of local failures. For cloud migration, you can gradually migrate your application and data to the cloud using Storage Gateway as a bridge. Also, you can use and develop applications that span both on-premises and cloud environments, so it is very good for hybrid cloud apps. Essentially, AWS Storage Gateway simplifies the integration of on-premises storage with AWS Cloud Storage, offering a flexible and cost-effective way to manage your data and applications in a hybrid cloud environment. So, that was a very long and extensive information about databases and other services based on data in Azure. But now we will hop to AWS. But first, let's learn what are the types of databases are offered to users in AWS. Well, AWS offers a wide range of databases types to meet the needs of various applications, including relational, NoSQL, in-memory, graphic, time series, and ledger databases. Popular options include Amazon RDS or Relational Database Service, Amazon Aurora, a relational database compatible with MySQL and PostgreSQL, Amazon DynamoDB, NoSQL database, Amazon Elastic Cache, in-memory data storage, Amazon Redshift data warehouse, and Amazon Neptune, which is graphical database. Of course, all of these databases are simply, I cannot show you everything, and we will see the most popular databases, and I will show you how they work. Of course, how can you create them step by step. Some of them will be created, some of them not because of price. But first, let's look at a detailed overview of some key types of the AWS databases. First, we have relational databases. Here we have Amazon RDS or Relational Database Service. This is a managed service that simplifies the setup, operation, and scaling of relational databases in the cloud. It supports multiple databases, systems such as MySQL, PostgreSQL, MariaDB, Oracle, and SQL Server. Then we have Aurora, Amazon Aurora. This is a relational database compatible with MySQL and PostgreSQL built for the cloud, which offer high performance and availability. Also, there is also a large amount of NoSQL databases. First one is Amazon Database DB. This is a fully managed NoSQL database that delivers fast and predictable performance with seamless scalability. It is ideal for applications that requires access to data with low latency. Then we have in-memory databases. This is Amazon Elastic Cache. This is a fully managed in-memory caching service that improves web application performance by allowing you to retrieve information from fast managed in-memory caches rather than relying entirely on slow disk-based databases. And other types of databases are Amazon Redshift. This is a fully managed petabyte scale data storage service designed for large-scale data analysis. Then we have Amazon Neptune. This is a fully managed graphical database service for building and running applications that work highly connected database sets. Amazon Document DB is a database service that is compatible with MongoDB workloads. Then we have Amazon TimeStream. This is a fully managed time series database service for IoT and other applications that generates timestamp data. And we have Amazon Quantum Ledger DB or QLDB. This is a fully managed ledger database service that provides a transparent, immutable, and cryptographically verifiable log of transaction. These are just a few examples of the many database options available on AWS, each designed to meet specific application needs and performance requirements. Just like in Azure, it is almost impossible to show you all the offer that we can and what we can do with databases in Azure and AWS. I will show you the most important one, and if you want to learn more about databases, there is a lot of other courses. I create especially 2 courses for databases, for SQL database offer and Cosmos DB in Azure. But if you want to learn more about databases in AWS, then you will have to find another source in Udemy platform. Thank you. Let's learn about relational database service in AWS. Amazon Relational Database Service, or Amazon RDS, is a fully managed service offered by Amazon Web Service that simplifies the process of setting up, operating, and scaling relational database in the cloud. It provides automated tasks such as backups, software updates, and scaling, allowing users to focus on their applications rather than database administration. Amazon RDS supports various database systems such as MySQL, PostgreSQL, MariaDB, Oracle, SQL Server, and DB2. Amazon Web Service offers Amazon RDS service that is fully managed by AWS and also offers a wide range of databases, and you can see what you can choose from. Also, AWS will take care of the backup and data and infrastructure, scaling and load balancing. Security is very high and data will be encrypted at rest. And also data access can be controlled with the help of IAM, this is Identity and Access Management. DR, Disaster Recovery, will automatically take over by AWS. Traditionally, database management used to be a very dispersed service from the web server to the application server, finally to the database. It took a team to maintain such a huge system and to reduce the number of employees. AWS came across an incredible all-in-one service, RDS, so Relational Database Service. The entire architecture of RDS incorporates every aspect of a traditional management system, all in its place. So it includes everything from EC2, Elastic Cloud, Compute Cloud, to DNS, Domain Name System. Each part of the RDS architecture has its own distinct set of functions that are completely different from each other. So Amazon RDS use shared responsibility model. This means that this model divides responsibilities between AWS and the customer, ensuring the security and availability of data services. So, for AWS, they're responsible for managing the infrastructure that includes the underlying hardware, data center, and network security. AWS also handles database software installation, remediation, and automated backups. This includes managing physical security in the event of a failure and ensuring high availability. We as a clients, we have our own responsibility, and we are responsible for managing the data stored in the database, including encryption, access controls, and compliance with data management policies. Clients also need to configure security settings, fine-tune database performance, and optimize queries to ensure official use. This model ensures that AWS provides a secure and reliable platform, while also giving customers control over their data application-specific configuration and access management. There is a few examples of how can we use Amazon RDS in AWS. We can use it for web application. So Amazon RDS is mainly used for the backend of web application, where it can support a minimum number of input and output operations. It's also easy to scale. Instead of you managing the database, AWS will provide Amazon RDS as a service by simply configuring your database so that your database will be available to perform an operation. Also, isolation is considered, so you can integrate and configure multiple applications with secure isolation by protecting each isolation or application user data while managing the underlying infrastructure at the same time. Also, you can use Amazon RDS for domains like healthcare and banking, because the data used in this type of application is very secure, which can be achieved with the help of AWS RDS. RDS offers features such as automated backups and replication to improve database availability and data durability. RDS provides a familiar environment for those who are already using these database systems, allowing for a smooth transition to the cloud. With RDS, users only pay for the resources they consume, eliminating the need for upfront investment. RDS allows users to easily scale their databases instance based on their needs, providing cost-effective and variable capacity. In the next chapter, we will learn about deployment options in RDS. Welcome back. We are again in our console. As you can see, it's time to see RDS service. So, in the search bar, or simply if you click on this hamburger menu, click on all services, you can see all services by category. And here we will find our databases, and as you can see, there is a lot of option for databases. But for now, we will use Aurora and RDS. And of course, you can choose between various options, but if we go back to our first page, main page, and type RDS, you'll find Aurora and RDS. Let's go inside our service, and here in this dashboard, you can see all resources that we use here, or we are using on RDS service in the Northeast North Virginia region. So as you can see, you can choose within various services, and you can see what are used and how many quotas do you have for this region. For example, for DB instances, you have 0 terabyte of 100 terabytes, sorry, and you can see how many DB clusters, reserved instances, snapshot, DB clusters, instance, and so on. So here you have some kind of example, or how to say, a better view of how much resources are you using in this service for now. And right for here, you can create a database and see all service health of your databases. Also, here you can see what are recommendations for you, and if you click on one of these links, you can go to official AWS pages, and you can see all about Amazon RDS backup and so on. If you click on database, you can see that right on here we can create our new database. So if I click on create database, we can choose a database creation method. You can choose from standard or easy. If you choose standard, then you will set all the configuration options, including ones for availability, security, backups, and maintenance. But if you choose easy create, then you will use recommended best practices configuration. So some configurations will be added by default, and you can then change them later when you create your desired engine type or database. Then the most important thing here are database engine or engine type. We will use standard create, and here you can choose between 8 engines. First, we have our Aurora, which is MySQL and PostgreSQL compatible. This is official AWS offer. And then we have MySQL and PostgreSQL official engines, MariaDB, Oracle, Microsoft SQL Server, and IBM DB2. So, as you can see, the first Aurora offer or engine type is AWS offer. Other 6 are official engine types from these companies. So, if you choose some of these engine type, you can choose a various versions that support the following databases, and this is, for example, if you choose Microsoft SQL Server, you have option to choose between Amazon RDS and Amazon RDS Custom. The first option is that RDS is fully managed your database. This is a PaaS offering, so including automatic patching. And here, if you choose RDS Custom, then RDS manage your database, and you as a user have this privilege to access the operating system, and you can use this option if you want to customize your database, operating system, infrastructure. So it is very good option. Then in addition, if you choose Microsoft SQL Server, you can use SQL Server Express Edition, Web Edition, Standard, or Enterprise Edition. It really depends on what you need. Of course, a license is included for this SQL Server Express Edition, and if you choose these other options, you have option to add your license. Also, you can choose between various SQL engines. So, for example, you can choose from SQL Server 2019 to SQL Server 2022, and license included, of course. Then in the templates, you can choose free tier. So you will use this free tier to develop this new application. Then you will, in the settings option, you must add a name for all your databases. You must add your credential, as you already know. This is a master username, and here you can add your credential management. You can create, of course, manage in AWS Secret Manager. This is most secure, so RDS generates a password for you and manages through the life cycle of this AWS Secret Manager. And you can specify your own or create your own password, and here you can auto-generate password or add your own password. Of course, you need to confirm your password because this is the most secure way, and you can avoid any confusion. So I will now confirm my password, and then we will scroll down. This is just a testing, as you can see. Password that we mainly use in this demonstration, and it's a weak password, but of course the password, both passwords must matched. Let me scroll down. Here we have instance configuration, so you can choose your DB instance class. For example, you can use these burstable classes. Automatically it will use db.3 micro with 2 vCPUs and 1 GB of RAM, and you can see what is our network, up to 2085 megabytes per second. Also, if you choose a different image engine, you will use, or you can use a different type. Also, if you use a free test, this is a free version of this machine. For the storage type, automatically it is set up to use general purpose SSGP2 storage, and we have 20 gigabytes of allocated space. For the connectivity option, you can choose if you want do not connect to an EC compute resource, or you can connect to an EC resource. Is really up to you if you want to connect to your EC2 compute resource for this database. Then you will choose your EC2, and this is our virtual private cloud. This is default for this region, and here we have something called DB subnet. This is by default. The DB subnet defines your IP address and so on, and here we will choose our security group. This is default, and we are adding our public IP address to this database. You can choose if you want availability zone. You can create your proxy. Also, there is certificate authority. Using a server certificate provides an extra layer of security, of course. And here you have option to choose one of these 6 availability zones, because North Virginia region has 6 AZs. And then there is additional configuration. You can set up a really RDS option in great detail, and of course here you can see what is the database port. So 1433 is a port that will database use for application or for some connection, and this is the official port of SQL Server. And also you can enable MicroSQL Server Windows authentication if you want. Here you can choose to use your AWS Connect option and so on. You can add tags, and for the monitoring we will use this tool. You can use advanced or standard option, and your logs will be stored here. You can enable performance insight. Retention period is 7 days, and you can see visualize the database, load, and so on. So we will use retention period for 7 days, and of course AWS KMS key is required. This is our account, this is our key ID. As you can see, AWS RDS will create a new key in our key management service. And that's it. This is how can you create your... Also, there is additional configuration. You can configure backup, encryption, and so on. How much do you want to retain? How much is the retention period for your backups that will be automatically kept on S3 service? And here any encryption is enabled. As you can see, you can also check your maintenance if you want to enable version. If new version is up, then it will automatically upgrade to the newest version. And here you can see what are estimated monthly cost for this RDS. You can try this for free, as you can see, and that's it. We completely set up our Microsoft SQL Server. Also, you can choose different engine, MySQL, and here you must choose your engine version. Then there is an option for templates. You can now you have production and free tier, and then you can choose between these options how to choose between one AZ and multi-AZ. Then you can choose your database name, then choose your password name and user credentials, of course. Then you have option to choose your machine types, and here you will also choose another one. Now db.tg4 micro is available, and of course you can choose what type of storage do you want to use, how much allocated space do you want, and of course you can choose your connectivity type, network type, what do you want to add for this, and how much. You can also enable this storage scaling. Finally, you will choose your VPC, public access, existing security group, availability zone, and database authentication, monitoring option, just like in our previous example when we see how can we work with our SQL server. Now you can export these logs if you want, audit, error, general, or slow query logs. And finally, you can see additional configuration, and as you can see, this is also a free offer for 12 months, sorry. And if you hit on create database, you can now create this database based on MySQL image. And just like that, we create our database, and there is suggested add-ons for this database, but let's wait until this. Here it is. Our database is successfully created, and now this is our database based on db.t3 micro. This status is available. As you can see, this is MySQL engine. And here you can go inside your database or simply scroll left to right to see all other information. This is our default VPC. We don't use multi-AZs, so we only have write option. And here you will see what is our name, how much CPU are we using, what region and AZ are we using, what are our engine, class, status. And here there is a lot of information in these tabs. What is our network type, endpoint, port is 3306 for MySQL databases. You can check your security, certificate authority, and all other information considering connectivity and security. Also, there is a lot of tabs that you can go and see what are, for example, monitoring. You can check your all monitoring option here. And of course, monitoring is very important when you are using databases in any cloud. And for example, you have option to download you can install this SQL Server Management Studio, for example, and you can use this program to securely connect to your SQL Server, for example. And you have option to download from your local machine, for example. And you will use this endpoint to log in to some other official software that you can use, for example, to query this database and so on. Also, if you go to monitoring option or tab, as you can see, we are using CloudWatch, and in CloudWatch you can check all information, how much is disk space, if you want to see your burst or credit balance, CPU credit usage, data connectors, and so on. So here you can turn this on, this alarm notification, and you will see your metrics here, how much do you use and how do you use. Also, you can investigate, see your logs, metrics, and so on. So this is just a tour in this database. And here, as you can see, this is our recent event that we started, created, and finished this instance. And this is our logs. As you can see, we have 3 logs that is located and stored. Here you can also see our recent events and choose from out of this custom range. Also, you can set up and CloudWatch alarm, for example. And here are our configuration of our database. And you can see that what is our configuration, what is our instance class, what is our primary storage. Of course, you can do a failover to a secondary storage if you want, but you must enable this feature first. And here are more informations about this database that we just created. We don't have any IMDB authentication because we are not enabled this option. Here are our primary storage. As you can see, we are using AWS KMS key. And here we can view the integrations for our account. You can create zero extract transfer load integration with some other. You can integrate this database to some other service in AWS and also see the full option of this in official Microsoft pages. In the maintenance and backup, you can see that AutoMiner version is upgraded. This is our maintenance window, and we don't have any pending maintenance for now. And for the backup, it is automated backups included by default on one day, and you can see where is our backup window and last restore time. So if someone happened to your database, you can always use this latest restore that is automatically created. You can see this is our snapshot, and you can recover your database from this snapshot. And then we have also, as I told you, this maintenance. If you have some minor version upgrade, this will automatically update your database and your EC2, because basically this database is running on EC2 instance. And here are recommendations. You can set up this option if you want to get your recommendations. If I go to modify, we can modify this database, and as you can see, we can change everything that we set up during the creation of this database. And when you finish, you can simply go to continue, and that's it. In the query editor, you can use this query editor in your console to query some of these instances. If I go to events, you can see what are events that is available for this DB, and when this data is created, when the first automated snapshot is created, and so on and so forth. Then you can subscribe to one of these events. If you click on subscription, you need to add a name for this event, choose your email topic, for example, and choose what is the target of your event subscription. So you will get subscription. If you subscribe to some of this event, you will get notified if something happens. Also, in the recommendations option, this list will include this certification. Also, you can see what subnet are we using. We don't have any parameter group for now, and this is our option group. Also, there is a lot of options that you can create and use in this. Also, this is our automated backup. You can see when this database is backed up, and this backup is automatically backed with our AWS. So you can use this action to restore the point of time or manage cross-replication, region replication. So if you want to replicate this database to some other region, you will use this option to manage this cross-replication, and this is a very, very good option. And if you want to restore to point in time, if something happened to your database, you can use this restore to point in time and go back to the previous version before some accident happened to your database. Also, you can export this all to S3 options, and in the performance insight you can see all other options. Of course, you can take a snapshot, and here you can create a database, and right from here you can create your database and add your objects here, and you can work with database. So this is how can you work and create a relational database in AWS. And now we can simply delete this database if you want and create another one, or you can simply practice if you want. But the most important thing, this is the way how can you create one of these relational database. And now I want to delete this database. Simply check this box before database 1, for example, and now if you want, you can go to actions and simply click on delete, and this will delete. Also, you can take a snapshot right from here, restore to point in time, migrate this snapshot, create read replica, create Aurora read replica, create blue-green deployment, use RDS proxy, Elastic Cache cluster, and so on. Reboot or temporarily stop this. And here we need to type delete to confirm this deletion. And as you can see, we need to proceed with this download. First, I will go here and now we can delete our database. I don't want to create a final snapshot, so now I am able to write delete me, and finally we will be able to delete this database. Thank you for watching, and I will see you in the next chapter. Welcome back. In previous chapter, we already saw how can we create a databases based on different engines. Now let's talk about the deployment options in relational database service in AWS. First, we have multi-AZ with one backup server. We have multi-AZ with two readable backup servers, and we have multi-AZ database clusters. Also, read replica are also available for scaling RAID operations. That's the main thing. But now let's see what implementations option we have in this service. First, as I already told you, this is a single availability zone. This option is most cost effective and is best suited for development or staging environments where high availability is not critical. It includes a single instance of a database in a single availability zone. Also, we have multiple availability zone with a single backup instance. This ensures high availability and automatic switching in the event of failure. So, if a backup instance is created in another availability zone and the data is synchronously replicated to it, in the event of a failure, the RDS automatically switches to a backup instance, usually within 60 seconds. So, if one zone goes away, then this backup instance is automatically created in another availability zone. And we have multiple availability zones with two readable backup instances. This offers the benefits of multiple availability zones with a single backup instance, plus improved performance. It includes two readable backup instances in different availability zones, along for faster failover times, typically under 35 seconds, and providing additional read capacity. We have multi-AZ database cluster. This option builds on multi-AZ implemented systems by adding read nodes, allowing for increased read capacity and improved performance for read-high workloads. Then we have replicas to read. So, read replicas are read-only copies of your primary database instance. They are used to offload read traffic from the primary instance, improving performance and scalability for applications with a high number of read. So imagine if you have, for example, two databases. Imagine if you have one database first, how much time it takes for your, for example, application or something else, to write all these requests, and then in the same time it must read those requests for some other request. Then this second replica is great because all read information will be offloaded to that secondary instance. So the first or the primary instance will only be used for writing, and this read will only be for the second instance will only be for read replicas, and the whole system will be much faster. And then we have blue-green deployment implemented system. This option provides a way to securely test database changes in a staging environment before they are promoted to production, minimizing the risk of downtime during updates. Then you must consider some option if you want to excel at, for example, availability. So with multi-zone deployments, these are critical for production workloads that require high availability and automatic switching to backup instances. Performance with multi-zone with two readable backup instances and multi-zone database clusters offer performance improvements, especially for read-high workloads. So if you have high demand on these options, then these multi-zone with 2 reliable backups are very, very great for your app. Then, when we talk about cost, single zone deployments are most cost effective, while multi-zone options incur additional cost for backup instances, for example. And we have disaster recovery option or consideration with multi-zone deployments. You can combine with read replicas in other regions to create a robust disaster recovery solution. So if one data center or region goes down, then this read replica will be your saving solution. Also, what deployment option you want to choose is also depending on your needs. As an individual or as a company, in consultation with DB experts, it is the best to opt for one of these options available to you in AWS. When we talked about RDS service, we saw something called Amazon Aurora. Let's talk about this offer. Well, Amazon Aurora is a cloud-based relational database service offered exclusively by AWS. It combines the performance and availability of high-end commercial databases with the simplicity and cost-effectiveness of open-source databases such as MySQL and PostgreSQL. Aurora is designed for high performance and scalability, offering features such as autoscaling, encryption, and replication across multiple availability zones. The Amazon Aurora is packed with high performance subsystems, and these are MySQL and PostgreSQL mechanisms that take advantage of fast distributed storage. Aurora provides speeds and bandwidth up to 5 times faster than MySQL and 3 times faster than PostgreSQL with an existing system. It amplifies high storage capacity, which can scale up to 64 terabytes of database size for enterprise deployment. Amazon Aurora is a fully managed by Amazon Relational Database Service, or RDS, which automates tedious administrative tasks such as securing hardware, setting up databases, repairs, and updates. So, when you create Aurora, you don't have to worry about this because this is a PaaS offering. Amazon Aurora is built on an innovative distributed architecture that separates the storage and computing layers of the database engine. The storage layer is distributed across multiple replicas, while the computing layer works on instances that are separated for storage layer. These architectures allows storage and compute resources to be scaled automatically and independently, and also provide better fault tolerance and availability. What are the key features and benefits of Aurora? Well, if we talk about high performance and availability, Aurora is built for speed and reliability and offering up to 5 times the throughput of standard MySQL and 3 times the throughput of standard PostgreSQL. Scalability automatically scales storage up to 128 terabytes and computing resources based on workload requirements. Aurora is compatible with both MySQL and PostgreSQL, allowing for easy migration for existing databases, so it has some open source compatibility. It is a fully managed, so as I already told you, AWS performs tasks such as patches, backups, and switching to backup, freeing up developers or users to focus on application development. Aurora is designed to be cost-effective with pricing based on actual use, so we'll use pay-per-use model. You will pay only what you're using. When we talk about security of Amazon Aurora, it provides multiple layers of security, including network isolation, encryption, and access control. Also, this database or this service offers global database and the ability to replicate data across multiple AWS regions for improved disaster recovery and reduced latency. Aurora Serverless version 2 allows for automatic scaling of computing capacity without downtime of manual intervention. Vector database capabilities can be used to build generative AI applications, which its vector database capabilities. Also, let's talk about how this service works. Aurora uses a distributed, fault-tolerant, and self-healing storage system that is separate for computing resources. Data is also replicated across multiple availability zones for high availability and disaster recovery. It provides the ability to restore database to a specific point in time. And backups are automatically done by Amazon S3 service, and you can use this storage service to backup your data. So an Aurora database cluster consists of a primary database and a replica of the Aurora database and a cluster volume for processing data for those instances of the database. The Aurora cluster volume is definitely not a physical but a virtual database storage volume that spans different availability zones to better support applications around the world. Each zone has its own duplicate database cluster information. A primary database is a place where all read and write operations are performed through a cluster volume. Each cluster in Aurora will have one primary database instance. It is an equal replica of the primary instance of the database whose only responsibility is to simply provide the information, like read operations only. There can be 50 replicas for the primary database instance to maintain a high availability across all zones. In a fail-safe state, Aurora will move to a replica when the primary database is unavailable, and replicas help to reduce the read load compared to the primary database. There can be also a cluster with multiple masters for Aurora. In multi-master application, all instances of the database would have the read and write capabilities. In AWS terminology, they are known as read-write database instances. The user can configure to keep a backup copy of their database on Amazon S3. This ensures the security of the user database even if the worst case is when the entire cluster fails. For unpredictable loads, the user can use the Aurora serverless to automatically start scaling and shut down the database to align with the application requirements. In the Amazon RDS share responsibility model, AWS and customer share duties to ensure the database availability and performance of database services. AWS manages the infrastructure as a customer take control of their data and database management. So Amazon Aurora use a pay-per-use pricing model, which means you will only pay for the resources that you actually use. Here's a quick overview of the main factors influencing the Aurora price. So we have instance pricing. Aurora charges based on the type and size of the instance you choose, with different prices for MySQL and PostgreSQL compatible instances. Larger instances cost more, but they also provide higher performance. Also, there is a storage cost. Aurora automatically scales storage according to your need and usage and charges you per gigabyte of storage usage. The advantage is that you only pay for the storage you need. The backup storage. Aurora includes automated backup at no additional cost for the same amount of storage as your database. Additional backup storage is charged per gigabytes. Also, you are charged for input-output operations or request or I/O request and operations performed by your database, and Aurora offers cost effectiveness by using optimized I/O operations for high performance. Data transfer between Amazon Aurora and other AWS services is generally free within the same region, while fees may apply for data transfer between regions. Essentially, Amazon Aurora is a powerful and flexible relational database service that delivers the performance and reliability of commercial databases while simplifying database management and reducing costs. Well, if you go back to our console, you can see that we are now in our Aurora and RDS. If you go to database and click on create database, you can see that we are using standard option to create a database, and then we have this engine option. We have Aurora MySQL compatible and Aurora Postgres compatible. If you choose the first one, you can choose your engine version, and then from the templates you can use, for example, production and dev test. But first, here are offers for engine version, and you can use this default version 8.0, and this is of course Aurora MySQL. And you can enable RDS extended support, but this support is a paid offering, and you will be charged if you run your database in a major version, the past RDS, and of course you will be charge for this. In the templates, I already told you that you can use production and dev test. You can use this production for high availability, fast, consistent, and here you can use this dev test template for development. And this is a great option, of course. If we choose production, then we have the option to add a name for our database. Then in the credential settings, you need to add your master username. And finally, this credential management. You can choose to use this manager in AWS Secret Manager, or this generates a password or you can create your own password with self-managed. Here I will provide my password and confirm my password, but for now let's stick with this auto-generated password, and this auto-generated password is also a good option, but the most secure is this first one. For the cluster configuration, you can use Aurora IO optimized or standard. With this optimized option, you pay for predictable pricing for application, and as you can see, there is no additional charges, for example, read-write IO operations. DB instance and storage prices include input-output usage. On the other hand, Aurora Standard is a cost-effective pricing for application with moderate IO usage, and here you will pay per request input-output, and for DB instance and storage prices does not include this input-output usage. So it really depends on your need, and it's up to you to choose your storage configurations. So we have two options, optimized and Aurora standard. If I scroll down, we have something called instance configuration, and here you can choose your instance if you want to use serverless, memory optimized, classless, includes R classes, or burstable classes, and here you will have to choose your service type or your machine type, virtual machine type. As you can see, this is all very powerful machines, because this database needs some power to run, and the power we are getting from our virtual machines. Also, in the availability and durability option, you can choose to create multi-AZ deployment to create an Aurora replica or a read or node in different AZ. This is good for scale availability, and as you can see, you can choose the option to don't create an Aurora replica, so it will use only one AZ. And here you can choose your connectivity type. You can also choose your network type, virtual private cloud, and also you have to choose if you want to have a public access or not to your database. And as you can see, with the dual stack mode, you can use IPv4 and IPv6. Also, when you choose your VPC, it is recommended to choose your security group. You can choose your default group in that region, or you can create a new one. Also, this certificate will be created, but this is an optional. I will leave everything as it is. And there is also a few additional configuration if you want to choose this. And so, as you can see, there is a lot of options that we can use in Amazon Aurora, and it really depends of your need or your company needs, but this is the process of how can you configure your Aurora, Amazon Aurora. And of course, we are not getting into detail to how can we work with this. This is our database port 3306, and also the point of this demonstration is just to show you how can you create a resource, not how can you work with this database resource. So I won't create any database, I won't add any files or values or something else. Also, If you want to use tags, database authentication, you can choose monitor. We already saw this when we work with RDS official engines, and here with MySQL engines, and here you can choose your CloudWatch, or you can export this log for audit error, general instance, slow query log, and so on. You can use, of course, DevOps Guru for RDS to detect performance anomalies, and here are tag keys, and you can see the price for DevOps Guru pricing. This is a cost per hour. And in the additional configuration, you can also check your database option, turned off your encryption, failover. You can turn backup, check your maintenance, check your CloudWatch, delete protection, and so on, so on. There is a lot of options that are offered in Aurora Amazon. Also, as you can see, this is the estimated monthly cost for DB instance. It's almost $2,000 per month, but it is a very expensive service, so I won't click on create database, because as you can see, if you click on this Amazon Aurora pricing, you can check your pricing for this, and also, as I already mentioned, this is very expensive service. So if you use Aurora MySQL or PostgreSQL, if you choose PostgreSQL, you can see that we are getting exactly the same price for both Aurora options, and it really depends if you want to create this, but I won't click on create. So this is our option. How can we create Aurora database? So in this chapter I want to show you how can you create MySQL database on your EC2 instance. So once again, as you can see, we are in our console, and we will go to our EC2 service. And if you go to instances, or quickly click on launch instance, we can launch our instance. First, we need to add a name for our instance. This will be VMDB1. I will choose my image, Amazon image. This will be based on Ubuntu. We will use our t2.micro instance type. And if I scroll down, you can see that we need to create our key pair login. If you don't have one, if you have existing, simply choose from this drop down menu. This is a very required for this demonstration, and we will use this RSA key pair. As you can see, it is downloaded on my laptop, and simply I will scroll down and click on launch instance, because we are using the default VPC and security group. If you check your logs, you can see that everything was successful. Let's go inside our instances, and this is our VMDB1. We have public IP address, as you can see, and everything else. Let me go to my Elastic IP. I will click on allocate IP, so it will use some address from Amazon pool. This is a simple IPv4 address. And finally, let's go to actions and associate this Elastic IP with our instance. Our VMDB1 instance is running, and this is our private IP address. Let's click on associate. So we are adding our Elastic IP to our newly created DB VM. I will now go back to our instances, and if I refresh this page, you can see that we have different public IP address, IPv4 public IP address, and that's it. Our machine is still a phase of initializing. And of course we need to wait. If I go to my startup and type putty, I can run this program, as you can see. But first, in the putty gen, I will run my putty gen. let's click on load, and we will choose our Linux key in my download. This is our VMDB key pair. And finally, let's click on save private key. So we will save our private key to our download folder, and let me add my name for this key. This will be VMDB, for example, key. That's it. And now we can go inside our PuTTY configuration. Let me find appropriate field. There is a really lot of options, and sometimes even I get distracted or confused. So we need to find our place where we will be upload our private key to this PuTTY. And if you go to auth credentials, let me browse my private key for authentication. We will use our VMDB key. And finally, let's go to session. Let me copy my public IP address of this VMDB. And we will paste this here and click on open. I will accept this and type my Ubuntu login, and finally we are logged in on our VMDB via PuTTY, as you can see. And now we can run our command. Let me just make a little order, and here I can run this information. First, I want to update my system. We will run sudo apt update. At the same time, I am recording this on Serbian language, so this material will be affordable to you to download this on English. So do not worry, simply follow these steps. First, we are downloading the necessary packages to our instance, and then we will run sudo apt full upgrade to upgrade our server or instance. We need to confirm with yes. So we need to wait for this upgrade to finish this progress, and then we will install MySQL Server. Sometimes it really takes time, sometimes it's faster, but patience is a key. Then the next step I want to do is to install MySQL Server. So we will run sudo apt install mysql-server, and this will install MySQL Server on this VM. I will type on yes. And once again, we need to be patient. To finish with this installation. Then I can run, for example, this sudo MySQL. So we want to create password for the root user, and you need to add your password. My password is testing and 123, so there is a double command, so I will delete the second one. Unintentionally I'll add this, and now we can simply copy this once again, this command. So you can see we are now in MySQL, and then we will run this command to create our base table, and we will add some values in that, or insert some values in that table. So I will now exit from my SQL server. I will run sudo system status MySQL. As you can see, it is running. MySQL community server is running, and now I can run sudo MySQL to log into my SQL, and then we can log in or simply run this command again. So now we can create this user. Finally, we will create our database. This will be MyDB. Then I will use my DB table. This is the next command. And then we will create our database. As you can see, this is our whole command. And then we will insert some information in our column. And finally, we will run select from star from our table name, and our table name is, let me just check, we need to add our table name here. Select star from the name of our table. You will add, or you need to add whenever you're using, and here it is. This is our table. As you can see, MySQL table on, or MySQL database that is running on my EC2 instance in AWS. So, as you can see, it's very easy to create this table, and with the help of few commands, you can create tables or databases and tables. But just to remind you, this is just a sample, or this is just a lab. You can create more complex table, but for that, Amazon Elastic Cache is a fully managed in-memory caching service provided by Amazon Web Services. It allows users to easily set up, manage, and scale distributed data storage or in-memory caches to improve the performance of web applications. Elastic Cache is compatible with Redis and Memcached, popular open-source caching engines, and by using Elastic Cache, application can access data with microsecond latency, significantly reducing load times and improving overall performance. So caching is the process of storing data in a cache. It allows you to quickly reuse that data that has been previously obtained or calculated. Normally, all data is stored in the main memory of the system, but caching reduces the entire process of searching with the help of a cache. In simple terms, caching reduces the search bandwidth of the desired data. A cache is a high-speed data storage layer in computing that stores a piece of data that is often temporary in nature, so that subsequent requests for the data can be processed faster than accessing the primary data storage location. There are some database queries used by users which are inherently slower and cost more than any other user queries. By caching query result, users can only pay the price of a query that is used once. Then the user can quickly retrieve the data multiple times, but there is no need to re-execute the query. Amazon Elastic Cache is a fully managed in-memory caching solution that supports a variety of customizable real-time use cases. Amazon Elastic Cache has the ability to manage, deploy, and scale a distributed cache environment in the AWS Cloud, and it can be used for caching, which improves the speed of application and databases, or as a master data store for use cases such as session stores, game leaderboards, streaming, and analytics that don't need stamina. Amazon Elastic Cache allows its users to use Redis and Memcached cache engines. Redis is an acronym for Remote Dictionary Server. Dictionary refers to data structure of a dictionary. As we all know, dictionaries work on the mechanism of a key-value pair, just like Redis. It is an open-source in-memory data structure that implements the caching process. Amazon Elastic Cache with Redis is fully compatible with open-source data formats, APIs, and clients. Memcache is also a caching system for memory management. It is often used to speed up dynamic database-driven websites by caching data and objects to minimize the number of times an independent data source must be read to get values in a web application. Memcache is a simple but powerful memory caching system. Its simple design promotes rapid deployment, ease of development, and overcomes the many problems associated with huge caches. Its API is available in the most common languages. So, the pros of Elastic Cache is high performance. So, Elastic Cache will allow you to cache frequently accessed data in memory, reducing the latency, improving the performance of your application. Scalability. Elastic Cache provides a highly scalable cache environment, allowing you to increase or decrease the size of your cache cluster as needed to accommodate changes in traffic or load. Also, this service is designed to provide low latency for your cache operation, making it suitable for applications that require real-time access to data. It's a fully managed service, which means that AWS take care of infrastructure, remediation, and backups, allowing you to focus on your core businesses. Also, this Elastic Cache service is very easy to integrate with other AWS services, so you can integrate AWS Elastic Cache with EC2, RDS, and Lambda, making it easy to build scalable and highly available applications. Elastic Cache has some limitations to consider. For example, it is a caching service, not a persistent data store, so it's not suitable for storing data that must survive a cache cluster restart. So it means if you restart your service, all cached memory, all cache will be erased from that memory. Elastic Cache is a regional service, so you can't use it to cache data in different regions. And once again, we are in our console. As you can see, we can go to search option and type Elastic. Here you must provide a name Elastic, so we are now in our Elastic Cache service, and here you can see what is the price or pricing for this service. Let's go to Elastic Cache, and here you can see, or you can choose one of the following options to create a cache. Also, there is an option to save your money if you choose this Valky option engine, and this is open source established under the Linux Foundation. It is fully compatible with Redis operating system. So, in the engine, you can choose Valky, Memcached, or Redis. If you choose Valky, you can choose between serverless option, as you can see, or you can design your own cache. You can also see that if you check Memkey, you will get exactly the same deployment option. And here with serverless, you can use this to create a quick cache that automatically scale to meet your traffic demands with no server message, or you can design your own cache. You can choose by your node type, size, and count. In the creation method, you can restore some old data from .rdb file into a new cache, or simply create a new cache. If you choose to design your own cache, as you can see, there is easy create option. cluster cache or restore from backup, as I already told you. And this is a bit different between serverless, and you can design your own cache. Here you can choose your restore option from Elastic backups or other types of backups, and here just check your snapshot. Choose your snapshot. If you choose the new cache, here you must provide your name, details, engine version, and in the default option you will see value and what is editable after creation. So with Velki you can't edit engine, availability zone, encryption in transit, encryption at rest, and so on. All other settings are editable. So we have engine version you can choose, and security group, automatic backups, and usage limit. If you choose custom settings, here, as I already told you, you can choose your connectivity. This is our default VPC for North Virginia, and in the availability set you can check your availability zones. So if you go and check these boxes, then this Velki will be available in these availability zones. Also, you can manage your own subnets for this availability zone. From the security standpoint, you can use default security settings, and you can customize your own. As you can see, we are using encryption at rest. Our encryption in transit is enabled, and security group is for now default. So we are using again default security group for North Virginia region. Also, you can enable automatic backup, and Elastic Cache will automatically create a daily backup of your cache, and you can choose the number of days which automated backups are retained before they automatically delete. So the minimum is 1 day, and you can choose up to 30 days if I remember correctly. And you can specify the start time for your backup if you want in that time. So 35 days is our retention policy, and I will now show you how can you specify that start time. And for example, you can set up that daily time to automatically backup your Elastic Cache, for example, every day in 8 hours PM or AM, sorry. And of course, you can choose a minimum or maximum data storage to limit your cache. And when these limits are set up, you can, or your cache cannot be scaled beyond that limits that you add in your usage limits option. Here it is. And of course, you can, for example, add your data storage and the usage. So this is how can you create a Velki. In the mem cache, there is also option to design your own cache or serverless cache, new cache, restore all backup cache. It has almost the same options, just like Velki, but this time you can choose between different options. And the last one is Redis. For the Redis, we have also exactly the same options, but as you can see, AWS preferred Velki. I don't know why, but I guess there's some commitment to AWS, so you can also check Redis serverless and design your own cache. In the AWS, we have Redis as a separate service. So in the default settings, you can see that we have what engine are we using, and you can also customize these default settings. But this was a quick example or walkthrough how can you work with Elastic Cache. Thank you for the next offer in databases are DynamoDB and DEX. So to manage data, DynamoDB uses a hashing B trees. Although DynamoDB supports JSON, it only uses it as a transport format. So JSON is not used as a storage format. JSON stands for JavaScript Object Notation, just to remind you. Much of the exact implementation of DynamoDB storage format remains proprietary. So generally, the user doesn't need to know about it. But data in DynamoDB is generally exported via streaming technologies or downloaded in bulk to CSV file or comma-separated value files via extract transform load tools such as AWS Glue. As a managed service, the exact nature of the data on the disk, just like the rest of the system specification, hardware, operating system, etc., remains hidden from DynamoDB end users. So, unlike structured query languages, SQL, DynamoDB queries uses the JSON format to structure their queries. In DynamoDB, you would redesign the data model so that everything is in a single table, denormalized and without joins. This leads to a lack of deduplication that you get in a normal database, but it also makes the query much simpler. DynamoDB is a key-value pair NoSQL database. First of all, this makes it Amazon preferred database for simple and fast data models, such as managing user profile data or web session information for applications that need quickly to download any amount of data on the internet. This database is so popular for this use case that it is ranked among top 20 databases listed on dbengines.com. So, NoSQL database. DynamoDB, as I already told you, is a NoSQL database, which means that it does not use traditional relational structure with tables, rows, and columns. Instead, it is used a key value or document data model. As a serverless service, DynamoDB automatically manages the underlying infrastructure, so you don't need to worry about server provisioning, software updates, or capacity management. DynamoDB is designed to automatically scale to handle virtually any amount of data and traffic. It distributes data and traffic across multiple servers to maintain consistent performance. DynamoDB is known for its speed and low latency, offering consistent performance from a single-digit milliseconds. It's a fully managed service, which means that AWS handles all operational aspects, including infrastructure management, backups, and security. It uses key-value data models and documents, so you can choose that one the best suits for your data structure. You can create secondary indexes for data queries using attributes other than the primary key, allowing for more flexible query options. Also, DynamoDB supports ACID, that stands for atomicity, consistency, isolation, and durability transaction, ensuring data consistency and reliability. DynamoDB offers a free tier that includes 25 GB of storage and 25 units of provided read-write capacity, making it a good option for experimentation for a small-scale applications. AmazonDB, as we already know, is a serverless NoSQL database service that allows you to develop modern applications of any size. As a serverless database, you only pay for what you use, and DynamoDB scales to 0. No cold start, no version upgrades, no maintenance windows, no patches, and no maintenance during downtime. Amazon DynamoDB Accelerator, or DEX, is a fully managed, highly scalable caching service built for Amazon DynamoDB. DEX provides performance improvements up to 10 times, from milliseconds to microseconds, even at millions of requests per second. DEX does all the work or hard work needed to add in-memory acceleration to your DynamoDB tables without the need for developers to manage cache resets, data filling, or cluster management. Since DEX is compatible with existing Dynamo API calls, no modification of the application logic is required. Similar to DynamoDB, you only pay for the capacity you provide. You can focus on building great apps for your customers without having any worrying about performance at scale. If you've been following the course in details, now it's realistic to wonder what the difference between the DEX and Elastic Cache. Well, Amazon DynamoDB Accelerator is a DEX, or DEX is a fully managed in-memory caching service specially tailored for DynamoDB. Amazon Elastic Cache is a versatile caching service that supports various mechanisms such as Memcache and Redis and Valky, as you can see, offering a wide range of applications in addition to DynamoDB. In the next chapter, we will talk about Amazon Redshift. If you go to our console and go to search bar and type DynamoDB, you will see that we are using this service for managed NoSQL as a NoSQL managed database. So if you go inside that service, you can see that we don't have any table, and if you want to get started, you will hit on create table, and you can create a new table, of course. Here we need to provide some table details. So as you can see, DynamoDB is a schemaless database, and it only requires a table name and primary key when you create this table. I will add my name for this table. Here we need to provide a partition key. So the partition key is just a part of the table's primary key. It is only a hash value that is used to retrieve items from your table and allocate data across host and scalability option. You can choose between binary, number, or string. I will use my string, and here let's add, for example, user ID. You can also use a sort key, and you can use sort key as the second part of the table primary key. I won't do that, but you can choose table settings in default settings, and this is the fastest way to create your table. You can also modify this later when you create this table, and if you don't know what to do or want to customize your settings, you can use this advanced feature to specify even more options, and then, as you can see, DynamoDB will work better for you or for your needs. Here we can choose our table class. There is DynamoDB standard or DynamoDB standard IA. The first one is the default general purpose table class, and it will use for majority of tables for storing frequently accessed data with throughput, reads and writes, and the dominant table cost. And we have this DynamoDB standard IA, which use for if you want to store infrequent data. Of course, you can choose your default option, and here we can see what is our default settings and what is editable after creation. So as you can see, only local secondary indexes are not editable, but our value is a table class, capacity amount, maximum read capacity, maximum write capacity, global secondary indexes, encryption key management, deletion protection, resource-based policy is editable after you create this table. So you can see this is a very scalable, and this DynamoDB has a very great feature. Let's click on create, and here we are creating our table, and we need to wait for this blue information to become green. Here it is. Our table was successfully created. As you can see, this is the name, this is the status, it is active, this is our partition key. We don't have any sort or key or indexes, we don't have any replicated region. You can check this to favorite. Read capacity mode is on demand, write capacity is on demand, and table class is standard. As you can see, we don't have any information or data in our table. So let's go inside our table, and here you have this general information, and this is our table, as you can see. And right on here we can, as you can see, edit this information, edit our capacity, read-write capacity, check our auto-scaling options. We can even add something called warm throughput. If you have, you can increase the warm throughput. For example, if you have some peak event, then this will be very available. Then here you can turn on this delete protection, check your delete items with time to live. you can choose how much this data will or item will be available. For example, if you set up for 50 minutes, then after 50 minutes, because of time to live, we'll delete all these items. And here you can choose your encryption or manage your encryption key. So you have very and also tags are here, of course. If you go to manage encryption, you can choose this encryption set owned by Amazon key, DynamoDB, sorry, or add Amazon managed key, or you can store your account, and here this key you can add your own key. Also, there is something called PTR. You can start or scan your database, of course. If you can see, you can edit our PTR, and this is a point in time recovery, so you can use this as a backup. You can see, you can monitor our database. There is a lot of CloudWatch metrics that we can set or see how our database is running, and we can check every detail in this graphic. In the global tables, you can also create a replica. So in the backups, as you can see, this is an option, as I already told you, point in time or PTR, and it provides continuous backup of our Dynamo database. You can schedule your backup or create on-demand backup of this table. And also you can export this to S3, and in the permissions you can add IAM access if you want, or create a resource-based policy for this data. If you go to actions, you can create an item. For example, delete table, create an index, create replica, and so on. Let's create one item, for example. As you can see, our user ID is our partition key, and here I can add a value, type is string, and here I can add, for example, my name, and click on create item. As you can see, just like that, we created our item, and this is our user ID. I can also edit this item or create a new one if I want. Let's add a new attribute, and here you can choose between string, number, boolean, binary, null, string set, number set, binary set, list, or map. Here I will choose my number. Let me add my user ID. Value, sorry, we don't have to, it's not a good option to duplicate our attribute name, so I will add, for example, name, and here for the value I will add number 10, or you can add different value. Here will be add 10, sorry, and here I will add, for example, number for this attribute name. And now if I click on create item, or simply let's see that we must provide key attribute for this user ID, I will now add some different value, or again check my number. In here, sorry, I will add a number 10, and here we can provide, for example, some different name. And if you click on create item, you can see that we create our item. So the other user ID, we have number 10, and that's it. You can see how it's easy to add your items, and you can create new attribute, add some different type of this attribute. Here you can add your value. This will be another name, for example. This will be string, and in the attribute name you can add again number. Let's add Maria. Here we will add some number again. This will be, for example, number 10. Let's add a new attribute. This time I will, for example, add another string. Here I can add another attribute name. Let's add the last name, and for example the last name of this Maria person, this imaginary person, will be Danik. If you click on create, you can see how it's flexible and easy to work with these items, and how you can expand and add more and more columns to this item or values to this item. Also, you can see what is the option that we have. The result, it is completed. You have 1 item returned, 1 item scanned, efficiency is 1%, and how much RCU is consumed. And here you can run and filter your items. And if I go to particle editor, you can also run a query against these tables. As you can see, also there is a backup section, so we can create backup from here or export our jobs from the last 90 days to S3. You can choose, for example, this demo table, and we must first turn our PI tier or point in time recovery to be able to run this, to export these details. So we need to provide our bucket name. I don't have any bucket. I will just want to show you how can you do it. Then the process of this exporting. Now you have to add your you can choose from different account or this account, and if you want to choose between export, you can choose the full export of this table or only incremental. It will only export data that's changed with a specific period of time, and you can choose your time and export the data file. I won't export this, just wanted to show you the way. Also, you can import the tables from some other source. This source is, for example, S3. If you have this exactly the same table in some other region or some other account, you can also import this, and as a Dynamo JSON, Amazon Ion or CSV, you can import file compression, no compression, gzip or zstd, and that's it. You can specify table details, then configure table settings, go to review and support, and click on import. Also, if you go to DAX, you can see that we have something called clusters, subgroup, parameters, and you can also work with event. So as you can see, DynamoDB is NoSQL key pair or key value database that is very easy to set up and very easy to work with. As you can see, this is our demo table. I will now check my table and delete our table. Here we need to confirm this table, to confirm this deletion, and finally I will hit on delete to delete this table. And just like that, as you can see, our request is successful and we don't have any tables. After this, that all our items will be deleted, and with our demo table, or you can download this item to CSV, for example. But I already deleted my table and all items are also deleted, so you can export your all items for this table in CSV file and you can continue to work on your local machine. So this was just a simple demonstration how can you create and work with DynamoDB in AWS. Thank you for watching. AWS Redshift is a fully managed petabyte scale cloud storage service provided by Amazon Web Services. It is designed for fast and cost-effective data analysis, allowing users to analyze all their data using standard SQL and existing business intelligence tools. Redshift is optimized to handle large amounts of structured and semi-structured data, making it suitable for a variety of analytical workloads. It is a fully managed service where AWS manages the underlying infrastructure, including setup, maintenance, and scaling, allowing users to focus on data analysis. Redshift is designed to handle huge data sets ranging from a few hundred gigabytes to petabytes and more. Also, it is a centralized repository for storing and analyzing large amounts of data, commonly used for business intelligence and reporting. Redshift is designed to be cost-effective, offering competitive pricing compared to traditional local data warehouses. It uses standard SQL for queries and data analytics or analysis, making them available to a wide range of users and tools. Also, Redshift is optimized for online and analytical processing or OLAP workloads, which involve complex queries and aggregation on large data sets. Also, Redshift can be integrated with Amazon S3, simple storage service, to directly query data from data lake without loading it onto tables. Amazon Redshift provides a serverless option, allowing users to analyze data without having to secure and manage clusters. The data stored in Redshift is encrypted for security reasons. Also, Amazon Redshift allows you to query and combine petabyte structured and semi-structured data in your operational database, data warehouse, and data lake using standard SQL. You can save query result back to an S3 data lake using open formats such as Apache Parquet or optimized row columnar org, which allows you to execute additional analytical queries. It uses massive parallel processing or MPP technology, and like most AWS services, is easy to deploy with just a few clicks, with plenty of options for importing data. There are also numerous tutorials to help you quickly figure out how to run Redshift cluster in minutes. It delivers high-end performance, and which is imperative for businesses today. It is also known for its affordable prices. So according to AWS, Amazon Redshift has up to 3 times better price-performance ratio than other cloud storage, and the price-performance advantage improves as you expand from gigabytes to petabytes. How does it work? Taking advantage of proprietary hardware and machine learning, or ML, the Redshift database uses the AWS Nitro system to accelerate data compression and encryption, query analysis, and graph optimization algorithms to automatically organize and store data for extremely fast result. In addition, Amazon offers Aqua or Advanced Query Accelerator that opens in a new tab, distributed and hardware accelerated cache that allows Redshift data queries to execute up to 10 times faster than the other enterprise cloud data warehouses. It speeds up scanning, filtering, and aggregation operation, and Amazon reports that it will speed up more operations in the future. Overall, Amazon Redshift is easy to use, that handles the vast amount of big data that businesses generate and consume, and reduce the need to manage infrastructure. Amazon Redshift and Amazon Simple Storage Solution are two of the most popular storage solutions provided by AWS. Although both are designed for data storage, they serve different purposes and are optimized for different use cases. Here, now we will talk about detailed comparison to help you understand the difference between features and functionality. So, when we talk about purpose and data type in Amazon Redshift, we use this service primarily for structured data. So Redshift is similar to a data warehouse. It offers tools for real-time analysis and predictive analysis. The data within Redshift must be structured in a predefined format. Amazon S3, as you also know, is a versatile, capable of entering structured, semi-structured, and unstructured data. It functions more as a data lake, storing data from a variety of sources, including videos, images, and log files. When we talk about data storage capacity, Amazon Redshift is a columnar database in data warehouse, and Redshift is optimized for online analytic processing or OLAP. Its columnar storage facilitates faster data aggregation, allowing analysis to execute complex queries quickly. S3 is an object storage solution, ideal for storing different types of data. It is commonly used for extract, transform, load data pipelines. Some example for use: Amazon Redshift is already structured. Data within Redshift is already structured, and it provides quick insight and forecast. It can feed data directly into business intelligent tools. S3 is used by organizations to consolidate vast amount of different data formats in a single repository. Analytical tools can then be used on this data to gain insight, and data lakes such as S3 are preferred because of their ability to process unstructured data, flexibility, accessibility, and the ability to store large amounts of data for predictive analysis. When we talk about cost structure, Amazon Redshift works on hourly pay model starting at $0.25 or $0.25 per hour. The price varies depending on the type of node and the number of nodes in the cluster. But in Amazon S3, we offer or often pay or use a pay-per-user model, making it affordable storage option. Users only pay for what we consume, with no minimum fee. Data lakes such as S3 often prove to be more cost-effective for companies with diverse and extensive data. In conclusion, while Amazon Redshift is tailored for structured data analysis and storage, Amazon S3 provides a flexible storage solution for a wide range of data types in a data lake environment. The choice between these two largely depends on the specific needs for the organization or data storage and analysis. If you go to search bar and type, for example, Redshift, you can see that we have this Amazon Redshift, that is a service was fast, serverless, and cost-effective SQL analytics and data warehouse. Let's click on our link, and just like that we are in our Amazon Redshift service. But if you want to get more about this Redshift service, then you must know that this service is very expensive. But if you want to learn how to work, you have a great offer. This is an offer for free trial, so you can activate this Redshift serverless, and it will give you the $300 of credits, as you can see. So here you can simply click on try serverless Redshift for free trial, and you can continue working with this service, of course. But this is only available for the first time, so if you want to use this for 30 days, you can click on try Redshift.
It's easy to run and scale analytics in data warehouse. We could use the default settings for a quick and easy setup, but let's walk through customizing our own settings for this demo. First, we'll configure a namespace, which is a collection of database objects and users that groups together various storage-related objects like schemas, tables, and data encryption keys. We'll call it My Redshift Namespace. Next, we'll configure our admin user credentials. Let's leave the admin username alone, but check the box to have Redshift generate a secure password for us. We can also associate IAM roles to load and unload data or interact with related services like Amazon S3, CloudWatch Logs, SageMaker, or AWS Glue if needed. Finally, instead of using the default encryption keys, let's choose our own custom AWS KMS key. After configuring the namespace, we need to configure a workgroup, which we'll call My Redshift Workgroup. A workgroup is a collection of compute resources like RPUs, security groups, and VPC subnets, which we've also selected. Enhanced VPC routing forces Redshift to route all copy or unload traffic that goes between our cluster and data repositories through our VPC. We'll leave that setting turned off, as we won't be running any copy or unload commands in this demo. Finally, we'll click Save Configuration, and in just a few minutes, our serverless Redshift cluster is ready to go. Before we jump into our cluster and try out some queries, let's see how easy it is to set the base capacity for our cluster and improve the overall query performance. We just click on our workgroup name from the dashboard, switch to the Limits tab, then click Edit to change the base RPU capacity from the default of 128 to the new value of 200. Now, let's open the Redshift Query Editor v2 and run some queries. In the query editor, we can see the default dev database's public schema is empty. Let's open the sample data dev database and load the ticket sample data, which is used in most examples throughout the Amazon Redshift documentation. Finally, let's run the sales per event query, which will show us the total ticket sales for each event in descending order.
So as you can see, this was official video of Amazon Redshift. It's better to see their official video. Thank you for watching. Amazon Document DB is a fully managed MongoDB compatible NoSQL database service offered by Amazon Web Services or the AWS. It is designed to store and query JSON documents at scale, making it suitable for a variety of applications such as content management, user profile management, and web mobile applications. Document databases are useful for applications that require queries and storage of large amounts of data. This data can be semi-structured or unstructured, such as gaming apps, social media apps, and web apps. These types of databases are also called non-relational or NoSQL databases. Just to remind you that non-relational databases offer some key difference from traditional relational databases. Relational databases typically store data in tables with fixed rows and columns. Rows represent the complete records and columns represent an attribute of the record. Alternatively, non-relational databases can store data in charts, key value pairs, and documents. Storing documents in a document database is similar to using JavaScript object notation or JSON object. JSON is a lightweight data exchange format that is easy to read and write. This similarly makes document databases a good choice for application that needs to store data that is easily readable by humans. Here are some of the benefits of using document databases in the concept of their JSON-like documents. Documents are a natural way to model data that is complex or unstructured, such as user profiles, like names, email address, and phone numbers. Also, document databases have a flexible schema. They can change the structured data or data structures without recreating the database, making them a good solution for evolving applications. Without the fixed schema, you have the flexibility to define a relationship through code so that you are not limited by limitations of table definitions. Indexing and how you store data provide speed and performance optimization for queries. Certain types of data are ideal for this formatting and structure. Document databases typically have an expressive query language that allows the users to examine the data in a variety of ways. This makes it easier to find complex or even unstructured data. Amazon Document DB is a fully managed NoSQL database service designed to manage JSON data at scale. It offers compatibility with MongoDB, ensuring a seamless transition between several applications. Amazon Document DB is defined by its basic distributes. So we already I was already told you that this service is a fully managed NoSQL database service. So the AWS managed operational aspect of database startups such as cloud, backups, patching, and scaling. This allows businesses to focus on application development. Built to manage JSON data at scale, it is designed to handle massive amounts of data in JSON format while ensuring high performance as the volume of data grows. MongoDB is Amazon Document DB compatibility with MongoDB application programming interface or APIs ensure that businesses using MongoDB can be easily switched to Amazon Document DB without significant code change-ups. Although both Document and DynamoDB databases are part of AWS Database Service Suite, they cater to different needs. DynamoDB is a key value database in documents and is designed for extremely high performance at any scale. It offers a high level of versatility, supporting both document data structures and key values. In contrast, DocumentDB is a pure document database specifically tailored for JSON-like document data. It is optimal for programs that include complex queries and data modeling capabilities. Amazon DocumentDB offers the performance, scalability, and availability, security, and compatibility of MongoDB with the ease of use and management of other managed services. DocumentDB is an excellent choice for a wide range of applications, including big data, gaming, real-time web and mobile apps, online shopping, advertising, social media, content management, personalization, catalog, and IoT. The features and capabilities of Amazon DocumentDB make it a top choice for businesses looking for a long-lasting cloud management solution. Whether you're switching from MongoDB or starting over, Amazon DocumentDB offers the tool and performance needed for efficient cloud storage, enable businesses to grow and scale their cloud environments in the most optimal way possible. So, this was just a theoretical part because it is almost impossible to show all offers in AWS. Amazon Neptune is a fully managed graphic database service offered by Amazon Web Services or AWS. It is designed to efficiently store and navigate through highly connected dataset, making it suitable for applications such as recommendation systems, fraud detection, and knowledge graphs. Neptune supports popular graphics query languages such as Gremlin, OpenCipher, and SparkQL, and offers features such as high availability, scalability, and integration with other AWS services. Amazon Neptune is a high-performance graphic database designed from the ground up. It is designed to handle graphical queries, to expand read capacity and execute more than 100 queries per second. Neptune supports up to 15 low latency read replicas spread across 3 availability zones. As your requirements change, you can quickly scale your database deployment from smaller to larger instance type. It is fully managed by Amazon, so Amazon Neptune simplifies the operation of high-performance graphic database. Neptune eliminates the need to generate custom indexes on your graphics data. To mitigate the impact of queries that consume too many resources, Neptune includes a timeout and memory consumption limit. What are the benefits of AWS Neptune service? So, it supports Open Graphic API. Amazon Neptune supports both Gremlin and SparkQL Open Graphics API and provides high performance for graphic models and query languages. Amazon Neptune, as I already told you, is a high performance graphic database designed specially and specifically for Amazon. You can scale read capacity and choose your read replicas that is spread across 3 availability zones. So Amazon Neptune is a highly available, long-lasting and compliant with ACID standards. Just to remind you, ACID stands for Atomicity, Consistency, Insulation and Durability. Neptune is built to provide more than 99.9% of uptime. Amazon Neptune offers multiple levels of security for your database, including network isolation via Amazon VPC IAM authentication for endpoint access and HTTPS encrypted client connections. You don't have to worry about database management tasks such as securing hardware, updating software, setting up, configuring, or backing up with Amazon Neptune. AWS prioritizes cloud security above all else. As an AWS customer, you have access to a data center and network architecture designed to meet the needs of the most security-conscious organization. AWS is in charge of protecting the infrastructure that enables the delivery of AWS services in the AWS cloud. AWS also provides you with security services as part of the AWS compliance program. Independent auditors regularly test and verify the effectiveness of your security. The AWS service you use determines your responsibility. Other factors such as sensitivity of your data, your company's requirements, and applicable laws and regulations are also your responsibility. So, with Amazon Neptune, there are no long-term commitments and prepaid costs. When you use on-demand instances, you only pay for databases on an hourly basis. It's easy to create and run applications that were highly connected databases for such users as identity graph, knowledge graph, and fraud detection. This frees you from cost and complexities associated with planning, purchasing, and maintaining hardware, and turns what are usually large fixed costs into much less variable cost. Pricing for primary instances, which are used for read and write workloads, and Amazon Neptune replicas, which are used to scale reads and improve fallback transition, are the same. Multi-AZ deployments cost no more than the price of the primary instance plus the price of each Neptune replicas. Me recommends that you place at least one replica in a different availability zone than the primary instance to maximize availability. Let's go to our search bar and try to find our AWS Neptune. As you can see, if I type Neptune, we'll get fast and reliable graph database that you can work in the cloud. Let's click on Neptune link, and here, as you can see, we can create our Neptune database cluster. So here are some basic information, how it works, how to get started, what is the cost of the service, what are benefits and features, and the most use cases that you find on official pages. If you go to clusters, you can click on create database, for example. I will now click on create database, and here you can add some specification to this image or instance. You can see the definition, what is Neptune and what are you getting with Neptune. Here you can use different type, of course, of Neptune. You can use provision Neptune or serverless Neptune, and you can choose between different engines. It really depends of what are you want to do, but the best thing is to use this default option chosen by AWS. So as you can see, it really doesn't matter which type of Neptune offer are you using, serverless or not. In the templates option, we have production and development and testing. You can use this production for high availability and fast consistent performance, and development is intended for development and testing. Here are our cluster name and DB instance name. You can change if you want. And here we have option to add our cluster storage configuration. We have Neptune standard and Neptune IO optimized. With the IO optimized, we are using predictable pricing for all application. As you can see, there are no additional charges for read-write operations. DB instance and storage prices include in our IO or input-output usage, and in the Neptune standard, this is a cost-effective pricing for many applications with moderate IO usage and so on. If I scroll down, you can see our instance option. Here we have memory optimized classes or burstable classes. This is first one is R and X class of our instances, and the second one is T class. You know this burstable option when we work with our EC2 service. In the availability and durability option, you can choose between multiple options to multi-AZ deployment. You have option to create a read replica in different AZ or availability zone, or you can check no. In the network and security, of course, you can add your own VPC, your subnet group, and here you can choose VPC security group. You can create your new security group or create a new security group, sorry. By default, as you can see, default security group is added in North Virginia region. Here we can also customize our encryption using our AWS KMS key, and we can also add a tag, or simply you can add your additional settings. So you can choose this availability zone for improved high availability, and this is our TCP IP port for our Neptune database. Also, you can create a notebook if you want. This will create a Jupyter notebook for query your Neptune database, and here there is some additional settings to add DB group parameters, to check your backup retention, export your logs. You can also turn this minor option for upgrading, or you can turn on deletion protection, so this database can be deleted when deletion protected is enabled. And this is the whole process of how you can create this database. This was my intention, just to show you. Of course, you will hit on create database, just to show you how can you create database. But if you want to learn more, then you will find these examples on official AWS documents. And here you can also add analytics to see your graphs, snapshot. If you click on create graph, you can create a graph by specifying your name graph, and simply go and see all other options. Thank you for watching. The AWS Database Migration Service, or AWS DMS, is a cloud-based service that facilitates the migration of database and data warehouses to AWS or between different AWS services with minimal downtime. It supports both homogeneous same database mechanism and heterogeneous different database mechanism migrations, including those to and from on-premises database and various AWS services such as RDS and EC2. AWS DMS also enables continuous data replication, which can be used for tasks such as disaster recovery and synchronizations of dev test environment. When you install the database migration service on your virtual machine, it connects to the source database, reads the source database, formatted for use by the target database, and then loads the data into the target database. You can also use the AWS Data Migration Service to continuously replicate data from any supported source to any supported destination with the lowest latency. AWS DMS and AWS Cloud Server is powered by replication software. To maintain sources and changes, you can perform one-time migration and duplicate ongoing changes. Before you can use the AWS Service Migration Service, or DMS, you need to connect your source database to it. After reading the data and formatting it to meet the needs of your target database, the source sends the data according to the migration task that you specified. The DMS then starts tracking all changes to your database as soon as replication from source to destination begins. This is done using the AWS CDC process, then often referred to as data change recording processes. AWS DMS CDC often referred to as data change recording processes. The database migration service inspects all cached objects and makes any necessary changes to the target. Until you transfer your workloads and shut down the source database, the source continues to check and cache the changes. Understanding the key components of AWS DMS is key to planning and executing a successful data migration. So the first step is SourceDB. The source database is where your original data is stored before migration. AWS DMS supports a wide range of databases types for source, including on-premises database, Amazon Relational Database Service, or data stored in other AWS service. Example, you may have data in local MySQL database that you plan to migrate to AWS. The second step is source endpoint, or our destination DB. The source endpoint defines the connection between AWS DMS on your source database. It includes the configuration details and authentication credentials required for AWS DMS to access the source database. Some of the key responsibility is that you must ensure that AWS DMS can securely read data from the source database. Also, you can manage any necessary conversions or configurations to facilitate data extraction. The third step is replication instance. A replication instance is the basic mechanism of AWS DMS. It connects to both source and destination endpoints to migrate data. All data extraction, transformation, and load tasks run on this instance. Key responsibilities in the third steps are extracting data from the source database, perform all the necessary data transformation, uploading data to the target database, and also you can choose from different types and size of replication instances depending on the amount of data and the performance requirements of your migration. The fourth step is migration task or replication task. Migration task, also known as a replication task, define how data is moved from the source to the destination. Each task controls the flow of data and can be customized to meet your migration needs. Type of migration task is fully load task. You can migrate the entire data set from the source to the target. This is usually for initial data loading. So we have something called data change capture or CDC. Tasks continue to record changes, entries, update, and deletions to make to the source database and replicates them to the largest database in real time. And we have some customization options such as data filtering to migrate only specific schema or tables, or transferring data like renaming columns, changing data types during the migration process. The fifth step is target endpoint. The target endpoint defines the connection to your target database. Like the source endpoint, it includes the settings and credentials required for the AWS DMS service to write data to the target location. The key responsibilities in the fifth step are you must ensure that safe and successful load data into the target database, and you can manage configurations that affect how the data is written to the target, such as compression or encryption settings. And finally, the sixth step is target database or our destination database. The destination database is where the data will reside after the migration. AWS DMS supports a variety of target database which can be in the AWS cloud such as Amazon RDS, Amazon Aurora or Amazon Redshift, or on-premises. If you're migrating data from an on-premise MySQL database to AWS, the target database can be Amazon RDS for MySQL or Amazon Aurora. Source database and source endpoint. So this service uses the source endpoint to securely connect to read and data from the source database. In the next chapter, we will talk about AWS Glue. As already mentioned in the previous chapter, in this lecture, we will talk about AWS Glue. This is a serverless data integration service provided by Amazon Web Service, or AWS, and simplifies the process of discovering, preparing, and combining data for analytics, machine learning, and application development. It provides a centralized metadata repository like AWS Glue Data Catalog, visual tools for creating and extracting, transform and load workflows, and support various data integration engines such as Apache Spark and Python shells. AWS Glue provides a serverless solution that simplifies the entire process of discovering, preparing, and combining data for application development and machine learning and analytics. To adequately define what AWS Glue is, you first need to understand how data integration works. Essentially, you can think of data integration as the process of setting up and unifying data for analytics, application development, and machine learning. It consists of multiple procedures such as identifying and generating data from different sources, followed by enrichment, cleaning, normalization, and merging of data. Eventually, the data is uploaded and organized in data warehouses, databases, and data lakes. AWS Glue facilitates all data integration procedures so you can quickly leverage your merged data. This means that you can analyze and leverage data in minutes instead of waiting forever. Taking these capabilities into account, AWS Glue is technically described as a fully managed ETL or extract, transform, and load solution for data integration. Amazon even further explained that the entire system is designed to provide a simple and low-cost way to not only categorize your data, but also to efficiently clean, enrich, and transfer it between different data streams and data warehouses. It doesn't work on one front. Instead, AWS Glue comes as a multi-layered system that drives data integration across three core components. AWS Glue provides the following capabilities. First, you have option to launch ETL jobs as soon as newly collected data arrives. So AWS Glue, for example, allows you to automatically run ETL jobs when new data arrives in your Amazon Simple Storage Service bucket. Then you can use Data Catalog. You can use it to quickly browse and search multiple AWS data sets without having to move the data. Catalog data can be instantly searched and queried using Amazon Athena, Amazon Redshift Spectrum, or Amazon EMR. AWS Glue Studio supports no-code ETL jobs and allows you to visually create, run, and track AWS Glue ETL jobs. Your ETL jobs can move and transform data using a drag-and-drop editor. AWS Glue automatically generates the code. And here we have more information, something called multi-method support. It supports various data processing approaches and workloads such as ETL or ELT, extract, transform, load, or extract, load, transform, packet processing, and streaming. You can also use your favorite method from dragging and dropping or writing code to connecting to your notebook. AWS Glue Data Quality automatically creates, manages, and monitors data quality rules. This ensures high quality data in all of your data lakes and pipelines. AWS Glue Data Brew. This allows you to discover and interact with data directly from your data lake, data warehouse, and databases. You can do this using Amazon S3, Redshift, Lake Formation, Aurora, or RDS. Also, Data Brew has over 250 pre-built transformation to automate data preparation operation, including anomaly filtering, invalid value corrections, and formal standardization. Under the hood, you will find these three AWS Glue components. The first one is console. The AWS Glue console is where you define and orchestrate your workflow. These are several APIs operations that you can call from here to perform tasks such as defining AWS Glue objects, editing transformation scripts, and defining events or job schedules for job triggers. Then we have AWS Glue Catalog. This is basically a central repository for your metadata, built to store information in metadata tables, with each table pointing to a single data warehouse. In other words, it acts as an index of your data schema, location, and runtime metrics, which are then used to identify the goals and sources of your ETL jobs. We have job scheduling system. This is a system that is intended to help you automate the connect your ETL pipelines. It comes in the form of flexible scheduler that is capable of setting event-based triggers and job execution schedules. Then we have scripts. AWS service or Glue service generates a script to transfer your data. Alternatively, you can upload your script via the AWS Glue API or the console. Script extract data from your data source, transform it, and load into your data targets. In AWS Glue, scripts run in Apache Spark environments. Then connection refers to a data catalog object that contains properties to connect to given data warehouses. Data warehouse is a place where your data is permanently stored, such as relational database and Amazon S3. Data source refers to a data warehouse that serves as an input for a transformation or process. Data target is a place where all process writes. And transformation refers to the code logic used to change the format of your data. Also, altogether, these components allow you to streamline your ETL workflows. While AWS Glue continues to cater to different types of users, it's especially popular among organizations trying to establish an enterprise-grade data warehouse. They benefit from the fact that AWS Glue seamlessly makes it easy to move data from different sources to their data warehouse. The process itself is quite simple and straightforward. You can use AWS Glue to validate, clean, organize, and format data, which is ultimately stored in a centrally accessible data warehouse. Further, you will notice that the platform allows you to load such data from both streaming data and static sources. AWS Cloud Formations is a service that allows users to model, provision, and manage AWS resources as infrastructure as a code. It allows developers to define and automate the creation of and management of AWS resources using templates, usually in JSON and YAML format. This allows for consistent and repetitive deployments, infrastructure version control, and easier scaling and updates. AWS Cloud Formation is an infrastructure as a code, or IaaC, offering that allows you to describe and secure your AWS infrastructure in a repeatable and automated way. You write CloudFormation templates in JSON or YAML to specify the resources you need, such as EC2 instances, S3 buckets, or RDS databases, and CloudFormation does the work of creating, managing, and updating them for you. With CloudFormation, you can treat your infrastructure as a single unit, knowing as stack, so that you can easily replicate and have consistency across different AWS environments and regions. This eliminates the need for manual configuration, which is prone to errors and time-consuming. How does AWS CloudFormation work? Well, Amazon Web Services is a service offered by AWS Cloud, as we know. It is mainly used to provide services in AWS, such as EC2, S3, autoscaling, load balancing, etc. You can provide all the automation of services using infrastructure as a code. Instead of managing them manually, you can manage them all with the help of AWS CloudFormation. AWS CloudFormation is a free service. AWS does not charge for the use of CloudFormation. Users only pay for the services they used when they created the resources. AWS steps Functions and AWS Cloud Formations are two completely different services. For example, AWS Step Function is a service where users can orchestrate serverless workload. A chain of action and conditions is created when managed by this service. AWS Cloud Formation is as already told you, infrastructure as a code tool. With it, users can create and manage infrastructures, including these steps functions. AWS Cloud Formation stacks are templates arranged by AWS using CLI, SDK, GUI, etc. They are a collection of resources created by a template, which is also part of a stack. Through stacks, users can control and manage resource updates, executions, and downtime. It is important that users are able to manage the behavior of the stack when it is configured. For example, if an error occurs during deployment, what is the rollback strategy? Well, there is something called CloudFormation nested stack. Stacks or nested stacks are created as a part of other stacks. Users can create multiple templates and use them in others. For example, a template that is used to create an EC2 instance with its key and security group can be reused multiple times in the main template to create many EC2 instances. CloudFormation stacks are an extension of the functionality of stack. It allows you to use a single template to deploy stacks across multiple AWS regions and even across different AWS accounts. Also, it's common for one stack to depend on the other, so you can export a cloud to CloudFormation. Exporting to CloudFormation is a functionality that allows the transfer of output from one stack to another. For example, when an EC2 instance is created, it should run in a previous created virtual private cloud or VPC. CloudFormation Designer is a tool that allows users to create, modify, or easily review infrastructure created with CloudFormation. It can design the infrastructure and export it as CloudFormation code. Also, there is something called CloudFormation Registry. This registry allows users to manage modules in AWS Workspace. Similar to Terraform, it allows you to create separate modules, for example, to create an EC2 instance, store them in AWS CloudFormation Registry, and reuse them multiple times. So, if you ask yourself, what are AWS CloudFormation templates? Well, the answer is that CloudFormation templates is a codified declarative description of the resources and connections between resources to be created in AWS ecosystem. Templates can be created using JSON file or YAML files. They contain several sections, which I will describe later in this post or lecture. CloudFormation template sections are part of the template itself and have different roles. I will describe them more in detail below, and one of these sections is resources, when all resources such as VPC, EC2, etc. are defined. There is also CloudFormation functions. This is a feature that allows you to automate and manage CloudFormation templates. The main functionality is the ability to use certain data while the value of the data is not available before execution. For example, if you need to collect a specific attribute from a freshly created resource, you should use the function fn_get_at, as you can see. Then, CloudFormation change sets are a view deployment concept that fits perfectly into CI/CD solution. A set of changes contains two elements, creation and scheduling. Creating provides insight into changes in infrastructure caused by changes in template code. After reviewing, these changes are deployed using the schedule change set functionality. When a CloudFormation change set is generated, it contains all the changes applied to that template. We can think of it as a delta between the deployment or deployed template and the updated one. This gives us as a user the opportunity to examine the changes and decide whether we want to continue or not. Of course, you can have your template in VCS, but you can add another layer of management or Visual Studio Code, a process that controls the quality of template, and if all checkpoints are met, shares that template in the S3 bucket and makes it available to others or our team. What are other general benefits of infrastructure as a code provided by this service? Well, there is something called improved security, conducting infrastructure operations through a well-controlled process with multiple phases of quality control enhance safety. Also, repeatably and scaling, because infrastructure as a code is stored in Visual Studio Code. The infrastructure can be quickly scaled both horizontally and vertically when needed. Repeatably helps the process because the action is the application of the code, not the entire process of creating the infrastructure. Also, it is very consistent, so the code is validated and stored in VCS. That means that each execution will be carried out in the same way, with the same protective fences applied. As you can see, this is our one document, and in this document you can see how it looks like. First, let me just grab my pen. We have our AWS template format version. So here it is. As you can see, this is our version. Then in the description you have to add some description. For example, in this particular example, you can set up code build and code deployed pipeline. Then in the parameters we have notification email, for example. This will be type will be string and default with some name, some different email address, as you can see, and in the description default name for pipeline notifications. Resources, you can add your artifact. For example, this will be bucket and deletion policy will be delete. In the notification settings we will use something called SNS or simple notification service, and as you can see, every time in the properties, of course, we will add our point for notification email. So every time that we add or get this email, for example, this is some random address, as you can see, then we will get our notification from this SNS service. So as you can see, it's really easy and convenient to work with these CloudFormation options. Let's now hop to our console and see how can we do it practically. And once again we are in our console. In the search bar I will type AWS CloudFormation, and as you can see, we can search these. You can see all the features, but we can also find this file, this service, if you go to this hamburger menu, all services, and scroll down and simply click on CloudFormation in management and governance. Here we can create, as you can see, something called stacks. In the theoretical part I already explained what is a stack. If we click on stack, we can choose, let me just expand this screen. So we need to prepare our template. Every stack is based on template, and template is simple JSON or YAML file that contains this configuration option. So you can choose an existing template or build from infrastructure composer. You can upload or choose existing templates from Amazon S3 URL, upload a template file directly to this console, or you can also sync a template from your Git repository if you have. Then you will add a link, S3 URL or our S3 bucket here, and you have option to go to next. Also you can upload your own file or simply add to Git. If you go to our composer, you can build a new one. Here I have some YAML file, as you can see, and this is our simple YAML file that will create EC key pair with SSH key. As you can see, this is my template version, this is my description. This will create an EC2 instance in default VPC. This is our resources. As you can see, we are building security group. Security ingress type will be TCP 2022. CIDR is, we can allow all traffic from internet, and this will be based on t2.micro, and as you can see, all other like information like our images and the region. It depends what is the name of my tag key and value, and output will be ID of our created instance. So let me now go and upload this template to our CloudFormation. This is our YAML file, as you can see, and we can view this in our infrastructure composer. So we are using our North Virginia region, as you can see. If I click on view in infrastructure composer, this YAML file will be showed in this canvas. As you can see, this is our EC2 instance, and this is our standard component. This is our EC2 group. So we are building simple EC2 instance. But now I must again upload my file, template file. So let me again choose my file, and I will upload my CloudFormation YAML file. Let's hit on next. Here I will provide the stack name. This will be simple name, stack 1. And here you can add your parameters. I will add my key pair that I already have in this region from some of our previous demonstration. Let's click on next. In the step number 3, we need to configure our step option. I will choose my role. You can add your role, and this permission is optional. And in stack failure options, you can choose your behavior on provisioning failure. You can roll back all stack resources to the no stable step, or preserve successfully provisioned resources. Then you can also delete newly created resources during a rollback. So if you get a failure, all newly created resources will be deleted if you roll back to previous one. Then we have some additional options, but all of these are optional. And here we have our stack policy, rollback configuration, notification option, stack creation. This is all optional. So if you want, you can choose and learn more about this optional policy. So the first one, define the resource that you want to protect from unintentional update during a stack update. The second one, you can specify alarm for CloudFormation to monitor when creating and update the stack. Then in notification option, you can specify the new or existing SNS topic where notification about stack events are sent, and in the stack create option, you can specify the timeout and termination protection for stack creation. So you can deactivate or activate. This prevents the stack from being accidentally deleted by you or somebody else. So this is all optional but very useful features. And in the next steps, this is a 4th step, we will review and see what are we creating. And simple, we will click on submit. So as you can see, our creation is in progress. Sometimes it really depends about your script. If your script is valid, then this stack or this creation will be successful, but sometimes it's not. As you can see, our status reason is user initiated, so we as a user initiate this stack to be, and we want to create a simple EC2 instance. So let's wait a little and see if this works or not. Also, there is a various options and tabs, and you can see our rollback is in progress and our creation it fails. As you can see, our value, so this parameter is not valid, so it must be changed. But just to simplify this demonstration, because it really doesn't matter what resource are we creating, I just wanted to show you how can we work with our CloudFormation. So as you can see, my intention was to show you how can you roll back this to the previous, this tag to the previous, as you can see, and deletion is completed. So you can see that using our stack number 1 is not succeeded, of course. I will now delete this stack and we will try to create another resource. So we will go back and click on create new stack. I will choose exactly the same template, but this time let me edit and show you in Notepad and show what I want to do. I want to create a simple bucket. As you can see, my resource type is S3 bucket, and I will add my bucket name. It must be unique. Access control is of course private, and the name of the created S3 bucket will reference here. I will now go back to our CloudFormation. Let me choose my file. I will scroll down, choose my S3. Let's hit on next. If you go to our composer, I will now open this in a new tab. If you go to our canvas, you can see that we are creating a simple storage service, just storage service. Let me add my name for this stack. I will again use my stack number 2. I will not add any parameters. Let's click on next. I won't do anything. I want to change anything. I won't change anything. And in the review and create, we will simply go and click on submit. Now our creation for the stack 2 is again in progress, and in the stack number 1 we intentionally made a mistake just to show you how it looks like. Now we are building or creating our resource using YAML file again, and you can see the creation is complete. So with the stack number 2, where our defined code is good, we are finished creation of this resource using CloudFormation. And now if I, for example, open a new tab, go to our console home and go to our S3 service, you can see that we have our bucket created, and this is our my simple demo bucket. And you can see also that we have this CF template. But if you go inside my demo bucket, you can then go to upload and simply upload some objects and work with this bucket. But this time we create this bucket using our CloudFormation, and with the help of our YAML file, you can build a complete infrastructure using only CloudFormation. So if you are developer and using infrastructure as a code regularly, then this is a service for you. You can also update this stack, make a different or update stack, replace existing template, edit infrastructure composer. So you can see all stack details. What are we? This is stack ID, of course. What are the description of what are we trying to build, and you can delete this stack. Also, there is various tabs that you can use. For example, if you go to events, you can see all events in detail status. This is our resources that we created. In the outputs, this is our bucket name. Then we don't have any parameters. This is our template. So this is the template that we uploaded to this service. And you can also use something called change set if you want to see how the stack will be configured before the start and update. And also you can use this Git option to connect to your GitHub account. Now there is also infrastructure composer. We already saw how it looks like, but here you can also go and click on S3 bucket or simply use drag and drop here, and if you add here, you can build your own template right from here. For example, I want to use my bucket. This is our topic. I need to hold my mouse and connect these two services. So as you can see, connection is made. Let me click on create my template. You can confirm and continue to CloudFormation, and this will create another service by using your infrastructure composer. So with the drag and drop option, you can also create your resources just like that. And that's it. This was just a simple presentation of our CloudFormation, and I hope that you are satisfied. And if you want to learn more about this, then go to AWS console and play around with it. I will now delete my stack, and as you can see, we are deleting our stack that we upload and create to this option. And now, as you can see, deletion is completed. If I now go to my stack, you have to refresh this page, and after some time this stack will vanish from your screen. But the most important part, as you can see, that we successfully deleted our stack. Now if I go to stacks, exports or IC generators, we don't have any stacks. And if you go to our EC2 service in the instances, you can see that I don't have any instance, and that's it. We only have our default resources in our North Virginia. So if you remember, we created that, or tried to create this instance. Now I will just check if there is some resources that is created during this intentional error. Now if I go to S3 service, you can see that this is my CF templates. I will now delete these CF templates, but the bucket must be emptied. As you can see, it is always good to have a clean slate, and here we need to type this permanently delete to confirm our deletion, to empty our bucket. It is always good to delete all your resources when you finish with some demonstration, because we don't want to occur any additional cost during our demonstrations. Here I can click on empty, so we are emptying our bucket, and after some time, if I go to exit, I will now be able to delete this template. And that's it, of course. Thank you for watching, and I will see you in the next lecture. I must warn you that this complete course is not intended to be developer's course. This is more about infrastructure and architecture based course, but it is time to learn more about Cloud Development Kit, or AWS CDK offers in this section. So let's start. So the AWS CDK or Cloud Development Kit is a framework that allows you to use reusable components called constructs to build cloud environments. Developers can build and create cloud services using integrated development environments with the help of libraries and components. AWS CDK provides a simple and easy approach to building infrastructure with the help of programming languages. So let's learn more about AWS CDK. AWS CDK includes a command line interface or toolkit that defines the design and implementation of application, where the design and implementation are written in various programming languages such as JavaScript, TypeScript, etc. The AWS CDK requires the definition of one or more stacks, such as CloudFormation stack. The stack uses the construction defined above. construct are components of a programming language that contain the exact definition and structure of AWS resources. CDK covers this construction into templates for CloudFormation and then allocates or provides the required resources, minimizing the need for complex operations. Advantage of using AWS Service Cloud Development Kit is reusability, so constructs in a CDK can be used multiple times to create the same type of resource. Once written in a programming language, constructions can be reused as needed. Also, there is a various language support, so AWS CDK provides support for multi-languages including JavaScript, TypeScript, Python, Java, and many more. You can use a programmer can use ID for both programming and infrastructure management. The same code can be used from the ID, for example, Visual Studio Code. Also, CloudFormation integration in AWS CDK provides users with the benefits of CloudFormation, allowing for stack management, stenciling, etc. With the help of CloudFormation, the infrastructure can be easily updated. The AWS Cloud Development Kit or CDK allows developers to define cloud infrastructure using familiar programming languages, and here are some common ways that AWS CDK is used. It is used for infrastructure as a code. This AWS CDK allows you to automate the provision of cloud resources such as S3, as we saw in the previous chapter, Lambda, and API gateway using code. This ensures consistency in infrastructure management and makes it easy to track changes with version control. Serverless application building. So with CDK, deploying serverless application is much faster and easier. By using AWS services such as Lambda, API Gateway, and DynamoDB, developers can focus more on building features and less on configurations. You can deploy this across multiple accounts and regions. So AWS CDK allows you to manage infrastructure across different AWS accounts and regions, making it ideal for large projects where you need to consistently set up deployments across different environments. Manage multiple environments, so you can also define the same infrastructure for different stages, such as development, testing, or production, with AWS CDK. After a small tweaks, it will ensure that each environment is tuned to its specific needs. Also, you can use CI/CD pipeline automation, and it integrates seamlessly with this service, such as code pipeline and code build, simplifying the process of automating infrastructure deployment and updates. With AWS CDK, you can dynamically scale resources like EC2 instances to align with demand, helping to optimize cost by using only what you need. AWS Services Integration. So CDK simplifies the integration of various AWS services such as EC2, RDS, S3, and SNS, allowing you to build complex applications with minimal configurations effort. You can also use this Cloud Development Kit for building hybrid cloud solutions for enterprises looking to extend on-premises resources to the cloud. AWS CDK makes it easy to integrate on-premises system with cloud services, creating hybrid cloud solutions. CDK allows you to define and implement security best practices directly in your infrastructure code, such as setting up IAM roles and enable encryption. Also, with AWS CDK, it's easier to build scalable data pipelines using services such as Kinesis, Lambda, and DynamoDB, allowing you to process and analyze data in real time. AWS CDK is a useful framework in the cloud because the features it offers redefine the process of writing and securing cloud resources. In the next chapter, we will talk about Elastic Beanstalk. AWS Elastic Beanstalk is a platform as a service or PaaS offer from Amazon Web Service that simplifies the deployment and management of web application and services. It automates infrastructure provisioning, load balancing, auto-scaling, and application health monitoring, allowing developers to focus on code rather than infrastructure management. All you have to do is upload your code to Elastic Beanstalk and it will take care of everything else, including capacity provisioning, load balancing, auto-scaling, and application health monitoring. At the same time, you still have full control over the AWS resources that support your application and can always access the underlying resources. You can use this service from AWS for orchestration. It is used to scale and deliver web application services on well-known services such as Apache, Passenger, Nginx, IIS, or Internet Information Services, and it supports different languages like Java, Python, Ruby, .NET, PHP, Node.js, Go, and Docker. You can also deploy your application on AWS in the fastest and easiest possible way. It also handles application health monitoring, load balancing, deployment, capacity, provisioning, and auto-scaling. The management of AWS resources is entirely up to you. What is advantages of Elastic Beanstalk in AWS? Quick and easy to deploy. It is the simplest and most time-efficient method to deploy your application on AWS. You can simply upload your application using the AWS Management Studio console, Git repository, or an integrated development environment or IDE, such as Eclipse or Visual Studio, which handles the details on the deployment including capacity provisioning, auto-scaling, load balancing, and application health monitoring. Your application will be ready for use in minutes without the need to configure infrastructure or resources on your part. Also, using easily variable auto-scaling settings, your application is automatically scaled up based and down based on its needs. For example, you can use CPU utilization measurements to run auto-scaling operations, and this allows your application to adapt to spike in load or traffic while minimizing cost. It is very good for developer productivity. So with Amazon Beanstalk Elastic secures and manages the infrastructure and manages the application stack or platform for you. So you don't have to spend time or develop expertise. It also keeps the underlying platform on which your app runs up to date with the latest patches and updates. So you can focus on writing code instead of spending time managing and configuring servers, load balancers, databases, firewalls, and networks. Full control of the infrastructure, so you are free to choose the AWS resources such as Amazon EC2 instance types that are optimal for your application. In addition, it allows you to open the hood and have full control over the AWS resources that run your application. If you decide that you want to download some or all elements of your infrastructure, you can do this seamlessly by using Amazon Elastic Beanstalk management capabilities. So, AWS Elastic Beanstalk allows you to manage all the resources that you run your application as environment. Here are some key concepts. Applications. The Amazon Elastic Beanstalk app is a logical collection of Elastic Beanstalk components, including environments, environment configuration, and versions. In Elastic Beanstalk, the application is conceptually similar to a folder. App version. Amazon Elastic Beanstalk app version refers to a specific labeled iteration of deployable code for a web app. The application version points to an Amazon Simple Storage Service object that contains deployable code such as a Python WAR file or WAR file. An environment is a collection of AWS resources that run a version of an application. Each environment runs only one version of the app at a time, but you can still run the same version of an app or different versions of apps in many environments at the same time. Environment configuration determines a set of parameters and settings that define how environment and its associated resources behave. When you update your environment configuration settings, it automatically applies changes to existing resources or deletes and schedules new resources depending on the changes you make. Also, a save configuration is a template that you can use as a starting point for creating unique environment configurations. You can create and modify saved configurations and apply them to environments using the Elastic Beanstalk console, AWS, CLI, EBCLI, or API. A platform is just a combination of an operating system, a programming language runtime, an application server, a web server, and Elastic Beanstalk components. It provides a variety of platforms on which you can build your apps. So, how does this service work? You can construct an application using Elastic Beanstalk. You can upload a version of the application in the form of an application code package, for example python.var file or war file, and then provide some information about the program. The AWS resources need to run your code are automatically created and configured using Elastic Beanstalk. You can manage your environment and deploy a new version of apps once your environment is up and running. It supports a DevOps practice called rolling implementation, and when enabled, your configuration implementations work hand in hand with autoscaling to ensure that there is always a defined number of instances available while configuration changes are made. It gives you control while Amazon EC2 instances are updated. By dealing with the complexity of infrastructure, Elastic Beanstalk allows developers to focus on writing their code and building great products. This service offers multiple ways to deploy your application, including using the AWS Management Console, AWS CLI, or EB CLI. And here how it works. First, you will create your application. Then you will upload that version. Then you will use this to launch your environment. And finally, if you want to manage your environment, you will use this update version and upload this version again. And then that version will be deployed in that environment. So it's easy as that. Let's find our Beanstalk service. So I will type beans. As you can see, we are getting our Elastic Beanstalk. This is used to run our application in cloud. So here you have option to see some basic information, how to get started, what is the benefits and feature, and pricing. So here you will find the most and get the most information about anything else. So there is no additional charge for Elastic Beanstalk. You pay only for Amazon Web Service resources that we create and store our web application. Let's click on create. The first thing we need to do, we have 6 steps, as you can see. The first thing we need to do is to choose our environment. And let's do step by step. First, this is our environment here. We have 2 types of environment that support different types of web application. The first one is web server environment. So here it will run a website, web application, or web API that serves HTTP request. And then we have worker environment that will run a worker application that processes long-running workloads on demand or perform tasks on a schedule. So it really depends on what you need. You have 2 offers for environment, web server and worker environment. Of course, after you choose your environment tier, there is an option for application information. So here you will add a name. You will add a name for your application or application name. Then I must remind you that this is just the first step when we configuring our environment, as you can see. So if we want to learn more about this environment tier, you will click on learn more, and from the official AWS pages you have option to learn more about these offers. Let me add a name for my application, and here we are creating some environment. I will add, for example, demo app, and as you can see, when I type my application name, environment name is automatically added. Okay, if you want to add tags, you can add, but here you can change the name and subdomain and description about our environment, and you cannot change this later. So when you add a name for your demo app, it will also add a name dash environment or env. Here we will add our domain, and you can see we are using North Virginia, US East 1 region. You can choose whatever region you want, and .elasticbeanstalk.com. So this service has its own domain, and if you add a name here, you can also check the availability for your app. Here we can add our description, and there is a platform type. You can choose between two types. You can choose manage platform or custom platform. Here, if you choose first one, the platform publish and maintain your app, and here custom platform will be a platform that you own, that you create, of course, and you can choose a different platform. For example, this is all languages, and you can choose one of these language. As you can see, Go, Java, Node.js, PHP, Python, Ruby, Tomcat, .NET Core on Linux, on Windows Server, and so on. I will choose, for example, Python, and this is my platform branch that will run on Amazon Linux, and this is our recommended versions. Of course, you can choose between different versions. In the application code, you can use some sample application, or you can upload your code. If you have your code, you can simply copy here from S3 bucket or from your local file, so you can upload this file from your laptop. I will choose my sample code. In the presets, we can choose a start from preset that matches our use case, or choose a different configuration. So we will use our single instance. This is free eligible tier, and you can use also single instance using spot instance. There is also some, you can save money, and here you can use high availability using spot or on demand instance, or some custom configurations. We'll use this first one, single instance. This is free eligible tier. Let's click on next. So we're creating our first step, our environment, and in the second step we need to configure our service access. Here we need to add this service role. So I will add, for example, this EC2 instance, or we need to create a role. Let's click on create role. And here we can choose our trusted entity type, AWS service. We'll use exactly the same Elastic Beanstalk, and this is the options that we are using. As you can see, and here is help and manage. And let's click on save roles. This is our existing roles, as you can see. And finally, let me find my appropriate role. And here we are adding our Elastic Bean service role and this EC2 role. You can add also keeper if you want. This is an optional. And here we need to set up our networking database. I will choose our default option, and if you want, you can add these subnets. It's really depending. We are activating our public IP address, and I will, for example, use my East US availability zone. Here you can integrate an RDS SQL database. You can click on enable database or restore the snapshot and so on. Let's keep it simple, and I'm using my East US, for example, for this database, but we need to wait for our option to go. This is all optional for step 3, 4, and 5 are optional. You can configure instance traffic and scaling, configure updates, monitoring, and logging. But you can, as you can see here, skip all the way to step number 6 to go to review and create. Let me just fix this error. So we are getting some strange error. So I will now refresh this page, and here we need to start from the beginning. I will just be quick and add again our application name. We are choosing web server environment. Sometimes it's really not your fault. It's not your fault if something goes wrong, because sometimes AWS is on their side. So we need to choose our platform. I will choose my Python, and we will choose our single instance free tier eligible. Let's go to next. We have our roles. Let me add my EC2 role again. I can add my key pair. Let's go to next. And here we can simply skip to review or go to next if you want. As I told you, steps 3, 4 and 5 are optional, so we will skip everything and leave everything as it is. We'll skip these two and we will go to review, and also we will use this basic system. Let's go to next, and finally let's try to create our Beanstalk app. We can see our review and all steps that we configured, and you can edit this step if you want. I don't want to edit anything, just want to scroll down, and finally we are using, as you can see, what machines, and let's click on create. Here our Elastic Beanstalk is launching in our environment, and Beanstalk will not work if you don't have your environment. Let me now just go to my console. If I go in CloudFormation, you can see that we have our stack, and you can track all your progress of creating your Beanstalk. You can see our events and what is the logical ID, what is the status, and of course timestamp. So basically you can filter and watch every step of creation of your resources using CloudFormation. Let me refresh this again. So creation is still in progress, and as you can see, our environment is launching, but it really takes a few minutes to provision all the necessary options. And here you can check your events in Elastic Beanstalk. And finally, as you can see, our environment is successfully launched. And if I now refresh our page in our CloudFormation, you can see that our creation is completed. So this is how can you track your provisioning or your deployment of this Beanstalk app. You can see what is platform we are using, and you can now go to upload and deploy your code here. Our health is green. If I go to our environments, you can see that we have our environments, and this is our app. So we have demo app that is created, and if I go to EC2, for example, go to instances, you can see that this demo app environment is run on our instance, as you can see, and this is t3.micro instance. If I go to, for example, to security group, you can see that we have our security group. Exactly, this is demo app 1. So Beanstalk is created a few more resources. If you check your autoscaling group, you can see that we have our autoscaling group, and that is running. So this is a complete offer, as you can see, and AWS is managing all necessary steps. You're just responsible to fill that wizard, and everything will be created for you. You can see metadata, template, instance launch condition, and all other information that you can see on your all resources. We have also SSH here, and in the outpost we don't have any outpost parameters. We don't use parameters. Also, you can see your template. Here are full template in JSON that is created when we created this resource. If you go to infrastructure composer, if you check your canvas, this is the whole infrastructure that is created by AWS. As you can see, we have something called auto scaling group, security group, template, metadata, and all other information. And also you can change your set if you want. We don't have any git sync, but if you go back to our Elastic Beanstalk, this is the way to create environment, to create this app that will run on your computer. And here now we can go to actions and simply delete our application. We need to add our demo app name 100 to delete this app. Let me click on delete. Then we will delete our environment, because as I already told you, your demo cannot run without your environment. I will delete this application. And finally, this will be deleted very soon. And if you go to our stack, let me just refresh this. As you can see, we completely deleted our security group, and it will go step by step, just like when we start creation of this service. You can see what is your status and so on. So let's afresh again. And after some time, all these resources will be deleted. So as you can see, AWS created virtual machine, created our HG and so on. Now we can go to environment and delete this demo app environment, but demo app application is still being deleted, and it really takes some time to delete all resources that we created in this demo. Finally, after some time, if we go to stack details, you will see that all our resources being deleted. And if you go to template, you can see how it looks like, and in the events we have our deleted stack, and you can see all information about this deleted stack. But if you go back to our application or Elastic Bean, you can see that this is successfully deleted. And now if you go to environments, we don't have any application, but if you go to environments, we still have our environment, and as you can see, we can restore this environment if you want. But after some time, as you can see, this demo app environment is terminated. If you go inside it, you can see events that delete application completed successfully. So there is an option to delete this. If I now go back to our EC2 service, if I go to instances, you can see that our demo app machine is terminated. Let me go to security group. We don't have that security group anymore. And if you go to key pairs, we have our key pair from some of the previous chapters. If we go to load balancer, there is no load balancer. and in the scaling group we don't have any scaling group. So we successfully deleted all other resources that we are created during this demonstration. And that's it. This is how can you also learn more about CloudFormation, and there is no our stack anymore, so we are able to finish this successfully. Thank you for watching. Welcome back. If you're a developer, then you don't want to miss this lecture. This lecture will only contain theoretical part, but I will present you the most services that is the part of this AWS development kit. So let's start. AWS developer tools offer a variety of services to help developers and IT professionals to deliver software quickly and securely. These tools allow you to store and manage your application source code and automate the build, test and deployment of your software in AWS or on-premises environment. From building simple web application to sophisticated microservices, AWS developers tools allow you to seamlessly integrate and deploy software using DevOps techniques when you manage AWS services directly from your code editor or command line. Developer and debug code for AWS application within your favorite IDE or browser. You can automate software development tasks, reducing the need for error-prone manual work, monitor the performance of the software with a personalized monitoring dashboard, and developer tools in AWS provide a wide range of optimization options and simplify the process of working on cloud-based projects. Following is a list of expertly selected AWS developer tools designed to significantly enhance your cloud-based development projects. So, this is exactly what this development kit has and have to offer. So, we are starting for Amazon Corretto, then we have AWS Code Pipeline, AWS Code Build, AWS Cloud Shell, Amazon Code Star, AWS Fault Injection Service, AWS Application Composer, Amazon Code Catalyst, AWS Code Artifact, AWS Code Deploy, AWS Code Commit, AWS Cloud 9, and something called AWS X-Ray. So if you're development, you must know all these services. Let's go and find out more about these services individually. So the first one is Amazon Corretto. This is a free, customizable and production-ready version of OpenJava Development Kit or OpenJDK. Not only does this all-in-one package come at no financial cost, but it also offers broad cross-platform compatibility, making it an ideal choice for a variety of environments. Corretto's commitment to a long-term support ensures continuous performance improvement and safety measures. What sets Amazon Corretto apart is its support by Amazon itself for its internal operations, running thousands of manufacturing services within the company. Also, its certification with the Java Special Edition adds another layer of reliability and security, making it one of the most popular AWS development tools in ecosystem. So, the features of Amazon Corretto that it provides support for multiple platforms, support Graal VM compiler, improving performance. It offers native image support to run apps faster, availability of Docker images for easy containerized deployment. It provides long-term support while improving performance and resolving security issues. It supports popular operating systems including Amazon Linux, Windows, and Mac OS, and is certified for compatibility with Java SE standard. The next service is AWS X-Ray. Among the best AWS tools for developers, AWS X-Ray stands out as a powerful tool that helps developers to analyze and debug distributed applications, whether they are in production or under development. X-Ray offers a comprehensive view of the request path within your application. This tool is available for applications structured around a microservice architecture, and it shows you a map that includes all the components involved, where you can analyze complex microservices application and simple free tier ones. Features of X-Ray are: you have deep insight into application and service performance metrics such as response time, latency, and resource usage. It quickly identifies performance issue and error with end-to-end monitoring, improving system reliability and user experience. It easily integrates with AWS services such as EC2, ECS, Lambda, and Elastic Beanstalk. It offers a comprehensive perspective of the required path within your application, allowing for fundamental analysis. Visualize component interactions, ideal for complex microservices. It is compatible with development and production applications of various types. It seamlessly tracks requests across all AWS services, offers full visibility, easy access to the tool through a variety of options, including AWS Management Console, CLI, and API, and efficiently customize analysis to optimize and troubleshoot any applications. AWS Cloud 9. If you're looking for a unique tool that can seamlessly handle all aspects of coding, including project creation, testing, debugging, and collaborative work directly through your browser, in that case, AWS Cloud 9 is the ideal solution for you. As a browser-based, cloud-based integrated development environment, or IDE, it allows you to write, execute, and troubleshoot your code seamlessly, putting all the necessary tools at your fingertips. It comes with a code editor, debugger, and terminal, and support all popular programming languages such as JavaScript, Python, and PHP. You can say goodbye to all complex local configurations, working from anywhere with internal access, making it a widely popular AWS tool for developers. Features of AWS Cloud 9 are: this is a cloud-based IDE or integrated development environment, and it eliminates need for on-premise installations. You can use built-in tools for writing, debugging, and command-line operations with IDE. It covers over 40 programming languages such as JavaScript, Python, PHP, Ruby, Go, C++, and others. It debugs PHP, Python, JS Node, and C or C++ application using breakpoints and variable inspection. It works on managed EC2 instances or any Linux server with SSH connectivity. You can set up CI/CD pipelines using AWS CodeStar integration. The terminal provides complex sudo privileges and a pre-authorized AWS CLI to execute commands. You can customize the appearance of the user interface by using color schemes and editing style templates. It allows you to use Vim, Emacs, and Sublime key connections, or to define your own custom key connections, allowing you to use familiar commands and shortcuts. You can quickly edit images directly in the browser using the built-in image editor. It simplifies serverless application creation with pre-built tools and SAM support, and it enables real-time collaboration, allowing you for system programming and monitoring on live inputs. The next service is AWS Code Commit. This is an essential component of an AWS suite of development tools. It offers a comprehensive and fully managed source control service designed to simplify the management of private Git repositories for enterprises. In addition, it simplifies the secure hosting and expansion for repositories, eliminating the challenges of setting up and managing the infrastructure required to control the source code. Therefore, when you use AWS Code Commit and other AWS development tools, you have a robust set of resources that will make your software development projects more accessible and better. Features of Code Commit are: they enable code commits, branching, merging, and pull requests for team collaboration. Secure data transfer and repositories addressed with AWS Key Management Service or AWS KMS. After all, it manages source code control, eliminating the need to set up and maintain a source code control system. It manages data access using AWS Identity and Access Management, which is monitored by AWS CloudTrail and CloudWatch. Its store repositories are redundant in Amazon S3 and DynamoDB for data reliability. It offers even event alerts via Amazon Simple Notification Service, trigger actions, and calls Lambda functions in response to event in the repository. It easily integrates with Git tools and workloads to get known developers. It supports collaboration through branch management, pull request, and code review. It starts with 1,000 repositories, expandable to 25,000, supporting different versions of files. It integrates with other AWS services for simplified DevOps workflows and cloud-native application integration. The next service is AWS Code Deploy. This is classified as one of the AWS deployment tools, and it is designed to automate the implementation of code to various instances, including EC2 instances and on-premises servers. It also simplifies the process of releasing new features and minimizing downtime when deploying an application, while simplifying the complexity of updating application. Its focused approach to implementation management sets it apart from other developer tools, making it an effective solution for automating code implementation. Features of Code Deployed is that it automates the deployment of application to various services, including EC2, Fargate, Lambda, and on-premise instances. It guarantees uniform deployment across multiple instances, eliminating the need for manual intervention. It minimizes business during updates. It quickly scales deployments from individual instances to thousands, adapting to the needs of your infrastructure. It deploys for a variety of targets, including EC2 instances and on-premises servers, offering deployment flexibility. It provides a single interface for managing deployments through the AWS console, CLI SDK, and APIs. It easily integrates with popular DevOps tools and practices, simplifying the implementation process. It allows you to easily revert to the previous version, ensuring stability and resistance. It offers alert and track deployments, even through Amazon SNS integration. The sixth service is AWS Code Pipeline. AWS Code Pipeline serves a fully managed continuous delivery solution that simplifies and automates the step in publishing and updating application and infrastructure. It orchestrates the build, testing, and implementation phase of your publishing process in response to any code changes, adhering to your established publishing model. This allows you to deliver new features and improvements quickly and consistently. It also offers the flexibility to seamlessly connect to external services like GitHub and allows you the inclusion of custom plugins. What's more, it operates as a pay-as-you-go model without the burden of upfront fees or long-term obligations. This fits perfectly with the cost-effective and customizable nature of AWS developer tools. Integrating AWS developer tools with AWS well-architected tool enhances your development workflow by ensuring that your applications are built with the best practices of reliability, security, and performance as outlined in the well-architected framework. If you want to learn more about well-architected framework, I won't add this to this course. You can go and search in official AWS pages. Exactly the same thing you can do for Azure. Let's continue on AWS Code Pipeline. The features of this service is that it automates the build, test, and deployment phases for consistent updates with code changes, defines and automates your workflows in the publishing process using pipelines, stages, and actions. It integrates seamlessly with services such as GitHub and support custom plugins and customizability. It runs custom functions at any stage using AWS Lambda for flexibility and automation. Extend functionality by integrating custom systems or using Jenkins plugins. Also, it manages user access and control through AWS IAM, including IAM users, roles, and SAML integrated directories. It offers Amazon SNS notification for pipeline events, including status and links to resources. It defines the structure of pipelines through declarative JSON documents for easy updates and the creation of a new pipeline. It uses pre-built plugins for popular developer tools for easy integration, and it works on a pay-per-use model, so you only pay for resources and services you use. The next service is AWS Code Build. This is a service that helps you turn your written code into a functional software. It compiles code, tests it, and packages it for implementation. Best of all, you don't have to worry about configuring or monitoring your servers for this. Code Build can handle multiple tasks simultaneously, so you won't have to wait in line for your work to be completed. You can easily start using it with pre-made settings or create your own custom build environments using the tools you prefer. Features of this service that it offers ready-made environments equipped with basic tools, creates your build environments by packaging tools in Docker images, defines specific commands and actions to build using a YAML-based specification. It is suitable for improving the efficiency of task-related or to continuous integration and delivery CI/CD procedures. Creates encrypted and controlled access artifacts using AWS Key Management Service or KMS. You can track build details such as start time, end time status, and confirmation ID via AWS Code Build and Amazon CloudWatch. It supports simultaneous construction and prevents delay in the queues. It offers pre-made environment for quick setup. It allows customization with your preferred tools and configurations, versatile support for various programming languages and frameworks, and it benefits you. You can pay what you use with no upfront cost. The 8th service is AWS Cloud Shell. This is an integral part of AWS Developer Tools ecosystem, offers a secure and convenient browser-based environment for efficient management of AWS resources. It is equipped with pre-installed tools, pre-authenticated access, and support for AWS CLI and SDK, all at no additional cost. Features of this Cloud Shell service: that you can access Cloud Shell directly from your browser at no additional cost. Access and manage AWS command and script directly from your browser, web browser. Pre-authenticate your console credential, eliminating the need for conditional logins. Pre-install development tools, reducing the need for local installation and configuration. It will run script with AWS Service API using the AWS Software Development Kit for various programming languages, and it offers 1 GB of permanent storage for your scripts and configuration files. Then the next service is Application Composer. This is a visual AWS development tool designed to simplify the creation and configuration of serverless application using a variety of AWS services. Users can intuitively drag and drop serverless resources by using a browser-based canvas to construct their application architecture. This platform makes it easy and quickly connect between resources and simplifying the construction of complex serverless applications. Notably, AWS Application Composer can group resources into larger architectural components, improving ease of editing and configuration. It also provides functionality to generate ready-to-deploy configuration files, including default settings tailored to specific services used in the application architecture. Features of this service: it offers a drag-and-drop interface to easily design the architecture of your application using over 1,000 AWS resources. Automatically generate CloudFormation and Serverless Application Model or SAM templates based on your design. Store visual diagrams in infrastructure as a code artifact in real-time synchronization. It offers visual IaaC authorization, authorship in Visual Studio Code, AI-based code suggestion for CloudFormation templates. The next service is AWS Code Artifact. This is all-in-one artifact storage service designed to simplify the storage, publishing, and distribution of software packages across organizations of any size. As a part of AWS Developer Tools suite, it simplifies the storage, publishing, and distribution of packages, ensuring seamless collaboration and accessibility for developers at every stage of the development process. Features of AWS Code Artifact is easily access software packages from npm registry, Maven Central, PI, and NuGet.org. To share packages with your organization, use npm, pip, yarn, twine, Maven, NuGet, and Swift PM. Streamline packages approval and track usage with AWS CloudTrail. Work on multiple availability zone, storing data in Amazon S3 and DynamoDB. It does not require manual configuration or maintenance. It scales automatically. It will integrate with IAM, AWS CloudTrail, and KMS for security, and secure access within your VPC using AWS Private Link. The next service is Amazon Code Catalyst. This is all-in-one service tailored to software development teams that embrace continuous integration implementation methodologies as a part of their development workflows, or CI/CD. It is fully managed by the AWS. Code Catalyst brings together core tools, enabling seamless planning, collaborative coding, and efficient app building, testing, and deployment. In addition, it offers integration capabilities with AWS resources, allowing AWS accounts to connect to Code Catalyst spaces. By unifying all phases and aspects of the application lifecycle into a single platform could Catalyst enable teams to deliver software quickly and reliably. Features of Code Catalyst: that this service brings together all CI/CD tools. AWS performs all management tasks, plan, code, build, test, and deploy it all in one place, manage the entire application lifecycle effortlessly, and streamline fast and reliable software delivery processes. And the last one is AWS Fault Injection Service. AWS Bug Injection Service stands out as one of the best offerings in AWS Developer Toolkit. It is a managed service designed to run fault injection experiments on AWS, facilitating application performance, visibility, and improving resiliency. It supports chaos engineering practices by simulating disruptive events, such as sudden increases in CPU or memory consumption, in testing or production environments. The service simplifies the setup and execution of controlled fault injection experiment across various AWS services, offering pre-built templates and generating interrupts. This service is an integral part of AWS development tools, allowing developers to proactively identify and resolve potential issues in their application. Features of AWS Fault Injection Service are predefined scenario to simulate real-world events, finally grained controls for targeting environments, integrated with AWS IAM for security, and it is available via console, CLI, and API. With these powerful AWS developer tools at your disposal, you can streamline your development funnel, accelerate application publishing, and confidentially build, test, and deploy. All this while enjoying the flexibility and cost effectiveness of these tools with a strong emphasis of AWS cost optimization. So it was really necessary to provide you with all these services because all these services are part of AWS Development Kit. Thank you for listening and watching. AWS System Manager, or SSM, is a suite of capabilities within AWS that provides a unified interface for managing your AWS resources and hybrid cloud environments. It allows you to automate operational tasks, manage configurations, and gain operational visibility into your infrastructure. Amazon System Manager helps you manage nodes at scale. AWS System Manager, also known as SSM, which you can use to view and control your infrastructure and allows users to run remote commands without the need for SSH. You can view operational data for multiple AWS services and automate operational tasks in your AWS resources. It helps you maintain security and compliance by scanning your managed nodes. A managed node is a machine configured for System Manager and reporting any policy violation it detects. The only basic requirements to run SSM is that host should have the Amazon SSH agent running, and the host should have an IAM role with SSM access. So Amazon SSM Manager manage instance core and instance trust policy that allows the node to use the functionality of the core System Manager service. AWS System Manager is an AWS service that provides visibility and control of infrastructure on AWS. AWS System Manager provides a single interface through which you can view operational data from multiple AWS services. AWS System Manager allows you to automate operational tasks across all your AWS resources, formerly known as SSM. AWS System Manager is a central hub for controlling and reviewing your entire AWS infrastructure. It can help with security within your account and helps automate sanitation tasks to ensure that your environment is as compliant as possible with regulations. AWS System Manager is a powerful service that allows you to have a holistic view of all services you use to view and control your infrastructure on AWS. This service provides a single interface through which you can view operational data from multiple AWS services. With AWS System Manager, you can group resources such as Amazon EC2 instances, Amazon S3 buckets, Amazon RDS instance per application, view operational data for monitoring and troubleshooting, and take action of your resource groups. With AWS System Managers, you can select a resource group and view its recent API activities, resource configuration changes, related notifications, operational alerts, software inventory, and patch compliance status. You can also take action of each group of resources depending on your operational needs. AWS System Manager simplifies resource and application management, reduces the time to detect and resolve operational issues, and makes it easier to safely operate and manage your infrastructure at scale. AWS System Manager Inventory Manager automates the process of collecting software inventory from managed instances. You can easily specify the type of metadata that it will be collected, the instances from which metadata should be collected, and the schedule for collecting metadata. AWS System Manager collects information about your instances and the software installed on them, helping you to understand your system configurations and install application. The collected data allows you to manage application resources, track licenses, monitor file integrity, detect applications that were not installed by a traditional installer, and much more. AWS System Manager allows you to scan your managed instances for patch compliance and configuration inconsistencies. You can collect and aggregate data from multiple AWS accounts and regions and then drill down into specific resources that are not compliant. By default, AWS System Manager displays patch and association data. You can also customize the service and create your own compliance types based on your requirements. AWS System Manager allows you to securely automate common and repetitive IT operations and management tasks across all AWS resources. With System Manager, you can create JSON or YAML documents that specifies a list or specific list of tasks, or use documents that have been published by the community. Also, these documents can be executed directly through the AWS Management Console, CLI and SDK, scheduled in the maintenance window, or run based on changes in AWS resources with Amazon CloudWatch events. You can track the execution of each step in the document as well as request approval for each step. You can also introduce changes gradually and automatically stop when errors occur. By using Run Command option, you can use automate common administrative tasks and make one-time configuration changes in large volumes at the enterprise level. This essentially prevents you from having to jump into each of your instances and run the same command hundreds of times. Everything is actively managed within the console, and there is a simple console to administer your commands, as well as the CLI or via the AWS SDK. Example of a task includes stop, restart, terminate, and resize instances, attaching and disconnecting EBS volumes, creating snapshots. You can install or run the application, build a pipeline for deployment, etc. Commands can be applied to a group of systems based on AWS instance tags or manual selection. Commands and parameters are defined in the AWS System Manager documents. Commands can be issued using AWS Console, AWS CLI, AWS Tools for Windows PowerShell, AWS System Manager API, or Amazon SDK. AWS System Manager provides secure and remote management of your instances at scale without logging into your servers, replacing the need for Bastion host, SSH, or remote PowerShell. It provides an easy way to automate common administrative tasks in your group of instances such as registry changes, user management, and software and patch installations. Session Manager provides a command terminal for Linux instances and a Windows PowerShell terminal for Windows instances. Session Manager not only provides a complete revised terminal environment, but you can administer access to SSH sessions without having to open any ports, which significantly improves your security posture. You can easily enable the least privileged IAM permissions for the Session Manager console and allow you developers to maximize their efficiency and effectiveness. AWS System Manager is a service that can provide you with a lot of working with the services you use in the Amazon Cloud environment, so it is possible to list them all in this chapter, and it's up to you to find out everything else on the official AWS website. Amazon CloudFront is a web service that provides a globally distributed network of edge sites to accelerate the delivery of your static and dynamic web content, such as HTML, CSS, JavaScript, and image files, to your users. It acts as a content delivery network, or CDN, by caching content closer to users, which reduce latency and improve download speeds. Amazon Web Services offers a global content delivery network service called AWS CloudFront. It enables companies to quickly and efficiently distribute content to users around the world, including static or dynamic data, videos, images, or APIs. CloudFront caches copies of your content on strategically located servers known as edge locations. When a user submits a request for your content, CloudFront's delivers it from the nearest edge location, reducing latency and improving load times. This ensures low latency delivery, high transfer speeds, and an optimized user experience. CloudFront is an essential component of the AWS ecosystem, as it easily integrates with other AWS services such as Amazon S3, EC2, Lambda at Edge, and API Gateway. Key components of AWS CloudFront edge sites or CloudFront are data center around the world that cache content to deliver users, original server, the main server that hosts the original content, for example S3 bucket, EC2 instance, or local server, distribution, configuration to deliver content through CloudFront, web distribution, for web pages, APIs, and static dynamic content, RTMP distribution for streaming media, although it is deprecated, cache behavior. It defines caching rule like time to live or TTL, cookies, query strings, etc., signed URLs and signed cookies, secure access to private content, and Lambda at Edge runs custom logic on edge sites, for example, modifying HTTP headers, rewriting URLs. And you can see how it works. First, you as a developer, you can create some Amazon S3 bucket or HTTP server. Then you can upload this object or add this object to your server. Then it will run web distribution to Cloud Amazon Front. Then Amazon Cloud Front will cache this content and send back to you as a developer, as a user, and then one of this distribution will be sent to our edge location, and on that edge location this content will be cached. So that's the whole point of AWS CloudFront. If you go to our console and type CloudFront, you can see that CloudFront is Global Delivery Network or CDN. Here you can start and create your CloudFront distribution, and you can see that we are using our free tier. First, if you want to create this service, we need to, in step 1 of course, we need to add our CSV name. You can choose if you want to distribute this to a single website, or if you have multi-tenant infrastructure, you can choose when you have multiple domains that need to share configurations. Here I will add my domain name if I want, and in the next step we need to specify our origin. First, there is an option to choose between origin Amazon S3, for example Elastic Load Balancer, API Gateway, Elemental Media Package, VPC Origin, or other. So if we choose Amazon S3, we can deliver static assets like files and images, statically generated website, or single page applications. So here I need to check one of my S3 buckets. I will add here, and you need to provide origin path if you want. And now in the settings you can grant CloudFront access to this origin, so this will update your S3 bucket policy that allow CloudFront to access our S3 bucket. And here we can set our origin settings. We will use our recommended origin settings, or you can customize your own origin settings. Then we will use our custom settings, cache settings, and in the enable security, you can enable something called web application policy if you want. You can enable security protection, or you can choose to do not enable security protection. If you enable, this will keep your application secure for the most common web threats and security vulnerabilities using AWS WAF. And you can see what is included in this security protection. Of course, there is a different price. So the price is around $14 for 10 million requests per month. So you will have to pay for this service if you want to enable it. Of course, we can simply check this do not enable common security, and as you can see, you can also read what is included in this secure protection, but this is an optional. Let's hit on next, or simply you can click or check this do not enable this security protection. Finally, in the step number 4, there is a review and create option, and we can create our distribution. So we are creating our CloudFront service, and here you can see general information like details, the name of our CloudFront, distribution domain name, and so on. So we have security tabs, origin tabs. You can see that we have one origin tab and all other information that is available here. As you can see, we have our default behavior, and in the general option, this is our S3 bucket that we are using here. And if we go to properties or permission, you can see that now we have our bucket policy, that is policy for CloudFront private content. So this, if you remember, this policy is created when we choose or set up our CloudFront. So you can see what is our policy. This is our allowed CloudFront policies front service principal. Effect is allowed. What you can see what is our service. So it will get all object from our resource, and you can see that we granted permission with this policy to our CloudFront service. Now if I refresh this page, you can see in the setting option that we don't have any settings for now, but if I copy this name and paste it here and add slash, for example, let me go to my objects, and I will use one of these objects that we uploaded in our bucket. Let me copy this key, aws.png, and if I hit on enter, you can see that our CloudFront address is generally available because of that policy that we specified, that our CloudFront has all benefits to list all our objects. As you can see, here it is. So CloudFront has the permission to list all objects from our specific bucket. So we can also see this, that if we go to our official link of this object, you can see by default it is denied because we are not granted permission for this object to be generally accessible. Of course, if I go to my CloudFront, you can see that we have our domain, and now if we copy this domain, and if we of course copy this key, our another object is available because of that policy that we just talked about. And if you go to our connection, you can see that this is a secure connection, so it uses HTTPS. I will now disable this option, and now we can also enable again, and then after some time we will be able to delete our resource. So as you can see, using CloudFront is very, very easy, and with the help of our policies you can grant almost every object in this bucket. I will now delete my object. Let me add permanently delete in this empty field. So just to remind you, if you want to delete your resource, your bucket, you must first empty your bucket, and then you can delete your bucket. Let me now type the name of my bucket, and let me hit on delete bucket. And now if I refresh this, you can see that we are still not able to delete our CloudFront, but after some time I was able to delete this. But in the meantime, you can see that CloudFront it's not just CDN option. You have all different options that you can use from. And if you want to learn more about CloudFront, simply check the official AWS pages, and you will find a lot of examples there. Here I just want to show you how can you create your CloudFront. And now after some time, as you can see, we can delete our CloudFront because this is disabled status, and finally we don't have our CloudFront. So just to do a little recap, we created our CloudFront, add this policy for our S3, and then with the help of CloudFront, which is we was able to read this object thanks to this policy. Also, there is a lot of different buckets that I used here, so I can delete them also, just to have clean slate, and so we can move on with these different demonstrations. I will copy this name to our empty field and simply delete this bucket, so we don't have any bucket. So as you can see, I must go to my IAM service and fix this. So I will fix this behind my camera, and that's it. And we are starting a new section, and in this section the first lesson is AWS Global Services. So we will meet and learn what are AWS Global Services. AWS Global Services is just a set of AWS offerings designed to be available and functional across all AWS regions, meaning they do not have specific regional limitations. These services typically have a single control plane and resources that can be accessed from any AWS region. Examples include IAM Service, Route 53, CloudFront, and Global Accelerator. Well, unlike most AWS services that are tied to a specific region, global services, as their name implied, are designed to be used from anywhere within the AWS network. They have single control plane, and they are of course globally accessible. Many global services operate with a single control plane, which means that the management interface and core operations are centralized in a single location, often in a specific AWS region, but the service itself is available globally. When we talk about a data plan, which deals with the actual processing and delivery of data, it's often distributed across multiple AWS regions to ensure low latency and high availability. Amazon Web Service, or AWS, offers a wide range of cloud-based services that are available globally. AWS is the leading cloud computer platform provided by Amazon and operates globally, with all data centers located in different regions around the world. AWS Global Services generally refers to services that are available and can be used by customers from any region where AWS has a presence. Some of the key AWS Global Services include Amazon Elastic Cloud Compute, or EC2. It provides a scalable virtual service in the cloud, allowing users to run applications and workloads on different computing instances. Then we have Amazon Simple Storage Service. It offers scalable and durable storage of objects in the cloud, allowing users to store and download any amount of data at any time. Then we have Relational Database Service, or Amazon RDS. It provides managed database service for various database systems, making it easy to set up and operate and scale cloud databases. We have Amazon Private Cloud, or VPC. It allows users to create a private isolated network environment within the AWS cloud, providing control over network resources. Then we have AWS Identity and Access Management, or IAM, offers centralized control over access to AWS resources, allowing users to manage users, groups, roles, and permissions. And then we have Amazon CloudFront. This is a content delivery network, or CDN service, that securely and with low latency delivers content, videos, apps, and APIs to users around the world. We have AWS Lambda. This is a serverless computing service that allows users to run code without securing or managing servers, paying only for the computing time spent. Then we have AWS Global Accelerator. It improves application availability and performance by routing users through the AWS Global Network infrastructure. We have something called AWS Direct Connect, provides dedicated network connectors from on-premise data centers to AWS data centers, improving security and reducing the cost of data transmission over the internet. And finally, one of the most important and most used services are AWS Route 53. This is a scalable domain name, or DNS web service, that provides a reliable and cost-effective domain registration, routing, and validation. So there is no regional dependencies, so users do not need to select a specific region when using these services. They are inherently available everywhere. Also, it has improved availability and performance. Global services are designed to provide high availability and low latency by using AWS global infrastructure. In the next chapter, we will learn and start the set of chapters or lessons about AWS Route 53 service. Most of these services we already know, but it's time to see what is AWS Route 53. Well, Amazon Route 53 is a cloud-based domain name system, or DNS web service, designed to be highly available and scalable. It translates human-readable domain names, such as www.example.com, into numeric IP addresses, such as 192.0.2.1, that computers use to connect to each other. Essentially, it's like a phone book on the internet, allowing users to find the correct servers for a website or application. Amazon Route 53 is a highly available and scalable cloud-based domain name system, or DNS, web service. It is intended for developers and corporations to direct end users to internet applications by translating human-readable names such as www.nfl.com, for example, into numeric IP addresses such as 192.0.0.1, for example, that computers use to connect. You can't use Amazon Route 53 to connect your on-premises network to AWS Cloud. So, Amazon Route 53 is an AWS service that offers DNS web service, and as I already told you, it is highly available and scalable. It is necessary for converting user-friendly domain names into IP addresses so that internet communications can take place without difficulty. The following are some of the main features that explain how Amazon Route 53 works as well. First is domain registration and management. So Amazon Route 53 allows users to register and maintain domain names through its user-friendly interface. Users can transfer their existing route or domain to Route 53 or register a new one. Users are free to configure DNS settings, including mail servers, setting MX records, for example, domain name aliases, and more after they register. Global DNS resolution, or Route 53, uses a worldwide network of many DNS servers that are strategically located around the world. The IP addresses that matches the domain name that users entered into their web browsers is sent back to the DNS servers of Route 53. Users can instantly access the website and services from anywhere in the world thanks to the low latency and highly efficient DNS resolution, and Route 53 using the global network. Then, when we talk about traffic routing and load balancing, users can set up load balancing as a backup settings for their applications using the extensive traffic routing capabilities of Route 53. Users can distribute incoming traffic between several endpoints, such as Amazon EC2 instances, elastic load balancers, or other external resources using capabilities such as DNS-based routing and weighted circular routing. Also, some of the features of Route 53. If, for example, web application requires a domain name, the Route 53 service helps register a name for the website that's a domain name. Whenever a user enters a domain name, Route 53 helps connect the user to the website. If any error is detected at any level, it automatically directs the user to the correct resource. So Amazon Route 53 is a cost-effective, secure, and scalable. It is also a flexible, high accessible, and reliable service. Then some methodologies related to Route 53. We have logs. Logs are created to route internet traffic to resources. Then these are the objects present in the hosted zone that determine how internet traffic must route it to the domain name in order to finally reach the resource. That's not logs, there are records. The name of each record in the hosted zone must end with the name of hosted zone. What is a hosted zone? When a domain name is registered, Route 53 creates a public hosted zone that has the same name as the domain name. It is a collection of these set records that contains information about how to route traffic to your domains and all of your subdomains. Well, DNS query is just a request for information sent from a DNS client to a DNS server. Alias records help direct internet traffic to AWS resources such as S3 bucket, Amazon CloudFront, etc. It is created on the top of the node on the DNS namespace. Name servers, these are servers in DNS that translate the domain name into an IP address so that internet traffic can be routed to resources. DNS redirection in a case of failure. This is a method for routing traffic from unhealthy resources to healthy resources whenever a fault is detected. Routing policy. Well, the routing policy determines how Amazon 53 responds to queries. And type of this AWS route policy, we have simple routing policy. It is a simple Route 53 routing technique that can be used to route internet traffic to a single resource, like web service to the website, for example. And using it, you can create a routing of multiple records with the same name, but multiple values, such as multiple IP addresses, can be specified in the same record. Then we have fallback routing policy. Whenever a resource becomes defective, this policy allows traffic to be routed from the faulty resource to a healthy resource. We have geolocation routing policy. This routing policy directs traffic to resources based on the user's geographic location. Geographic location can be determined by continent, country, or city. For example, a person who lives in France will be redirected to French language website, while a person from the US will be redirected to an English language website. Then we have something called geo-proximity-based routing policy. This routes the traffic based on the user's geographic location and the type of content the user wants to access. A user policy can optionally redirect traffic from a resource in one location to a resource in another location. Using this policy, a user can be redirected more traffic to one site compared to any other site by specifying a value known as bias. Then we have latency-based route. If a website needs to be hosted in multiple regions, a latency-based routing policy is used. To improve performance for users, this policy helps serve requests from the AWS region that provides the lowest latency. To use this policy, latency records are resources are created across multiple AWS regions. We have multi-value routing policy. It is used when users want to route 53 to return multiple values in response to DNS queries. First, it checks the correctness of the resource and then returns more values just for the correctness of the resource. We have weighted routing policy. This routing policy routes traffic to multiple resources with a single domain name according to a proportion specified by the user. Type of DNS records supported by Amazon Route 53. We have a record. This is an address record. It is associated with IPv4 address that is used to route domains or subdomains to determine the IP addresses. 4As, this is a IPv6 address record. It is a similar to type of A record, but it is associated with an IPv6 address. And then it's associated the name with the IPv6 addresses. We have something called C name record or canonical name record. Creates an alias for a domain name that points to another domain name. It is used to set up domains, subdomains, or route multiple domain names to the same server. We have MIMX record. This is mail exchange record, specifies the mail server responses to receiving mail on behalf on the domain. It is used to route emails. Well, in the next set of chapters, we will take a deep look at and how to work with AWS Route 53, because this is one of the most important services in AWS and most used services, of course. Welcome back. We are in our console once again, and here this is our first lesson about Route 53 service. First, I want to show you how can we connect our Route 53 service with my hosting provider. For this, you must buy some domain name for some provider, for example GoDaddy or some other. I'm using my local provider here where I live, and now I will show you how can we connect our Route 53 with our hosting provider. So once again, you must buy, if you don't have some domain name, and finally from some other provider. Of course, there is a cheap random names for a few bucks a month or a year for the first year, and then when you connect your Route 53 and your domain hosting provider, then you will be able to work with Route 53. So as you can see, we are in our console, and finally we will use Route 53. As I already explained in our theoretical part, we learned a lot about Route 53. And now I want to show you how can we work with Route 53. Once again, Route 53 is one of the most popular service and most used service in AWS, and it is very good to know how to work. So here, as you can see, I can search my Route 53 or simply go to my most visited site. This is a scalable, as you can see, DNS and domain name registration. Let me click on Route 53, and here you can also host your zone. Let's go inside our service. As you can see, you have options to see this service, to view pricing, to read more about these resources, about documentation, but let's go to Route 53. As you can see, if we go to the left side of our window or screen, there is something called domains and registered domains. I will click on registered domains, and here you have option to register your domain. And let's click on register domain. Here you can check availability for your domain, and here is a standard TLD or top level domain like .com or .org. So you can search or enter a domain name and search it here, for example, to check the availability. Of course, you can also see the pricing. The pricing is for 1 year, and you can select up to 5 domain. So let me, for example, try cloudlab.com. So as you can see, this is not available, this username, this top level TLD or top level domain name, but there is suggested available domains. For example, I can buy cloudlab.tv for $36 for a year, and the only thing I need to do is to select and buy this right from here. If you click on select, as you can see, for example, webcloudlab.com, you can proceed to the next step. You need to check your pricing. You also have the option to check your duration price up to 10 years, so it will be $150. Also, you can auto renew this. If you unable auto renew, then it will only be valid for 1 year, for example. And finally, my subtotal is 15 USD, and I can go to next to add my contact registration information, and this domain with off auto renew will remain for 1 year. And here you must add your personal or company information. And finally, when you add your contact type, organization, first, last name, and go to next, you will be able to purchase your selected domain. Here you can add your admin contact. You can add some other person, or you can simply leave this same as registered contact. So once you will be also an administrator for this domain. Finally, if I hit on next, I can go to next, but in the step number 3, you will review and submit and purchase this domain. So as you can see, right from Route 53, you can buy your domain name, check if this register or domain is available, and simply when you add your contact information, choose the how many years do you want to use this domain. You can buy it from here. Also, you can transfer to a single domain or multiple domain. If you add your multiple domain, you can also check domains to transfer to Route 53, for example. And here we have something called hosted zones. In the hosted zone, we can create our hosted zone, as you can see. And here we can add 2 kinds of zone: public or private hosted zone. The first thing we need to do is to add a domain name for our hosted zone that is just a container that serves the whole information. How can we route traffic to for our domain? Then when I add my domain name here, I can add a description, and finally we will choose our type. The first one is a public hosted domain zone. So in the public hosted domain zone, traffic is routed on the internet, and the private hosted domain name, as you can guess, is routed within an Amazon VPC. So this is some kind of internal DNS or private hosted zone. In the later part of this course, I will show you, of course, DNS services in Azure. But for now, let's stick to our Route 53. Let me add my domain name. So I already have my domain name. This will be cloudlab.best. Here I can add if I want, and this is my, as you can see, my username. And here I can add, for example, the hosted zone is used for Route 53, for example, or some other thing if you want. You can also leave this empty. And here, as I already told you, we can host public hosted zone and private hosted zone. Of course, these, when you buy a domain name, for example, then you will be able to go and log in to your domain provider, and then there you will be able to add some values. I will show you how. And finally, I will choose to create this public hosted zone, and we need to add www.cloudlab.best and hit on create hosted zone. Of course, you can add a tag if you want. And finally, as you can see, our first public hosted zone is successfully created. So now we can create records in the hosted zone to specify how we want to route 53 our traffic on our domain. When you create your host zone, you can see that we have two record names. The first one is NS, that is a name servers, and we have by automatically added this for route servers value or route. And then we have something called SOA or state of authority, and as you can see, this is another value. We have something called TTL, this is time to live, and we don't have any other information, and this is simple routing, and we have our alias. Also, you can import zone file if you have right from here, and finally we will be able to, if you go back to our Route 53 for example, you can see that we have one hosted zone, and this zone, it will cost you $0.50 per month. As you can see, this is our public hosted zone created by route. We have two record counts, and this is hosted zone ID, of course. If I go again inside this hosted zone, as I already told you, we have something called name servers. In the theoretical part, I already explained what is name servers. And now, if I want to connect this Route 53 public hosted zone with my domain provider, I need to add these values, these name server values, to this empty field on my cloud, on my domain provider, as you can see, website. So in your provider you will find these name servers, and simply I will copy name server 1 here, and I will do exactly the same thing for other three values. And then you must change your name servers, so all these values from our cloudlab.best, we will now route this traffic to our Route 53. So as you can see, it's very easy. How can you connect your Route 53 service with your cloud, with your domain provider? Let's click on change servers. This is my local. As you can see, it is successfully changed, and we are using our different name servers. Finally, if I go back to my route, you can see that we successfully created our zone, and this is now connect with our domain name provider. So we are using www.cloudlab.best, and this is my domain name. Now that we know how can we connect, first how to create our public hosted zone, and how can we connect these zones with our domain provider, let's see how can we make our first record set. As you can see in this orange button, if I click here, there is another option to create a quick record. So if we want to create a record for the root domain, you will leave this blank. On the other hand, as you can see, we can add our record name and choose as our subdomain. And when you create this record set, for example, let's try some random name and .www.cloud.best, we can choose our record type. And I already talked about record types. For example, A record type, single A, routes traffic to an IPv4 address and some AWS resources. I will use this record type for now, and here I need to tell some random value. This random value will be some IP address. This will be 12.34.56.78. Here I can choose my time to live, and routing policy, you can choose a different route policy. We will, for example, use our simple routing, and just like that we will create our record set, and you can add another record if you want. And let's hit on create a record set, and here it is. We created a record set. As you can see, type is A for IPv4, alias, we don't have any alias, and you can see that this is the subdomain dot the domain name that we registered. And finally, as you can see, it has its own value, and what is the value of time to live. So this is how can you create your record set. And now, for example, if I open my Cloud Shell, let me just wait for our terminal to be ready, and finally we are ready. And here I can see or check my IP. Let's find our, first we must install the appropriate program with a simple command. If your command is not found for nslookup or dig, you can simply type sudo, this is just a super user, yum install -y for yes, bind -utils, and as you can see, we are just installing our utilities. And after some time, it is complete, this installation. And after some time, if we try, for example, nslookup or dig command, we will be able to use this feature. And this is a very important feature if we want to check your record sets on your public host zone in your Route 53. Let's now try to run some of these commands. So in this chapter we talk about record set. I showed you how can you create your record set, how can you install your utilities, and I will now copy my record name. There is a random, you can add whatever you want for your record set name. I will paste this here and type first, I will type nslookup, and I will of course paste here and hit on enter. As you can see, this is our server name, what is the address, and known authoritative answer. So we are getting our name and address. This is our value that we added, that we specified when we created this first record set. So this is how can you check this record set with your nslookup command, and simply run this nslookup and the name of your record set or record set name. Finally, we will run dig command, and I will copy exactly the same record name, and if I hit enter, you will get more informations about this record set name. You can see what is the global option, header, opt protection, UDP. This is our record set in a record set, and answer section you will get our value, and finally how much time or query time do you need to check this answer, and what is the server, when did we do this, and our message size. So with the dig command you you have the opportunity to dig even deeper. And this is very useful when you're working with your record set. So do not forget dig and nslookup command. So this is how can you set up your or create your first record set in your Route 53 service. Thank you, and I will see you in the next chapter. So in this chapter we will create a necessary infrastructure. In the previous chapter we looked how can we, of course, connect our Route 53 with our domain name provider, and as you can see I will use some different region. For example, I will use Europe Stockholm, and we'll learn how to add our record set. I will now create one instance launch one instance in Europe Stockholm region. Here I will add a name for this VM. This will be VM1, for example. I will choose my Ubuntu image 2404 LTS. As you can see here, we will use our T2 or T3 micro. I will proceed without key pair. Here we will allow HTTP traffic from the internet and allow HTTP traffic from anywhere. Finally, our public IP is available, and let me launch my instance. Once again, just to repeat you, in Europe Stockholm. So we're waiting for our machine to be initialized, and then I will try to connect via EC2 instance connect to my VM, and here the first thing I need to do is to update my system with sudo apt update. So we are downloading the necessary packages. As you already know, we are doing this every time. And then I will run sudo apt full -upgrade to upgrade this downloaded packages. So we need to be patient and wait for this progress to finish. And after that, I will run a new command. Sudo apt install httpd, and we are installing simple Apache server on our VM1 that is located in Europe Stockholm region. Simple Apache server, and finally it is installed. If I copy my public IP address and open a new tab, you can see that our Apache is here and it's up and running on our VM1 located in Europe Stockholm region. Then I will choose another region. Let's go, for example, to North California. Let me go to my EC2 service. I will now launch a new instance. We will add a name for this instance. This will be VM2, located in North California, Ubuntu service t2.micro. We are not using our public key, so we are using everything default from VPC to our security group, And finally, if we check our logs, you can see that we successfully install our create our instance, and then I will do exactly the same thing. So let me regroup these machines. I will now wait for this machine to be in the running state, and finally let me connect to my VM2. And here first we need to update our system. Then we will run full upgrade. Let's wait until our machine is initialized and we successfully establish connection. Finally, we will run sudo apt update. We did this so many times. I hope that you are remembering this, or remember this from some of the previous chapters. Finally, we will run sudo apt full dash upgrade. And after this installation or upgrade of these packages finish, we will install Nginx on our second VM. Let's run sudo apt install Nginx. And now, if we copy public IP address of our VM2, you can see it's running, and open a new window, you can see that we have this welcome message from our Nginx server. So in the VM1 that is located in our Sweden region, in Europe, Sweden, Stockholm, we have VM1 installed HTTPD or Apache server, and on VM2 located in North California we have our second machine, and this machine is running, on this machine is running, we are running our Nginx server. Let me go to my search, and I will now create my application load balancer. More about this when we learn about VPCs. I will now create a new load balancer. We will use this application load balancer. Let me hit on create. Here I will add my name for this service, for this load balancer. We will use internet facing. We will use IPv4 option. We will use default VPC in our North California region. Let me choose my US to S, and both of our availability zone is subnet. And here we will now use this default group. You can add another one if you want. So let me check just what group are we using in our North California. So we can add both of our security group just to be sure. And here we are adding our listener routing. Protocol will be 80, port will be 80, and finally we will create our target group. This target group will be, for example, TG group 53. Protocol is HTTP, port is 80, address type is, as you can see, we are using our VPC HTTP1, and finally let's click on next. Here we will add our instance to this group, and finally we will create our group target. And as you can see, I will now refresh this and add our group that we just created. And finally, let's hit on create load balancer. So the status is provisioning, and after some time we will be able to work with this. Let me just copy my IP addresses in some of these notepads. First, I will go to our VM1 and copy the public IP address of our VM1. Let me paste it here in Notepad, and this will be VM1. I will now copy public IP address of our VM2 or VM2 instance. Let me paste here in exactly the same notepad, and this will be VM2. And finally, we will copy a load balancer. Let me just refresh this, but we can copy this DNS name, and let me copy here in the same notepad, and I will add that this is our application load balancer address. So we will save this, and that's it. We created our infrastructure. Just to remind you, we have our Apache that is running on our VM1, and if you copy public IP address of our VM2, we have our Nginx server. And if you copy our DNS name of our load balancer, you can see that is not provisioning yet, because its still status is in provisioning status. But if you check your listeners and rules, you will see that all details about these listening rules. So here, this is our default rule. And finally, if I refresh this, so we need to wait to this load balancer to be provisioned, and then we will be able to see our message. Now that we set up our infrastructure, let's learn what is TTL. So TTL stands for time to live, and in the context of DNS is the amount of time in seconds that a DNS record remains cached on resolver or DNS servers before being rechecked with an authoritative source. Why is TTL so important? Well, it has, for speed of course, higher TTL means the record is cached longer, so that means faster responses. A smaller TTL allows faster changes when you change the site IP address, for example. And for propagation, when you change the DNS record, you have to wait for the old TTL to expire for the new value to be visible everywhere. Example from Route 53. For the domain name of our cloud lab.best, your NS records have a TTL of 17280 seconds, which is 48 hours. This means that when someone queries your name servers, their DNS server will cache the response for 2 days before checking again. So it is good to use this TTL and some recommended scenarios when you often change your IP address for 60 to 30 seconds. For stable website without changing, as you can see, 86,040 plus seconds, failover setups, for example, for 30 to 60 seconds, and testing DNS propagation is around 60 or between 60 and 120 seconds. And if you go inside our Route 53, as you can see, if we, for example, go to create a record, you can add some subdomain name, as you can see, and here, if you create your record, let's add some random name. We will choose our record type to be an A. This is for IPv4, and here I can, for example, add the public IP address of my VM2, for example. I will copy this public IP address, paste it as a value, choose my time to live in seconds. As you can see, I will add, for example, 100 seconds, and here I will create, or you can add 1 minute, 1 hour, 1 day. As you can see, this is the default value, and I can add, for example, 100. Let me hit on create record, and we are creating a simple record for our VM2. As you can see, this is our record name, type is A. I will now copy this record name. Let me open my Cloud Shell once again, and here I can now open my Cloud Shell. Let me just refresh my page. And here we are connecting to our terminal. And finally, I can run NSLOOKUP and the record name of our that we just created. And if I hit on enter, you can see that we have our server address and non-authoritative answer. But if I run dig command with our record name set, you can see that we are getting our information, and here time to live is 88. If you, for example, try again, then time to live will be different. So this is how can you set up your time to live. Now it's 65, as you can see, and if you run again, now it's 61. So, and now I want to introduce you what is a record set in AWS Route 53. We already saw how can we create our record set, but let's go even deeper. In Amazon Route 53, a record set, or more precisely a resource record set, is a simple DNS record that defines how traffic is routed for a specific domain or subdomain. Each record set contains domain name, for example, example.com, a record type like A, 4A's, CNAME, MX, TXT, etc. TTL, time to live. This determines how long DNS servers cache your data, and values like IP addresses, alias or alias, text data, etc. How is a record set created? So, in AWS console, when you create a record set, first you must open your console, go to AWS Route 53, choose the host zone for your domain, click on create record, select the type, for example, A for IP, address, CNAME for alias, enter a value, some random IP address for a record, set your TTL, for example 300 seconds, and save changes. That's it. And here a record is address record. It maps directly to an IP address. This is IPv4. For example, if you have 192.0.2.1 and this is the IP address of your website, for this is example.com, you will be able to set this record. And then you can use it when you want a user who types in your domain to be directed directly to a server with that IP address. What is the advantage of a record? It is fast, direct, without additional lookups. CNAME record or canonical name record, it maps a domain to another domain, not an IP address. This is very important. For example, if you have your example.com, you can use this CNAME record to map this example.net. And as I already told you, if you want to use multiple domains for blog, www shop, to all the point to the same domain, you cannot have a CNAME for the root domain, for example.com, only for subdomains. That means www.example.com and api.example.com. If you go to our Route 53 service, you can see that if you click on create records, we need to add our record name, and as you all know, this only can be our subdomain. I will add our alb1 name for our, we will use then CNAME, and then we will use for a value our load balancer, DNS, as you can see, and this is the address for our load balancer. Let me copy this and I will paste this as a value. If we check this, we will get exactly the same message that is running on our VM2, if you remember. And I will now add this value, choose my time to live, and click on create record. And after some time, as you can see, we have our record set here, and this will be alb1.www.cloud.lab.best. And if I copy this address and paste it in our new browser window, we will get exactly the same message because we are using our CNAME record. That's it. I hope this was helpful and that you get the point. And for example, you can add another name. You can add alb2, for example. Choose our record type as A, and you can use alias, for example. We need to choose our, where do we want to redirect this. Let's choose alias to application or classic load balancer. I will choose my region. This is our North California, if I remember. Yes, you can see that this is active now, and we are using North California. Let me choose my region. I will scroll down and we will find our North California. And here we need to choose our load balancer. Our load balancer is, as you can see, one that we have. And we will use our simple routing, and you can even evaluate target health and click on create record. So we added another record, but this time we are using A type, and I will now copy my alb2.www.cloudlab.best, paste in the new window, and let me hit on enter. As you can see, we will get exactly the same message from our Nginx server. Thank you for watching. Now that you know how to set up all these record sets and all other options, let's now talk about first routing policy. The first routing policy, this is just a simple policy, and in Amazon 53 is the most basic type of routing. It's used when you want the DNS records to always return to the same value, regardless of user location, resource help, or any other additional conditions. How simple routing works. Unconditional does not use geolocation, latency, health checks, or weighted distribution. In one answer, when a user queries a domain, they get exactly what is defined in the record, or the server IP address. This is ideal for simple sites, static resources, or when you only have one server. If we go to our Route 53 service and create a new record set, I will add, for example, simple as our record name. We will use our record set A, and then let me copy my public IP address of VM1, for example. This is located in Sweden, in Stockholm. Let me paste here, and we will add our routing, our TTL, for example. Let me add 225, and here you can choose your record routing. We will use our simple routing. routing policy, and here we will create a record set. If we check our record set name, we can copy our simple.www.cloudlab.best, and if I go to our Cloud Shell, we can use our nslookup or dig command, and let me copy my record set name, and here we can see that all informations, of course, and this is our TTL, and finally what is the name of our server when this is created, and what is the server response. So this is how can you route your traffic to and use a simple routing, as you can see. And as I already told you, this is the best option if you have a simple web server that is hosted on one VM, and you will use this routing method to route all your traffic to this server. And now if I, for example, go to my simple record set, and if I edit this record and add another record, I will now, for example, add my public IP address of second VM or VM2, and let me add here as a value, so you can add multiple values, and we can click on save. We are using exactly the same routing policy, and you can see that we have our values. And if we go again in our Cloud Shell and do exactly the same command, dig simple.www.cloud.best, you can see that we are getting a response from both of our servers, but it will route traffic to the nearest, to this VM1 that we added first. So this is how can you use your simple routing method in Route 53. The weighted routing policy in Amazon Route 53 allows you to distribute DNS traffic between multiple resources based on their weight you define yourself. It is ideal for load balancing, testing new application versions, or regional distribution. How weighted routing works? First, you can create multiple DNS records for the same domain, for example, www.cloudlab.best, or you can add your own domain. You can assign a weight to each other, for example, 70 for first machine and 30 for other one. And then Route 53 use those weights to decide how often to return which record. If you go to our Route 53, and if I go to create a new record, we can add our new subdomain. This will be weighted.www.cloudlab.best. Here I will use my A record set, and in the value I must add my public IP address for VM1, and here I will add my time to live, for example 5, and on the simple route we will now use weighted route. Here we need to provide weight, so each of our record that has the same name and type determines the proportion of DNS queries. And here you can use something called health check if you want, and here I need to add the record ID from our US West load balancer. So let me go to my load balancer, and we are in UE North 1, for example, or you can add this is just a simple ID, so you can type Europe North, for example, and then we can add another record set. This will be weighted again, we will of course use record type A, and here I will use my public IP address of my second VM that is located in North California. Here, and finally I will add my time to live to 5. We need to change this routing policy to weighted, and here we will add weight of 30. And finally, in the record ID, I will add the availability zone of my second VM. So this is US West 1A. And I don't want to use my health check ID. Everything is good. Let's go and click on create records. So we are creating 2 record sets for the weighted policy. Let me just check everything once again, and finally let's hit on create record. We successfully created our 2 records, as you can see, and now we have some new information. In the record name we have weighted. Once again, type is A, and here we have differentiator 70. 70 is for our first VM and 30 is for our second VM. And here you can see that routing is weighted. And you can also see the different public IP addresses or values in that column. I will now copy my weighted.www.cloudlab.best, and if we, for example, open a new tab and paste this, you will see that we will get the response from our VM1 because we added 70%. All this 70% means that 70% of our traffic will be routed to our VM1 that is holding our Apache 2 web server. So this is how can you use weighted option, weighted routing method in our Route 53. If I now go to our Cloud Shell and run dig command and paste this record set name, you will see that our answer is the public IP address of our VM2. So this is how can you even go deeper and dig your information about this routing type. And finally, now we will delete all of our resources that we used in this set of demonstrations, in these labs. So I hope that you're satisfied by these labs, and I really try to show you all the necessary options in Route 53. Of course, this service have a lot more options that just this, but this is the essential ones. Let's go to our Cloud Lab. I will now delete this zone, and first what we need to do is to delete all our records if you want. And if you choose to delete your Cloud Lab, as you can see, first you must delete your records except name servers and state of authorities. Let's go to our Cloud Lab. I will check this box to select all record sets, but let me uncheck our NS and SOA. SOA. Let me click on delete, and as you can see, records are successfully deleted. Now I will go to host zone, and now we can delete our host zone. Let me click delete, and once again delete to confirm this. As you can see, our host zone is successfully deleted. So this is how can you delete your Route 53 record set and this hosted zone. Now I will delete all of our infrastructure that we use in this set of chapters. So we will first delete our load balancer. Let me go to load balancer, and this load balancer is, as you can see, located in North California. Let me go to actions and click on delete load balancer. But first we need to delete our target group. I will first type confirm, and of course when you delete your load balancer it will delete all other things, but let's go to target group and delete it manually. I will now go to delete. Finally, we will go to our security group. We have two security groups. I will leave this security group because maybe I will use them again. And finally we will delete our instance that is located in our, this is our VM2, located in our North California. Of course, once that our VM is deleted, first it will shut down and then it will be terminated. Now let's go to our Europe Stockholm. Let me check my VM1 and let's go to instance state and terminate or delete this instance. So it will automatically shut this machine down and this machine will be terminated. And you can check, we have our security group. I will delete this security group, but as you can see we can delete this because our instance is still in phase of termination. So after a few minutes we will be able to delete this security group. Now let me go to my VPC in Europe Stockholm region. Let me check my dashboard. Everything looks fine. Our machine is terminated in North California. Now we can delete our security group. As you can see, once the machine is terminated, we are able to delete our security group. And then in the North California region, I will go to VPC or Virtual Private Cloud, and here I will just check our resources by region. As you can see, we have only two subnets because this region has only two availability zones. This is our default subnets. And finally, I think that everything looks fine. We are now able to go to our EC2, check our security group, and now we can delete our security group in Europe Stockholm region. It is always good to delete everything that you are using in that particular lab. So as you can see, we successfully deleted all complete infrastructure. And now we have a clean slate. As you can see, we don't have any infrastructure. Let me just go to EC2, to instances, and we don't have any because we are now in our main North Virginia region. Thank you for watching. AWS Global Accelerator is a networking service that improves the availability and performance of applications for users around the world. It achieves this by routing traffic through the AWS Global Network using static IP addresses as fixed entry points for applications in different AWS regions and availability zones. This allows for improved latency and faster application performance, especially for latency-sensitive applications such as gaming or real-time communication. The AWS Global Accelerator is a service that allows you to route traffic to your application using the AWS Global Network instead of the Internet. The Internet can be congested, and the AWS claims that using their private network infrastructure can improve connection speed and performance by up to 60%. The Global Accelerator, or GA, provides you with two public static IP addresses that users can connect to get to the endpoint of your application. The AWS Global Accelerator then optimizes the path from those IP addresses to your application, resulting in lower latency and better network performance. When something goes wrong on the network, Global Accelerator will redirect traffic along a different route to the application endpoints that you have defined, such as application load balancer, network load balancer, EC2 instances, or elastic IP addresses, without the need for the end user to take any action of their part. Then Global Accelerator finds the nearest correct endpoint and routes traffic along that route to reach your application. Whether your users are deployed locally or globally, you will always want them to connect to your application using the fastest, reliable, lowest latency connection, which is something that the public internet may not be able to provide consistently. Because Global Accelerator can detect unhealthy endpoints and replace traffic to the correct option within 30 seconds, it provides a seamless method of ensuring that you have the fastest way to deliver traffic to your application endpoints and resolve issues as soon as they arise. A Global Accelerator for a single region application. This is an option when Global Accelerators help single region application by bridging the gap between local and global traffic. Switching users globally from the internet to the global AWS network bypasses congestion and local outages through a network of over 90 global edge locations that find the fastest route to your application endpoint. And then we have Global Accelerator for multi-region application. When your application is spread across multiple regions, you can accumulate a long list of users facing IP addresses and the ever-increasing traffic routing logic. Global Accelerator simplifies this by providing just two static IP addresses that are broadcast via Anycast from AWS Edge locations, giving a single entry point to your application no matter how many regions is deployed in. When you use the Global Accelerator, you can use the console to add or remove origins, available zones, or entire regions without affecting the availability of your app. If a GA is directing traffic to a region or availability zone that is experiencing an outage, it will find the nearest healthy region or AZ and direct traffic there. Of course, the AWS Global Accelerator uses the AWS Edge network, which has over 100 data centers in 86 cities across 47 countries. These locations encrypt your assigned static IP addresses that point to your application or resource endpoints in one or more regions. Fault tolerance is built into Global Accelerator using network zones. When you create an instance of Global Accelerator, you are assigned two static IP addresses. They are served by two separate network zones that operates in a separate physical infrastructure. If one of your IP addresses becomes unavailable due to a network outage or blocking of IP addresses by a third party, you can switch to an alternate address. AWS Global Accelerator also allows you to enter your IP addresses, or you can bring your own IP as a fixed entry point for your application. You can then use up to 2/24 IPv4 address ranges and choose which /31 IP addresses to use during the accelerator setup process. So we have AWS Global Accelerator traffic number. You can control the percentage of traffic going to a specific region by using GA traffic number. For each region or group or of endpoints, you can set up traffic counter to control the percentage of traffic that is routed to the region. AWS GA continuous availability. AWS continuously monitor to health of your applications endpoints by performing ATP-P or ATP-PS and TCP health checks. When a problem is detected, it responds immediately by redirecting traffic to the correct endpoint, which ensures the best performance and availability of your application to your users. Resistance of DDoS attacks is also built into the edge infrastructure, so AWS Global Accelerator is protected by AWS Shield standard network flow monitoring, and automated protocols to mitigate attacks. Custom AWS GA routing accelerators. So you can use this option and it will allow you to use your own application logic to route traffic to a specific Amazon EC2 instance. A standard AWS Global Accelerator instance will redirect traffic to the nearest available correct endpoint, so you have no control over which EC2 instance will be used exactly, which can be a problem if, say, you have application in different languages that resides in separate instances. To overcome this problem, when you set up a custom routing accelerator, you set up separate ports that map to specific EC2 instances running over the AWS Edge infrastructure, which means you get all the benefits of using AWS infrastructure, not the internet, but retaining precise control over where your application users are sent. The global accelerators provide you with a static, anycast IP addresses that act as a fixed entry point for your applications. These IP addresses are published for multiple AWS Edge locations, ensuring that traffic enters the AWS network as close to users as possible. It provides static IP addresses that remain consistent even when you change or replace your application endpoints. So, online gaming, real-time communications, advertising technology, and financial services all benefit from the reduced latency provided by the global accelerator. It improves application performance for users around the world by routing traffic across the global AWS network. So in the next chapter we will learn more about S3 transfer acceleration. Amazon S3 transfer acceleration is a feature that speeds up data transfers to and from Amazon S3 buckets, especially for long distance transfers using Amazon CloudFront's globally distributed edge location. It uses optimized path and protocol optimization to reduce transfer time and variability, potentially increasing transfer speeds by 50 to 500% for larger objects. Amazon S3 transfer acceleration is a useful feature for businesses that want to speed up the transfer of content to and from S3 buckets. It relies on Amazon CloudFront and Amazon Web Services AWS Network Foundation to route traffic and reduce data traffic variability, making it a good choice for example, apps that use the Amazon S3 card and have users spread around the world. Companies that have on-premises application in distributed location and use the S3 API to store data in a centralized bucket. Any other organization that regularly transfer gigabytes or terabytes of data across continents. The good news is that enabling S3 transfer acceleration is extremely simple. You can activate it from any S3 buckets with a simple click in AWS Management Console. We already saw that. When enabled, an accelerated endpoint for your bucket become available, which you can use with your S3 client tools for accelerated transfers. Also, while the S3 transfer acceleration offers exceptional performance advantages, it comes with a pay-per-use data pricing model. However, given the potential cost saving from data transfer or data processing and improved application performance, it often turns out to be a worthwhile investment. It is used for edge routing, so instead of sending data directly to S3 bucket region, S3 transfer acceleration route data through the nearest AWS edge location, which is a part of CloudFront network. Optimized network path from the edge location, data is then transferred to the S3 bucket via AWS fast optimized network backbone, bypassing potential congestion and latency issues on the public internet. Key benefits is improved performance, faster transfers for larger files and data transfer over long distances, reduce latency, minimize the impact of network congestion and distance on transmission time, increase throughput, potentially higher transmission speed, especially for large facilities. It has simplified deployment, so it can be easily enabled for S3 bucket with a simple click in a console, and it is cost effective. You only pay for expedited transfer, making it a cost-effective solution for certain scenarios. So, when do you want to use this S3 transfer acceleration? You can use it, for example, for distributed user base. When user or application are spread across different geographic locations and need to access data in S3 bucket, large file data transfer, when you work with large data sets that can be benefit from accelerated transfer speed, web and mobile apps. When your app requires fast and reliable uploading and downloading of data to S3, faster transfer, this process results in faster uploads and downloads, especially for geographically dispersed users or applications. S3 transfer acceleration is a powerful tool for cloud engineers who want to optimize data transfer speed to and from S3. Its intelligence routing through CloudFront edge locations and a robust AWS backbone network can significantly improve transfer time, especially for geographically dispersed users and data transfers. If you are facing latency issues or slow data transfer, the S3 transfer acceleration is definitely worth exploring. With its ease of use and potential performance gains, it's an advantage that shouldn't be overlooked in your cloud engineering toolkit. S3 transfer acceleration is a tool for optimizing data transfer to and from S3 buckets, especially for those who need faster transmission over long distances using AWS Global Infrastructure and network optimization. AWS Outpost is another service that I want to present you by only in theoretical part, because it is almost impossible to show all these services in demonstrations. So, AWS Outpost is a fully managed service that extends AWS infrastructure, services, APIs and tools to customer premises, allowing you to run AWS services on-premise in your data center or on-premise facility. It provides a consistent hybrid cloud experience by allowing you to use the same AWS service, APIs and tools both in the cloud and on-premises. You can use AWS Outpost to run some AWS services locally, while also connecting to a wide range of services offered in the nearby AWS region. You can run workloads and applications on-premises using popular AWS services, resources, and APIs. Outposts serve as workload and devices that require low latency on-premises access, on-premises data processing, data storage, and application migration with on-premises system interdependencies. Outpost solution allows you to extend and run native AWS services on your own servers. They come in a variety of sizes, from 1U to 2U server outpost to 42U outpost racks and multiple racks. It allows you to run Amazon EC2, Amazon EBS, S3, container-based services like Amazon AKS, database services like Amazon RDS, and analytics services like Amazon EMR on-premises. You can run, manage, and secure your application on-premises and in the cloud using the same AWS APIs, tools, and security controls. Also, it allows you to control where your workloads are executed and where your data resides, while also using on-premises operational tools for monitoring and stability. It also allows workloads to move seamlessly between the public cloud and the network periphery, allowing you to easily adapt to any regulatory changes. It delivers a truly consistent hybrid experience by offering on-premises and cloud-based hardware infrastructure, services, APIs, management, and operations. It provides a consistent experience for developers and IT operations in on-premises and cloud environments. As I already told you, the AWS Outpost Rack has a form factor of 42 U's, which is the industry standard. It makes AWS infrastructure services, APIs, tools available to virtually any data center or co-location space. For a truly consistent hybrid experience, it provides AWS computing, storage, base, and other services on-premise, while giving you access to the full range of AWS services available in that region. So, servers for AWS Outpost are offered in, as I already told you, in 1U and 2U configurations. They offer the same AWS infrastructure, services, APIs, and tools to local and border locations with limitless space or lower capacity requirements, such as retail stores, branch offices, healthcare locations, or factory facilities. Local computer and network services are provided by Outpost servers. When do you want to use this service? If you want to use for low latency computing, it can help you running business applications where you need them for manufacturing execution systems of MES, high frequency trading, or medical diagnostics when the nearest public cloud servers aren't close enough to meet single-digit millisecond latency requirements. For data residency, There are times when data must remain in a particular country, state or municipality, due to regulations, contracts, or information service or security issues. By using AWS Outpost, you have the freedom to decide where your workloads are executed and where your data is stored. You can also easily switch between cloud and edge locations to quickly adapt to changing regulatory requirements. You can use it for migration and modernization. Migration is challenging for outdated on-premises applications because they typically depend on latency-sensitive systems. It allows you to segment migrations on premises into smaller chunks while maintaining latency-sensitive connectivity between application components until you are ready to migrate. Also, you can use it for on-premises data processing. You can handle data on-premises for use cases such as data lakes and machine learning model training, or set up a consistent hybrid architecture to process on-premises data sets that are difficult to migrate due to cost, size, or bandwidth limitation, and transport data to the cloud for long-term storage. AWS Outpost is suitable for a variety of use cases, including low latency applications, data residency requirements, and application migration with on-premises system interdependencies. AWS Wavelength is an AWS infrastructure service that extends AWS computing and storage services to the edge of telecom operators of 5G networks. This allows developers to deploy applications closer to mobile and connected devices, minimizing latency and maximizing performance for latency-sensitive applications. Essentially, it brings the cloud closer to the user using the speed and bandwidth of 5G networks. Amazon Wavelength allows developers or administrators to create mobile apps with incredibly low latencies. Wavelength has deployed storage and computing resources integrated into Communications Service Provider or CSP 5G edge networks. A virtual private cloud or VPC can be extended to one or more wavelength zones. After that, you can use AWS resources like Amazon Elastic Compute Cloud or Amazon EC2 instances to run applications that require incredibly low latency and connectivity to AWS services in that region. So, key concept of AWS Wavelength is this is a new AWS architecture designed to support mobile network workloads that require extremely low latency. We have something called parameter network group. This is a special collection of zones or wavelength zones or availability zones from which AWS promotes IP addresses. So we have wavelength zone. This is the location where our wavelength infrastructure of the operator's location is installed. Wavelength zones that are connected to the AWS region. The wavelength zone, the logical extension of the region, is controlled by the control plane in the region. And we have something called wavelength application. This is an application that runs in your wavelength zone on AWS resources. So, what is VPC? Amazon EC2 instances are among the resources that are deployed in subnets connected to zones in the client's virtual private cloud or VPC, which is distributed across availability zones, on-premises zones, and wavelength zones. We have something called wavelength subnet. This is a subnet when you create within a wavelength range. One or more subnet that you create can be used to manage AWS service, like Amazon EC2 instances. Then we have something called operator pass. The operator pass performs the two tasks. It allows both incoming and traffic from a specific operator network and outgoing traffic to the internet and the operator's network. Also, AWS Wavelength brings your servers closer to mobile users by placing them within 5G networks, creating a fast, direct route between your applications and your customers. It's like building a mini AWS data center inside a 5G tower, and it enables real-time responsive application in wavelengths. This service, you will start by extending your existing virtual private cloud or VPC. Typically, your VPC is located entirely within an AWS region, such as Mumbai or Ohio or some else. With Wavelength, AWS allows you to extend your VPC into that wavelength zone, which is a small part of the AWS infrastructure housed within a mobile operator 5G network. This means that your AWS environment now can reach closer to end users without having to cross the public internet, reducing latency. You can still manage in the same way as any other AWS network, but now this network is a part within this mobile network. In cloud integration, synchronous and asynchronous communication are different approaches on how applications interact. Synchronous communications is a pattern of requests and responses where the sender waits for an immediate response for the recipient. Asynchronous communication, on the other hand, allows the sender to proceed with processing without waiting for a response, often using message queues or other mechanism for final delivery and processing. So, synchronous communication. In this kind of communication, the calling application send a request and wait for a response for the receiving application before continuing. Features here is real-time interaction. It is suitable for scenarios that require instant responses and a strong connection between systems. Easier error handling. Errors are easier to identify and process because the response is instantaneous and it has potential for delay. If the receiving app is slow or unavailable, it can cause delays in the calling app. Example is a user submits a form on a website and waits for the confirmation page to load. Some of the use cases are access to data and real-time updates, orchestration of dependent tasks, maintaining the integrity of transaction when the current feedback is critical. Then we have asynchronous communication. In this second kind of communication, the calling application sends a request but does not wait for an immediate response. It continues to execute and later process the result. Features are distributed system, so systems can operate independently, improving resiliency and scalability. Also, if the recipient is not available, the sender can still work and the message will be processed later. Also, it requires mechanism for managing messages, handles features and tracking progress. And finally, some of the example is sending an email, so the sender does not wait for the recipient to read the email. Use cases: event-driven architectures, background task and processing of large volume of data, and when immediate feedback is not necessary. Also, it is good for split microservices, and that's it. How to choose or what integration or communication to choose? Well, if you choose between latency requirements, if the low latency is crucial, synchronous communication may be preferable. If latency is acceptable, asynchronous communication can offer better scalability and resiliency. For simple, straightforward tasks, synchronous communication can be simpler. For complex tasks, asynchronous communication may be more suitable. Then, if you talk about system dependencies, if a system are tightly connected and require real-time interaction, synchronous communication may be necessary, but if system can operate independently, asynchronous communication offers greater flexibility. Fault handling and tracking. Asynchronous communication often requires more robust mechanism for handling and tracking errors, and asynchronous communication generally offers better scalability and availability due to its decoupled nature. In short, both synchronous and asynchronous communication have their place in cloud integration. The best choice depends on the specific requirements of the application and the both characteristics of the integrated systems. Sometimes a hybrid approach that uses both synchronous and asynchronous patterns can be the optimal solution. So, this cloud integration is added to this section just for the future section, so for you as a learner or student to better understand what kind of communication that we have in cloud. First service in AWS that I want to present in this section is AWS SQS, or Amazon Simple Queue Service. This is a fully managed service or queue service that separates and scales microservices, distributed systems, and serverless application. It allows you to send, store, and receive messages between software components at any scale without losing messages or having to make other services available. Just a little note. I know that some of you will tell why I didn't put all Azure messaging system or pub subsystems services in this sector. I didn't want to confuse you with these monitoring services, and these all Azure resources or services will be available in later section. So we will now continue with AWS PubSub messages services, and we will later deal with Azure offering. So as I already told you, this is a fully managed message queue service, and SQS provides a web service to applications that help to quickly and reliably put messages in order. These messages have a single component in their application that generates only when they need to be used by another component. Therefore, the queue is a temporary repository for messages, and these messages are waiting to be processed. So, when these messages are processed, they are also deleted from the queue. The AWS SQS service basically adds a message to the queue, and then users will retrieve those messages from the queue. A queue is a place where you can store your messages until you unqueue or expire. Full form Amazon SQS is a simple order service or simple message service. It is a fully managed service by AWS itself and will take care of all aspects such as hardware provisioning, maintenance, and scaling. AWS SQS provides communication in a distributed system or application. Applications running in the cloud will be distributed across the different servers, so they need to communicate with each other. SQS or simple queue service is standard offer message-based asynchronous communication between two services. Before SQS, communication between two services was based on API calls, and after SQS, the event maker notified the user in an asynchronous manner. The messages that are in the queue are in the form of JSON format, JavaScript object notation, and the queue is a pool of messages that limit each message. So one message is 256 kilobytes per message. Publishers will post message in the queue, and messages are processed or removed with the help of the user. So this service allows you to send message, store message, and receive messages between different software components in any quantity without losing the actual message. Also without the need for any other service to be available. So basically, Amazon SQS is a distributed queue system. Rows are used to store textual information so that the consumer can receive and use it later. A customer is something that gets a message out of order. This can be anything that is capable of making API call to a SQS. For example, application, microservice, human or person, etc. Using this paradigm, we implement separation. Separation allows for later processing of incoming requests. So when a consumer is overwhelmed, he waits before getting another message. In this way, our application becomes more resilient to errors. Amazon Simple Queue Service is a fully managed queue service in AWS Cloud. Then, in a distributed messaging system, these are three basic elements involved. The system components, then the queue, which is distributed across Amazon SQS servers, and the message stored in the queue. In this scenario, your system includes multiple producers who send messages to the queue and consumers who download messages from that queue. Here's how this works, or how to use SQS. We have something called batch processing. SQS is typically used to manage workloads that require data processing. The queue can be used for scenarios such as data transfer, images processing, and report creation, as manufacturers can add tasks to it and consumers can download and process them simultaneously. Then we have separate microservices. In these architectures, services must communicate with each other asynchronously. SQS allows services to send messages to each other without needing to know the recipient's details, allowing for a loose connection between the services. Then we have order processing. For e-commerce platforms, SQS can be used to manage order processing. When an order is made, it can be added to the queue, and multiple workers can produce orders in parallel, ensuring the timely fulfillment of orders. And we have notifications. SQS can be used to send notifications or alerts to different parts of the app. For example, an event that occurs in one component can post a message to an SQS queue, which can then be processed by other components for notifications, logging, or a real-time app. There are only two types of queues in SQS. First is first in, first out, or FIFO. In the first in, first out, or FIFO queue, the order message is stored. So if you receive a message from the queue, you will get the oldest message. The line also ensures that the message will be delivered only once. Key features of this FIFO order you can use for edited processing, so messages are always processed in the exact order in which they are sent. Each message is delivered only and exactly once, preventing duplication. FIFO rows allow you to define group of messages, so it is good for message grouping, ensuring that related messages are processed in order while different groups can be processed simultaneously. Some examples of this use for banking transaction, ensuring that debts and accounts receivable are processed in the correct order, inventory systems where they are necessary to update the inventory levels in order, and workflows where tasks must be completed in a specific order, such as video rendering pipelines. And the second one is standard queue. So standard queue messages in this row or queue are delivered randomly. Also, the message can be delivered multiple times. Therefore, one should not rely on sequencing and only a one-time delivery in this type of queues. Key features of the standard order. Standard queues can process a virtually unlimited number of transactions per second. Although SQS try to maintain order, messages may be delivered out of order. Delivery at least once. Message can be delivered multiple times, so it is essential to have idempotent message processing logic. Example for use cases: real-time data entry, so you can use this for quickly log or collect metrics. Task processing, such as images processing job, where the order of task does not affect the outcome, and for notification system, where notifications can be sent in any order without affecting the user experience. Finally, as you can see in our table, in the first step, component 1 send message A to the queue, as you can see, and this queue will be stored in some of these objects. Then component 2 retrieves message A from the queue, and the visibility timeouts periods start, as you can see. And finally, in the third step, component 2 process message A and then deletes it from the queue during the visibility period, timeout period. So that's the whole point of this AWS SQS. Once again, we are in our portal and I want to log into my console using my root user signing. So I already add my password. Now I need to provide I already enter my username, my root user sign-in, and then I will enter my password. And finally, I will add my MFA code from my phone, from my iPhone, where I use my OT app. So let's add this MFA code, and finally we will be able to sign into our account on AWS. And as you can see, I can now go to my search bar and search for my SQS service or simple queue service. You can see that we have some cost usage for this month. And finally, let me type SQS in the search bar, and we are now using our simple queue message service. If we scroll down, you can see how it works. We already explained in our theoretical part how it works and what offer does we have. You can see that EMS and NASA using this service, and you can see what is your pricing. All customers can make 1 million Amazon SQS requests for free each month if you have opened this account before July the 15th. And if you want to create a queue, we have two types of queues. You already know The first one is standard and second one is FIFO, which stands for first in, first out delivery. Message ordering is preserved. So you can choose between these two types, and one that you choose your type, then of the queue you can't create this. So I will add a name for my queue, and this is the default configuration. How much you can set the maximum message size, visibility to other consumers, and message retention. So visibility is, for example, 30 seconds. You can also add your delivery delay of this message, and receive message, what should be the receive message wait time, for example, from 0 to 20 seconds. Also, visibility timeout can be up to 0 seconds to 12 hours. And delay, you can delay message between, choose this delay message, delivery delay between 0 and 15 minutes. Then, how much do you want your retention period of this message to be available? You can choose between 1 minute and 14 days. By default, it is 4 days. And finally, this is maximum message size. You can choose between 1 and 256 kilobyte. By default, it's already set up as maximum value. Then for decryption, you can use two types of decryption. We have first enable encryption by default, and you can use Amazon SQS, and this service can create the encryption key and will do all the rest, and then AWS key management if you want to use our KMS service. Then we have access policy. As you can see, you can define who can access to this queue. This is a basic and advanced. So you can use a JSON object to define an advanced access, and this is a simple read-only basic, as you can see. So only the group, only the queue owner can send messages to this queue. If you choose another one, for example, you can define who can receive this message, so only the queue owner can receive message. I will leave everything as it is, and finally we can add this option to set if you want to know what is a dead letter queue. If the message can be consumed successfully, you can send it a dead letter queue or DLQ. So dead letter queues let you isolate problematic message to determine why they are falling. And that's it. Let's hit on create queue to create our queue. And as you can see, this is a very easy to set up, and it's already provisioned successfully. And here you can see your name, type, queue policies, monitoring, what is URL for this queue, and we don't have any letter queue. So you can also use monitoring to get detailed monitoring in these graphics. So we have subscription. You can subscribe an Amazon SNS topic. We have something called Lambda triggers. We have event bridge pipes. Dead letter queues will be added here. You can use tagging, encryption, and dead letter queue red drive task. So this is our queue policy, and also you can click on send and receive message. So in this wizard you can send message, but first you must add a message body. So let me type something, and finally you can click on send message. After some time, if I scroll down, you can see that we have one message available, and polling duration is 30 seconds, and this is our message. As you can see, our message has been sent and is already received. If I change this and send again, you will see that we have two messages that is available for us. Let's send another message, and here it is, message is available. So you can see how it's easy to create this. Let's see poll for message. So we are polling our messages, and this is our message. This is our message ID. When this message is sent, what is the size of our message, and receive count. So if you type of one of this message, you can see what is the body, attributes, and details of this message, when it's sent, when it's first received, MD5 a message body, sender account ID, this is our account ID, and that's it. And polling process is, you can see how much messages are added here. For 30 seconds our message poll, you can change this maximum to message count 1 and how much in seconds can this polling, to set up this polling duration between 1 and 99.9, and exactly the same values you can do for maximum message count. So by default is 30 seconds and 10 message. And that's it. This is the most basic demonstration how can you use SQS. I will now delete my message and clear all content. Let me go to my demo queues and I will now hit on delete. Let me type confirm and I will delete this queue. Thank you for watching. If you type SNS in our console search or search in our console, you can see that we have this simple notification service. And we already know what is SNS because we take a deep dive in our theoretical part. If we go inside that service, you can see that we don't have any topics or platform applications. If you go to topics, we can create our topic. Let's hit create topic. And also you can use between first in, first out or standard. So standard is best effort for messaging ordering, and FIFO, first in, first out, is strictly preserved message ordering. So if you choose standard, you have an option to add your name. So I will add, for example, my topic, and here we can only create this topic. Of course, there is additional or optional but we don't want to use that. And now we can create our subscription. You can see if you choose, for example, one of these service, we can add this subscription. For this I will use email JSON, or you can use HTTP, HTTPS, platform efficient, or SMS. If you choose your SMS, your endpoint, a mobile user, can add this number. So you have option to add your phone number, and you can only deliver SMS to the sandbox destination before you add this. And now I want to add my email, for example. Here I will add one of my email, and finally I will check create my subscription. And that's it. This is how can you create a subscription using your endpoint. My endpoint is my email address, and status is pending confirmation. Protocol that we are using is, of course, email. As you can see, this topic we already created, and if I go to my email, there is an option to confirm subscription or visit link below. If I type this link below, as you can see that subscription is confirmed and I am successfully subscribed to this topic. So as you can see, this is my subscription and status is confirmed. So I will now delete my email in this topic, and when I delete this topic, everything else will be deleted. But for now I can publish my message. So here I will add my subject as optional. For example, I can add my name, for example, some random name, and here I will use identical payload for delivery, and this will be demo message 1, for example. And finally, let's hit on publish message. So as you can see, we published our message, and this is a standard type. As you can see, we are using my topic. You also have push messages and text messages, but we need to add our phone number. And now if you go to our dashboard, you can see that we have one topic and one subscription. If you go to our topics, this is our topic. And if I check my email and click on publish message, I will be able to publish this message, and if you check your email, that message will be here on your email. And I will now delete the whole infrastructure that we created with this SNS topic. So this was just a simple demonstration of how can you use Amazon SNS topic, but this service is very useful, and we will see when we talked about Lambda service. Thank you for watching. Welcome back. The next service that I want to present you is Amazon MQ. But before we continue, I want to just take a little note. It is really impossible to show all these services in some kind of lab or demonstration. So in this section we will mostly learn only theoretical part. And the first service is Amazon MQ. This is a managed message broker service provided by AWS that simplifies this setup, operation, and maintenance of a message broker for cloud application. It supports popular messaging systems such as Apache ActiveMQ and RabbitMQ, allowing users to migrate existing applications or create new ones with minimal code changes. The broker is an environment for message brokers that run on Amazon MQ. It's a basic building block of Amazon MQ. A message broker allows software applications or components to communicate using a variety of programming languages, operating systems, and formal messaging protocols. You can use Amazon MQ brokers to communicate between large cloud-native applications and components. What is the feature of this service? So, it manages maintenance and version upgrades. Amazon MQ performs maintenance and version upgrades for the message broker during your scheduled maintenance period. You can also track brokers with CloudWatch. Amazon MQ is integrated with Amazon CloudWatch, so you can view and analyze metrics for your brokers and queues. You can view and analyze metrics from the Amazon MQ console, CloudWatch console, command line, and API. Metrics are automatically collected and sent to CloudWatch every minute. Then, when we talk about security, Amazon MQ provides encryption for your messages at rest and in transit. Connections to the broker uses SSL, and access can be restricted to a private endpoint within your Amazon VPC. In addition, you can use AWS Identity and Access Management, or IAM, to control the actions that your IAM users and groups can take on specific Amazon MQ brokers. Also, you can use Quorum Queue for RabbitMQ on Amazon MQ. Quorum queues are a replicated type of queue composed of a leading node, this is our primary replica, and trailing nodes, other replicas. Each node is located in a different availability zone, so if one node is temporarily unavailable, message delivery continues to the new selected replica of the leader and in the other availability zone. Quorum rows or queues are useful for handling poison messages which occur when a message fails and is re-queued multiple times. Also, cross-region data replication for ActiveMQ on Amazon MQ, so you can use this CRDR enables a synchronous replication of messages from the primary broker in the primary AWS region to the replica broker in the replica region. By issuing a transition request in case of cancellation to the Amazon MQ API, the current replica broker is promoted to the role of the primary broker, and the current primary broker is demoted to the role of the replica. Finally, Amazon MQ handles the infrastructure and maintenance of the message broker, so users do not have to worry about core server setup, patches, or upgrades. A message broker acts as intermediary between applications, allowing them to communicate asynchronously through messages, and this allows for application separation and improved scalability. Amazon MQ currently supports Apache MQ and RabbitMQ and standard APIs and protocols. There is a support for a variety of standard messages, API and protocols, including JMS, NMS, AMQP, STOMP, MQTT, and WebSocket. Also, you can migrate Amazon MQ, and it makes easy to migrate these existing message brokers to the cloud or migrate applications that use message protocols. Also, when we talk about scalability and availability, Amazon MQ offers a variety of scheduling options, including single instance configurations and active standby configurations for high availability. It is cost-effective, so you will only pay for the resources you are using without a pay-per-use pricing model. In the next chapter, we will talk about what is AWS